Good morning to everybody.
Very good morning, sir.
All is well?
Yes, sir, all set.
Thank you. Thank you.
So we are already in live. I mean, not streaming. So at
Okay.
9:30, when guests come, we will go live on YouTube.
Okay.
So we are going live now. Good morning to one and all, and I welcome everyone to this year's Digital Kid Zone, initiated by Science for Rural India, a science outreach group at IISc. Science for Rural India, or SFRI, began in 2016 as a group of like-minded students keen on contributing to the betterment of science education in rural India. For the past 5 years, as a team, we have reached out to many government schools in and around Bangalore, demonstrating simple science experiments in an unconventional and thought-provoking way. As a part of IISc's annual open day, we created a platform called KidZone to invoke curiosity for science among the budding minds of our country. This year too, we are here to bring you the 5th edition of KidZone digitally. We now request Professor Anil Kumar, Dean of Administration and Finance, IISc, to give the welcome note.
Thank you. First of all, let me congratulate the students of IISc for initiating this very noble cause. I vividly remember a few years back, Professor Guru Rao and other dean was also contacting me when I was the associate dean of the undergraduate program and explaining about the need for this kind of experiments. Since then, the undergraduate program of IISc was also very actively participating in the KidZone. So usually we have the open day where thousands of kids and college and school students come to IISc, and the KidZone is a very attraction because this is really connecting to them. And so in that regard, this is a noble cause, and now it is going digital. That means it's becoming pan-India. And I welcome all the participants who have registered for this program to this event. Let me welcome Professor Rangarajan, Director of Indian Institute of Science, to this program. And we have Professor Anil Sahasrabudhe and Professor H.C. Verma for this program. So they will be joining us soon. And let me welcome Professor T.N. Guru Rao, the former Dean of Science at Indian Institute of Science. He was also encouraging the students to come up with this kind of programs. And IISc students always find very innovative ways of reaching out. I mean, there are many programs at IISc, the notebook drive. The KidZone is another in that round. So with this, let me welcome all of you to this program. And now may I invite Professor Govindan Rangarajan, Director of the Indian Institute of Science, to give his inaugural speech.
Thank you, Anil. It's a pleasure to be part of this very innovative and very welcome program, the Digital KidZone 2021, and also to formally, inaugurate it. As Anil Kumar was saying, it's really very nice that the students have thought about this program. IISc has always been very interested in various outreach programs. So Anil Kumar already mentioned about the notebook drive, which has been helping kids, in many schools. In addition, our faculty have been going and lecturing students in various places around the state and across India. They've also been actively taking part in Inspire camps where they again address 500 students at a time on various science subjects. And in addition, so that is on one side on the direct contact with the students. Also, on the other side, we have the teacher training. We conduct a very successful teacher training program in Chelakere, where you are essentially training the trainers, so that you have this multiplier effect. Each teacher can then go ahead and train thousands of students over her or his career. So there we have trained more than 13,000 teachers across the years, and it's going on, it's expanding into other areas. So those are two aspects, where, one is where we train the teachers and where our faculty members have been going and teaching students, giving lectures to students, sometimes, often in vernacular language and so on, which has been very helpful. But what the students have added now is a very welcome new dimension. Because when faculty members go and say something, there's always a distance, especially in the Indian context, between the teachers and the students. But when students go out and say the same thing, and then the school students are much more connected to all of you. So therefore they are able to relate much more to you. They are also less hesitant to come and ask you questions when they have some doubts. So these are, I think, very welcome aspects which will really enhance this program, which whatever and however friendly faculty may be, but they can never replicate the closeness that a school student will feel to some of you, since you are also students. So I think in that sense, it's a very innovative program, and yeah, you have been doing it offline earlier and now doing it online. This definitely allows you to reach out to a much wider audience, and there's no real need that this has to be restricted to India, the registration. After all, there are many students, very underprivileged students in all parts of the world. So one can in fact at some point open it up to the entire world and let students from all across the world participate. There is no harm in doing that. Let them, everybody gain knowledge from all of you. I think, you should at some point think about that. And right now, from what I saw is that you are demonstrating the equipment, the experiments, and students are learning from that. At some point, technology is also progressing rapidly. At some point, I think you should probably transition to a stage where you can virtually, the students are able to virtually run experiments, and see for themselves what happens. So that should be also be one goal that you can aim for. So with these few words, let me welcome all the participants to this workshop. This is a wonderful initiative, very welcome initiative on behalf of not part of the students. And with these words, let me formally inaugurate this program. Thank you.
Thank you for your words, Professor Rangarajan. We thank Professor Anil Kumar also for inaugurating the event. The successful activities of our group have been solely possible due to the active participation of its members, as well as many key contributors who have provided us with unconditional support throughout this journey. To name a few, we have Professor Guru Rao, whose positive encouragement to our group has kept us going through all our ups and downs. Mr. Veeranna, Deputy Registrar Public Relation IASC, who has always motivated the activities of the group and has generously helped us a lot in arranging the Kids Zone event every year. Mrs. Kavita Harish, who as a part of Office of Communication IASC has provided us with significant support, helping us in reaching out to many people in and outside the campus. Our group is always grateful to all of your contributions. I would now like to request Professor Guru Rao to address the audience.
Good morning, everyone, and it's a pleasure to be a part of this meeting, and particularly to see my good friends, Anil Kumar and Rangarajan. It's a pleasure to see you guys after so long, and I feel at home almost immediately. And of course, any event, whenever it takes place, it has its own history. And the wonderful aspect of this particular program seems to be that it is coincident with Teachers' Day. And it's very significant. I noticed that the kids have planned, our kids have planned for the younger kids, the program on a Teachers' Day. So I wish all of you, all the teachers, a very happy Teachers' Day before I go further. Well, it is an interesting historical journey this particular Kids Zone had. When a group of students, Suyog, Ashok and others, when they approached me when I was the dean, that's exactly 5 years ago now. And at that time, things were not so very conducive in the sense of the situation associated with starting something new in the institute. Anything to start new in the institute has to go through several procedures. So in fact, the engineering dean who was associated with me initially was not very supportive of this particular initiative. But then I had to persuade him And then once he accepted, I think most of the way was very smooth, because Anurag Kumar, the previous director of the institute, was very positive. And in this context, the students were very lucky to have director's approval almost immediately. Just like now, Rangarajan is encouraging this particular meeting. So, it is a pleasure that IASC, despite being what is called the ivory tower of India, #1 institution and all that, has these initiatives which are remarkable, and they sort of go unmentioned in some sense. And it is important that we recognize these. And I'm very happy that this meeting is going online. And as Anil mentioned, that it is going pan-India is a remarkable thing. And congratulations again to the students who organized this. And the very first Kidzone meeting was quite interesting, because something like 1,500 students visited on one day, which was our open day. And there was a separate pendal set up for kids. And all these experiments were made and performed in front of the kids. And they were quite excited about seeing how the volcano erupts, and people trying to explain how the brain works. And it was a remarkable event. And it so happened that it picked up over the years. And now I'm very happy that the digital platform is now available. And as Professor Rangarajan mentioned, these are now experiments which can be demonstrated online. And the students can put their hands together and perform the experiment hand in hand at home, which is a remarkable thing. So in some sense, the rather irritating pandemic has also helped in improving teaching methodologies. And in that sense, in fact, even some of us are still teaching courses in the institute online, and that is remarkable. So pandemic has had some advantages, whatever that is, particularly from the teaching initiative. So this event, which is now going to be also addressed by some very eminent personalities, has been a gift which is given to the younger kids. The whole idea is to reach rural areas, and because we do find that if I take the statistical analysis of the performance of my own students in the PhD program, I find that out of the 35 or so who graduated with their PhD degrees, more than 20 are from rural areas. And this is amazing. This is something which, we don't see that many IIT students get into the PhD program so easily. And with the start of our undergrad program, which was actually spearheaded, one of the important people in that is Anil. So when all these things started, I think IASC has really blossomed into a supporting, what should we say, a banyan tree under which these children are now getting educated in some sense. And this particular program is going to reach the rural areas. And I'm very happy to also say that they have already reached several rural schools. We must recollect here the help rendered by Virana and Kavita, and also the group from KSCST, who actually organized children to come in for our open day. They organized buses to bring children from rural areas. And they also arranged rural programs where our group of people in this program went around. And then it has been a remarkable journey altogether. And I have been very happy to be associated with it. I always want the rural education to improve. And with the NEP 2020, the National Education Policy 2020, it looks like it is going to blossom further. The idea of online training and the idea of skill development. In fact, I must mention that is already in the syllabus of our institute. We have the Chalakere Center, where we have a skill development and technology development and so on. So with these historical plus some of my own comments together, I wish this program a very big success. And I'm sure the Kidzone will be supported fully by the authorities of the institute in the future. Thank you very much.
Thank you very much for your words, Professor Gurra. Today we have among us an honorable guest, Dr. Anil Sahasrabuddhe, the present chairman of All India Council for Technical Education, AICTE. Graduated from BVB College of Engineering and Technology, Hubli, Karnataka, with a gold medal in bachelor degrees in mechanical engineering, he obtained his master's and PhD from IISc Bengaluru. He was a member of faculty at IIT Guwahati, was a lecturer at NER IST Itanagar, and served as the Director of College of Engineering, Pune from 2005 to 2015. Among the many awards and fellowships he has secured, Jeevan Gaurav Puraskar, Lifetime Achievement Award of MIT World Peace University, Gandhian Peace Award of CSR Times and Indian Achievers Forum are a few. His view on the need for outreach in developing countries like India and the role that we as students from a science institute could contribute over large scale have always been an inspiration to us. I now welcome Anil sir and request him to address the audience.
Thank you, Aditi. Good morning to all of you. Namaskar. Professor Govindan Rangarajan, Director of Indian Institute of Science. Professor Guru Rao, who has been passionate and driving this kind of initiative in IISc long time ago. Mr. Soyag Mahulkar, who was after me, that there were a lot of programs today, but I made my way into this particular program, which is very important. Mr. Anil Kumar, and most importantly, Professor Verma will join. And I think one of the finest physics teachers from IIT Kanpur, and whose books are read by all people who write JEE exams, actually. I think he will also be there. Young children, who are all associated with this Digital Kids Zone 2021, and teachers, because on the Teachers' Day, this program is being arranged. And my greetings to all the teachers and all the students also, because students are going to be the teachers. You know, many times these days in our classes, students become our teachers, teachers, because they are having a lot of information from the net. They bring a lot of value to the classroom. So I think they are also teachers in some sense. I am really appreciating this initiative of Digital Kids 2021. And I recollect my days from 1980 onwards for about 7-8 years. Partly I was out for being in a job, but again came back. But necessarily the issues of what we say rural development was always at the core of the heart. So we had a discipline or what we call interdisciplinary center, ASTRA, and the KSCST jointly used to have a lot of programs in villages there, and that was always significant that we want to bring in value to the education of the children from the rural areas. We also have Open Day, March 3, and I remember that every year we used to have a Founders Day on which all laboratories were kept open, and even as student of masters, because we are all from some other discipline. So when we visit, say, high voltage engineering department, and with the two large spheres with high voltage, and then when the distance is reduced, how the the spark is created or what lightning is created, and what is similarly happening in the sky. You know, that is so invigorating for children to understand those laboratory experiments. And therefore, the science demos, not only in the institute laboratories, but taking them forward to students in terms of reaching out to those villages, not just bringing in buses, but buses being taken to the villages must be the next alternative, because ultimately we have a limitation of number of students we can bring into the campus. But if we have a bus which has all variety of such, what we call experiments which are exciting for students, and take the bus to several villages in the neighborhood, I think that would be more invigorating, and this should not be very difficult, and many institutions are doing already. And Indian Institute of Science has all the capability of doing this. I'm very thankful to many others actually who have changed the scenario in terms of children learning science. We always talk about scientific spirit of inquiry, but through not only experiments which are conducted in the institute like IIT or IISc or any other university, most important thing is at very low cost with household things, how experiments can be conducted and shown the physical principles of science. So that is very, very important. And one of the objectives of digital science outreach of Digital Kids Zone is to have very low cost household thing usage and then creating experiments out of that so that they can do at their own homes and houses these experiments and also tell their younger siblings. That is what is really developing the spirit of inquiry, spirit of science amongst our students. But I recollect here two people who have done extremely well in this domain. One of them, you all are aware, Arvind Gupta, and a graduate of IIT Kanpur, mechanical engineering. But he was motivated when he was a student. He graduated in 1975. And then when one of the programs, he got connected with how we can really develop our children in terms of learning. And that is where, that was their seed in his heart and brain. And when he went to telco in Pune for some time, couple of years he did job, and then he left the job, and he has dedicated his entire life for creating these toys, toys which are scientific, to understand various principles. And he has been doing it from Ayuka in Pune, and I had several interactions with him, and used to call him to the College of Engineering Pune, to even engineering college students, to understand the nuances of some of the science experiments. And all of them are using absolutely simple trash there at home, be it to have use of air, water, liquids that are there already at home, how you make use of them to understand density, specific gravity, biology in terms of the lung power. You blow into a balloon or a tube and then find out what is the volume that you can have in your lungs, and you can bring it out. What is the pressure that you use? I think all variety. And another interesting experiment to tell about concavity and convexity, he used to use the wasted slippers. We remove those where we put in legs, and they are all old chappals. You bend them and show that this is concavity, this is convexity, how rays will converge or diverge from out of that. And that is what we do in an experiment with a lens, and then solar power is concentrated, and you can burn even paper or mastic by using a lens. So all of this through very, very simple experiments, be it the force. Many times, many of the scientific principles are difficult to enunciate. For example, you define a force, that's fine in physics, but we don't see the force. We only see the effect of the force. And that's why, to explain such principles, variety of usage of routine matters, spinning toys, you tell about what is centrifugal force using spinning, that we call it in Canada, or toy, which is there in commonplace. And then the higher levels, actually in terms of whether it is pump, electric motor, electric generator, all of that can be showcased using simple experiments. And then the biology is very, very important. In fact, the connect between human physiology or anatomy with various higher level things that we do study in computer science or in mechanical engineering or in electrical engineering, they can all be the functioning of the brain, the heart, the lungs, the kidney. The human body itself is an excellent experimentation tool. And that's why, in fact, amongst all the institutes in the country, I'm very proud that in way back, I'm talking about 2006, a mandatory biology course was introduced in engineering program. And everyone was watching, what is this? We left biology in the 10th grade, and 11th, 12th, we took only physics, chemistry, maths, because we wanted to come to engineering. And why is it this biology being introduced in engineering curriculum? And then we had to, because there was so much opposition from students for study this course as a credit course, a 3-credit course with laboratory. And then I said, we will call it as a different name. We called it as living machines. Then they thought there is something engineering, machines are involved, and then started learning. Then we told them the brain, which has the power of computing, storage, which is nothing but computer science in some sense. The heart, which purifies, the lungs, which take in oxygen and then make use of it to purify the blood. All of these are not only various what we call chemical equipment, or maybe in terms of mechanical engineering, purifying, which happens in the kidney. Then they started getting excited. And behold, one of the first Microsoft Challenge Award, which is for innovation, the students who studied biology in their first year of engineering, they created a parallel computing algorithm using biological principles, and they won the first prize of the Microsoft in Innovation Award. So I think there are a lot of parallels that we can draw from all of this. And more importantly, although this particular program, you are saying that it is Science for Rural India group, but I think it is more important and more necessary for our city students. I will come back to that. Because the villagers, they have a very strong power of observation, which our city guys have all lost it. We all stay in many times flats and buildings, and many of our students from metros, probably they do not know how the potato is grown. Maybe they will think that it is also a potato plant, fine. Sometimes they will say that it comes from a cooperative store or a department store, but otherwise, even if they understand that it is an agricultural product, they will think that it comes overground. They don't know that it is a root. Some of these guys are so foolish actually, because they are not observing, they have not seen it. And that's why village guys, they are in the midst of nature. They see the environment day in and day out. Probably the spirit of inquiry, scientific spirit is more in village students than in city students. The only difference is probably they don't have exposure. They have not seen high-end equipment. That is their problem. That's why how some of the bright students from villages not only are trained there through, as I said, taking the bus there and showing those experiments, but maybe during vacation bring them to institutes like IISc for 15 days, and they will go around different departments. I think they will get excited, and the nature of their observation power, the 5 senses given by the God. You know, today we talk about Internet of Things, machine learning, and AI. But all of that is embedded in our own 5 senses. You know, ears for hearing capability. We will come back to the sound later, whatever is required. Then eyes for seeing, the tongue for taste, and the nose for the smell, skin for the touch. And all modern sensors, they do the same activity. I know this is all part of the human body itself, but this is replicated in the form of a sensor for hearing. That means you have one is sound creation through microphone, speakers, and then it is again captured. You know, this is how we take the sound in, we transmit it, and then make use of it. So this is where sensors are made use of. Similarly, there are cameras all over. You know, in fact, in the institute, security part is half taken care of by not human beings, by the software and the sensors that are used there. Similarly, today we also have test sensors. Actually, they can test the hotness of the chili or the sourness of some lemon. I think all of these are also useful in terms of some kind of sensors. So is the case with the smell. You know, had this been evolved much better, probably Bhopal gas tragedy could have been averted or at least reduced in magnitude, because the sensor would have smelled that gas is leaking and immediately action would have been taken. I think these are all fantastic things. As far as I say again, skin, not only for touch, but the quantum of pressure applied or the force applied can be measured using sensors. And that is where many robots, they use those fingers which are there with the robot, and they have to understand whether it is a glass, whether it is a metal. So what kind of pressure is to be applied to pick it up and place it in some other place. I think these are absolutely exciting toys and tools which are available today for our young children. And this is what the role of not only IISc for that matter, for any university, for any college, which is higher education sector, must make use of in order to really promote science amongst our students. And once they get excited with a variety of these kind of experiments, some of them, they will start developing. And in fact, they will enrich our experiments. And that is why this kind of program is very, very important and significant. Today, another factor which Professor Gururaj also said, Rao also said, is about how the COVID has really helped us in some way. Because earlier we were thinking all of this will happen only through what is known as physical experiments. So we had to go to a place or someone had to be invited to a place. But on a digital platform, many of these things can be done. And there are 2 interesting facts about this. We all know that engineering courses were created by NPTEL from all IITs, including IISc and some other institutions were there. But as an extension of that, several virtual labs have been already developed by all these institutions together. There are about 9-10 institutions who have put in their efforts in creating what is known as virtual labs. And these have two special features which do not have in our even regular experimentation. In a regular experiment, at a given time, only that equipment can be used by one person, can be watched by about 10 people who are surrounding that particular area. And that's what happens in many cases. In some of the high-end experiments, which are expensive in many colleges, every student is not even allowed. You know, in chemistry lab, we are all allowed to use test tubes and mix chemicals and see the magic of changing color, changing, and then get excited about it. But when it comes to similarly physics experiment, we can do it ourselves, or optical microscope, all of that we do. But when it comes to very high-end experiments, it is normally not students who do it. It is the demonstrator or the in charge of the laboratory that he conducts the experiment. And that is the same case in our mechanical engineering. I remember whether it is universal testing machine to test the compression or to test the tension of the material and what is the strength of that material. The demonstrator does it, all students take down the readings. And therefore, at one time, one experiment on the equipment, and which is very expensive equipment, and then maybe 10-20 students who are in that batch or group or whatever we call division, they will be watching the experiment and taking down the readings. In the virtual experiments, when it is used through computer programming and a simulation, the same software simultaneously can be used for people. So if you make it available on the portal, and people can either download or directly use it on that same system itself on the cloud, and then same time thousands of students can do the experiment. Second important thing, the changing of the parameters. You know, if there is some experiment where you have to change the pressure, the temperature, the force, or some kind of a load to be applied, each time at a given time only one can be doing that particular experiment. Whereas in the case of a virtual experiment, simultaneously thousands of students can have different parameters being set. So there will be limitations of the upper and lower limit of what is to be fed as the parameter, and then you conduct the experiment, get the readings, and you can analyze offline or online. So there is a big power of technology when we use virtual experimentation, and that is what virtual labs have created. Then there is a second variety of virtual labs where we also use augmented reality and virtual reality and extended reality. I think these are new terms which have come in the last decade, where power of technology is used for really doing what we call experiential learning. So all said and done, in a tension test, if a material is posted onto the machine and then you apply a tensile load, there will be stretching happening, there will be necking happening, depending on whether it is a ductile material. Then if it is a brittle material, suddenly it will collapse and break down. So that is anyway observed by the students in a physical experiment, no doubt. But in a simulation experiment, you can become a participant in that. You know, many times we say in science that observer and the experiment being observed, many times the tools that are used for measurement, they themselves bring in error, and we will have to have a feedback loop in order to correct that error. Whereas in a participative experiment where an individual who is actually conducting an experiment through AR, VR will become part of the experiment. That means he can become sort of a metal and get a feeling of how the stretching is happening, how breakdown is happening. I think that is invigorating. Observance is one and feeling is different. I think observance and feeling both can be incorporated in a virtual experiment. I've seen some of these software where students of medicine, they are made to go through and they physically enter into a heart, they enter into a lung and experience the exact way the blood is flowing there as though they are looking at it from inside. And that is the power of augmented reality, virtual reality, extended reality. We are conducting these experiments on one side, continue household materials like spring. We have at home a ball pen. We do have some kind of a what we call as not only slippers experiment. I said this is very, very exciting, but also the lenses also may be there at some places. We also have a tire tube which is wasted. You use them and create several experiments. We also have the used straw, which we use for drinking cold drink. They also can be used for several experiments. I think these are one nature of experiment. The second nature of experiment, because we are talking today in pandemic, we are all forced to go online. So digital medium, how we can make use of in order to create experiments which simultaneously, not thousands, lakhs of them can also perform in the respective places with changing the parameters on their own. I think that is what is a thing about the virtual or the digital. And let us move slowly to physical, physical experiments as well as digital experiments. And that's what is important. Then, simple experiment. I'm again coming back to your topics I was saying, whether it is in mechanics, in the sound, all those topics which are going to be covered maybe by Professor S.C. Verma beautifully, being a physics teacher. But making students realize that the force, many times friction, all of these have what we call double-edged weapon. Many times we say friction is to be reduced because we want to save power, we should not have losses. But at the same time, without friction, whether it is rolling friction or sliding friction and the corresponding contact area which is there, we will not be able to do many things. Our braking system is required, and for that friction is important. We also walk, and walking on sand is different, walking on a solid ground is different, and how friction plays a role. And similarly, when in a very posh building with very polished surface, that is the beautiful tiles, and if let it slide water also, and the friction gets reduced, and we slip and fall down. I think the understanding of friction, whether rolling friction being less friction, these are small experiments which we can perform to make them understand. And similarly, when friction is required, when friction is not required, that also is a very important aspect. Similarly, pressure of the water, when we go down, pressure is increasing, and that's why when the dam is constructed, why is the structure of the dam in a trapezoidal manner? Very narrow at the top because the pressure is less of the water there, and as you go down, pressure increases, and therefore you require more strength, more capacity to absorb that force, and therefore it is trapezoidal in nature. I think these simple experiments, even surface tension, you put a blade on the top of the water, it floats, and when a metal, again the same material, it sinks. These are the simple experiments. In sound also we have reflection, echo. Take them to some empty hall and show them that whatever you speak, because there is reflection and the reflected sound also comes to your ears, there is an echo which is formed. Whereas if a room is full of lot of materials, they are all absorbing, and therefore echo is less. So an empty room and a filled room, that is a difference. But the more exciting is in IISc also, and many institutes, we have anechoic chambers, where absorbing materials are put in all almost 6 sides actually, except in the bottom, maybe there is some solid structure required, but even there we have a lot of sound absorbing material, but all 4 walls and ceilings. And when a person talks there, we don't realize it is our own speech because we have never heard that voice. Our own voice, pure voice, which has come without reflection, is never heard by ourselves. And therefore, that excitement, that how sound also is generated through vibrations, how it transmits, and for transmission, medium is required. We have that bell jar experiment in the high school, very important. And then, if there is a vacuum, we don't see the sound. How we can generate that kind of a studio where outside will and disturb the recording that is happening. I think wonderful explanations and experiments we can do. Same is with the case of temperature. Temperature like force is another thing which we cannot see. We can only feel it. Touch a hot object, we will get it. To cold object, we know what is the less temperature or more temperature. But the effect is known. And similarly, the heat transfer, the convection, the conduction, the radiation, which is better why something is better. I think simple dosa making, is a great art one side, but know the science of it, without knowing it, probably how much time we have to keep it, how much temperature, gas has to be kept on the low side, when it has to be on high side. I think the people who cook, mainly are ladies who cook most of the time, and men unfortunately don't do it. They should do it, and they should and try to learn the science of heat transfer actually. And similarly, radiation gives better transmission of heat, less losses. How we can create new products where we have more energy conservation possible, And then we come back to environment, of course, whether it is refrigeration, air conditioning, the ozone layer depletion, CFCs being not to be used, and WTO regime, all of that. We can connect actually each case of science experiment with technology or engineering on the other side, and with the environment and the society on the other side. And that is what our Astra was doing. I remember I had gone to the village along with the Astra people that time when I was a student. So this is what we need to make our students both from the rural area and urban area to understand. So my focus is more on urban area students in all these respects because they have more superficial knowledge. Whereas the rural folks, they have intrinsic knowledge actually. That's what I keep on feeling. And then more modern things. The new education policy, which was referred by Professor Guru Rao, is also talking about foundational years. Of course, this particular program today is for 6th standard onwards. That was what was given to understand. Most of the experiments are of that age. But I think students can start learning right from age 2, 3. A simple case is you tell a child that this is very hot, the candle is burning, don't touch. The child will obey you because you may beat. But when you are a little away, it will go and touch that flame. And when it gets its finger burnt, it understands the real, that is experiential learning. And that's why the formative years, whether it is literacy or numeracy, in the new system, from 10+2 moving away to 5+3+3+4 years of education, that is 15 years of education, and the education starting at the age of 3. We used to call in some cities nursery, lower KG, upper KG. In some rural areas, there are balwadis, anganwadis. But combining all of them and starting formal, some way of engagement in a very informal manner, through stories, through games, through toys, through going into the nature, through plays. You create a play, ask them to do acting. And through that also many scientific things can be taught. And teaching of different languages is also very easily possible through means. Because once you know the mother tongue and you come to the school, the story is known to you in your mother tongue. You say the same story in maybe in Kannada or in Marathi and Tamil and Telugu. Most of the words being common, child will start understanding the language. And therefore, the numeracy and literacy skill sets being developed is one. From 6th standard onwards, the policy also talks about having some kind of skills being developed. And up to 12th standard, minimum 2 to 3 skills every child has to imbibe. Maybe it carpentry, welding, machining, like mechanical, maybe electronic circuits, preparing some kind of a winding or in electric winding, fuse circuits, etc. in electrical, or it may be chemical engineering, or it could be little high-end like 3D printing or artificial intelligence, Internet of Things, all coming into the domain of school education from 6th standard to 12th standard. And therefore, we need to prepare our students in all of this. This is what makes them multidisciplinary. And how we can teach them that how maths, physics, music, they are all appearingly, externally different, but intrinsically same. For physics, sound waves created by vibrations, frequency is involved, mathematics is involved, whether it is sinusoidal, how many types of Fourier transform, all of that will come into that indirectly, directly. We have the music where raga, the rhythm, the pitch, all of that is also, unless it is musical, we don't enjoy it. We don't enjoy noise. And that's why how that rhythm has come, where physics is involved, maths is involved, music is involved. Similarly, the materials, chemistry materials, where we talk about electrons, proton, neutrons, or DNA. Biology also has all these elements. You talk about proteins. In mathematics, you get new materials by using modeling and computer programming, nanoscience, nanomaterial. I think gross as well as what we call subtler, both variety of knowledge, if we are able to impart through our different types of experiments, I think there is a lot of excitement. Now, the last part, 1 or 2 minutes I will take is about ancient Indian science. This is very important. Ministry has established an Indian Knowledge Systems division in AICT, and we are supporting funding. We have to be proud of our achievements, which are there from way back 3000 BC, 5000 BC, etc. Many times we think science has all come from the West. Science actually started from India and went to the West. They developed it further. So we don't belittle them, but we should be proud of our heritage. Go to Dholvira, Mohenjo-daro, Harappa, Dwarka. Their stories of Ramayana, Bharata are visually available in some of these places. How, without having scientific spirit, they could have developed astronomy even without telescopes by mere observation by the naked eye in the sky. They knew about planets, Earth being round. Sun's energy is important. That's why we pray sun god, that is Surya Bhagavan. Distant stars, constellations, galaxies. Kanada talked about physics, atoms, chemistry by Nagarjuna, metallurgy, as way back as 375 AD, 23 feet iron pillar, which is still not rusting near Delhi here. Polishing in Kerala, I know artisans from Arnamula, mirror making. It is a nano finish. They do it by hand actually. How these are, one side science is involved, techniques are involved, skill is involved. And therefore, in maths, of course, Professor Rangarajan, great, significant contribution. It is, many times we say zero was contributed by India. In fact, the entire numerical system of counting, not just 100,000, 10,000, lakh, crore, we had gone up to 10 raised to 23. We have names for those numbers. I think this then later went to Arabic and therefore called Indo-Arabic numerals, but it is actually Indian numerals. People should be all our heritage. And it is just not mathematical zero, but binomial theorem, Vedic mathematics, simple algorithms, which will make you solve the complex, calculations much easier. I think civil engineering, another area, construction of those temples, which are almost 8-9 story with huge structure, without lift, without electricity, without your cranes. How did they manage it? I think fundamentally people were observant, people were scientific, and they all made useful products to the society. And that's why, whether it is water wheel, the Ayurveda, the surgery that was developed, I think there are hundreds and thousands of things. Of course, we should not tell something which did not exist as being existing in the past. That also we should take a caution, because when we say we are scientific, what was truth, we should be accepting it, the truth as it is. Be proud of the ancient heritage, but don't be only glorifying that. How we make it relevant today, how we make use of that science to today's needs. COVID has also proved many times that our ancient Ayurveda has helped in many ways. So how we make it relevant and do future research and give the whole world a very happy ending. That is what is the most important. Sarve janaha sukhino bhavantu. Vasudhaiva Kutumbakam. These are the philosophies. So science without this philosophy is meaningless. Otherwise, we will only create nuclear bombs. And therefore, with this spirit, let us make the humanity a better place to live for our planet, better environment. Thank you very much. I think children will have an excellent time through IISc-like institution. Namaskar.
Thank you very much for your words, Anil sir. It was a pleasure hearing from you. We heartily thank you for making time for us despite your busy schedule. I once again thank our director, Professor Anil Kumar, Mr. Veeranna, Professor Guru Rao, Mrs. Kavita Harish for joining us today. We now conclude the inauguration, and I welcome all the audience to the nationwide event, the Digital Kids Zone. Let us not wait more, and let's dive into a fun-filled day of science. As we all know, over the past year, the pandemic has caused us a hindrance to attend school. Should that stop us from learning? How can we learn science practically sitting at our home? Don't we need sophisticated lab equipment to perform science activities? It turns out we can do a lot of science just within our home. On this occasion,
Yeah,
On
you're
this
audible.
occasion of Teachers' Day, we bring you a set of simple experiments that you can also replicate at home. I hope by the end of this day, we will not just confine science to textbooks, but indulge in the joy of learning it by just looking around us. Let me now brief out today's schedule to all of you. We have two sessions planned for the day. In the morning session, we have experiments on matter, mechanics, and sound. There will be interactive sessions between the experiments. You can drop in your questions related to the video being streamed on YouTube Live in the comment section. The demonstrator of that video will try to answer some of your questions. In the afternoon session, we will have a talk by Professor H.C. Verma and proceed to our next set of experiments in the topics of combustion and fire, electricity and magnetism, electrolysis, optics, biology, and environmental awareness. We will also announce an exciting science competition at the end of the day. The details of this can also be found on our website. We will try the best from our end today to ensure smooth streaming of these sessions. But in any case, due to technical issues, if we face any difficulty, we kindly request you to cooperate and be on our YouTube channel, Science for Rural India. We will get back as soon as possible. Let us now begin with our first video, Matter in Our Surroundings.
Yes, sorry for this interruption. So we will be starting our session soon. We are just loading our this videos. So please stay tuned. And I thank all the guests for this wonderful inaugural session. Please stay tuned. We will be starting our session soon. Thank you.
I hope I am audible. Experiment.
Yes, we will be starting our session in 2 minutes. Please stay tuned. Yeah, before we starting, I have some announcement for the kids who are on YouTube. So you guys can type your question while the video is being played. Type your question. So we will take up our question during the Q&A session. So after 1 or 2 videos of similar topic, there will be a Q&A session. There will be a Q&A session. At that time, our demonstrator will come live and take up few questions which he can during that particular Q&A session, and he will answer it. So stay tuned. It will be a fun field of sessions. We'll be starting soon.
Am I audible?
Yes. If you look around yourself, you can see many things, such as the screen, chair, fan, plants, maybe water also. There are also things that you can't see but can definitely feel, such as air when the fan is switched on, or air in a balloon. All these things, which are made of some material, are called matter. Let's look at the matter in our surroundings to understand it better. Imagine this table is the universe. Does this universe have matter? Yes, I can see some books, a water bottle, a pencil, and a balloon too. These things take up some space on the table. Now, what if the table wasn't there? These things still take up some space. Not just this, water occupies some space in the bottle. Air occupies some space in the balloon. And air is also occupying the space around all these objects. This is the first property of matter, that matter occupies space. But how much space does it occupy? Now look at this glass with coffee. It is this long and this wide. Similarly, look at this lunchbox. When we measure its length, width, and height, we can determine the amount of space that it occupies. This space is nothing but the volume of the object. But is volume enough to describe matter? This orange and the stone are of same shape and size and occupy the same volume. If you hold the two in your hand, you'll find that the stone is heavier than the orange. Therefore, matter also has mass. Overall, matter is anything that occupies space and has mass. For a very long time, scientists thought of this question. What is matter like? Is it like this wooden block, a single continuous object with no space inside? Or is it made of smaller units? Maybe think of water. Is it like this continuous thing? Or is it made of some smaller units? Now imagine that matter is actually like this wooden block and water is like a continuous object. That means if we put something in water, the water will have to shift upwards to make space for this object. So its level should increase. Now the same should happen if we add salt or sugar to water. Again, the level of water should increase. Now let's try this. Now, in this experiment, you will need a glass of water and something to mark the level of water. I am sticking this triangle. You can also mark it with a pen. Now, take a spoon of some salt or sugar and add it to the water and mix it till it dissolves completely. What do you think will happen to the level of water? Would it remain the same as before or will it increase? We see that the level of water is the same as before. Interestingly, the level of water doesn't change. So where did the salt go? The salt now occupies the space within water. This means that water is made up of smaller units known as particles. And there is space between these water particles that now the salt particles occupy. However, in the previous case of the stone, the space between water particles is not enough that the stone can occupy this space. We see that water is made up of smaller units which are known as particles. You must be thinking, are these particles big or small? Let's first imagine that the particles of matter are big. Imagine that we add very little color to a glass of water. You can't see the particles of the ink, but you can tell their presence through the color of the solution. Now we take about 1/5 of the solution and add it to a new glass and fill the rest of the glass with clear water. Now when I do this, maybe one or more particle would be present in this new glass. If you repeat this again, you will probably get water with no particle, and the water would be clear. Now let's imagine that the particles of matter are small. Again, if I add very little color to a glass of water and take out 1/5 of this solution, add it to a new glass and fill the rest with clear water, what I find is that many particles of color are still present in the new glass. If you repeat this again and again, you will again get water with some particles in it, and the water would not be clear. Now let's try this on our own. For this experiment, take a glass of water with some ink or food coloring in it. I have made this scale on a paper and pasted it onto all the glasses so that I know how much water I am taking out or adding. Now take 1/5 of the colored solution and add it to the empty glass next to it. Now fill the rest of the glass with clear water till the marking. The color of this solution is lighter than the previous one. Repeat the same process using the next empty glass. This solution is even lighter. Now this process is also known as dilution. Repeat the same step for the 4th glass. Now does this 4th solution look clear as water? Let's check. Now here on the right I have clear water with no ink. To see if there is any ink particle still present in in the glass on the left, keep a white sheet and compare the two glasses. The glass on the left still has very little blue tinge. We find that these particles are actually very tiny, and we will need to repeat this process few more times to get completely clear water. Now, you might be thinking, do the particles in matter remain stationary or do they move? To answer this, think about what happens when you put an unlit incense stick in a corner of your room. Can you smell it from some distance away? How close do you have to go near it so as to get its smell? Now light the incense stick. Can you smell it from some distance away? If yes, how? Some particles from the incense mix with the air and take space between the air particles and reach your nose. For the next experiment, we would need 2 glasses of water, some honey and ink. So again we have 2 glasses of water here. I'll add ink or food coloring to the glass on the left and to the glass on the right I'll add honey or shampoo or any thick syrup that you might find in your house. Now do not mix these solutions and leave them undisturbed for some time. Now let's observe what happens as time passes. Do notice the honey drop in the glass on the right. Let's see what happens after 10 minutes. The ink and the honey are evenly mixed in the solution on their own. Now, let's try one more activity. We'll need 1 glass of cold water and 1 glass with hot water, and we'll add ink to both of these glasses. For this experiment, I have 1 glass of chilled water on the left and a glass of hot water on the right. To both of these, I have added 1 drop of ink and I will leave them undisturbed. Now observe how the color or the ink particles mix in both of these solutions. What differences do you observe? As time passes, we see that the color hasn't mixed evenly in the cold water, whereas the entire solution with hot water is completely blue. From these experiments, we learned that particles keep moving continuously. We also learned that particles move faster when temperature is increased, and they move slower when temperature is decreased. Okay, we know that these particles keep moving continuously, but with such movements, why don't they just get away from each other? To understand this better, think of what will happen if you try to press these objects very hard. Which ones would break and which ones would not? Now, think of what will happen when you try to break water. Can you really break water? The particles remain together because they attract each other. This force of attraction keeps them together and prevents these particles from drifting far away from each other. Now, which objects would have a stronger force of attraction? That means, which objects are hard or easy to break? A nail or a chalk? What about water or say some potato chips? Once you have thought about it, the answers are in the next slide. it might be easy to guess that it is harder to break a nail compared to a chalk, and it is harder to break a potato chip compared to water. This is because of the stronger force of attraction between the particles in a nail and a potato chip. So in summary, we see that matter occupies space, that is, it has volume and has mass. Matter is also made up of very small particles. These particles keep moving continuously. The particles of matter move faster when temperature is increased and slower when temperature is decreased. They remain together because they attract each other. But this strength of attraction is different for different things, as we saw previously.
Those were interesting experiments, weren't they? Thank you, Tanveen, for your demonstration. I now request you to take up a few questions from the audience.
Hi, can I start? Can I start? I hope I'm audible. So there is one question which says, what kept the level of water same? I don't know with which question they're asking to, but if you're asking for the salt question where I mix salt and water, it is just that the salt, starts to occupy the space between water particles. But for example, if you add too much salt and you try to mix it, there would be still some salt left, towards when you start mixing a lot of salt. That means that all the spaces between these water particles have already been occupied. So now no more space is left. There is this question on what is plasma? About plasma. Plasma is also another kind of matter. You can read about it. It's a little. We will be looking at different states of matter and kinds of matter, and plasma is one of them. There is one question: what is matter ultimately made up of? So matter, if you go from a bigger picture to a smaller picture, you will see that ultimately matter is made up of atoms, but atoms are also made up of other things, which hopefully you'll see maybe in the later videos. And there is one question on why doesn't the ink mix later in hot water? I didn't quite understand this. Yeah, basically, I'll just explain what happens is when you put ink in hot water, it because the particles are moving so rapidly, in the hot water, because now they have heat and some energy, the ink mixes very quickly because they're kind of think of it like they're colliding with each other and moving here and there. But in the case of cold water, because they don't have that much heat, they're moving slowly, and therefore the ink is not able to spread throughout the solution.
You can take up one more question, Tanvi.
Okay. Yeah, how is the size of particle measured? Is it using microscope or any special device? So right now, what I'm saying that these particles, we have actually not really addressed what these particles are, but these particles could be molecules or atoms, and depending on what part, which one of these you want to see, you can actually use a microscope, yes. if you actually want to even go deeper into the particles, like look at an atom, or say if you want to look at the electrons in that atom, you can actually look at them through electron microscopy. Or yeah, basically you will have to you can't look at them through your naked eye because they're so tiny. So yeah, you would need something like a microscope to look at these particles.
Thank you, Tanveen, for answering the questions. We now move on to our next experiment, states of matter.
Yet they are very different from each other. The difference between them is although they are the same material. If I asked you what is common between ice, water, and steam, what would you say? We all know that these materials are exactly the same. They're all made of water, yet they're very different from each other. The difference between them is although they are the same material, they are in a different state, which we call as solid, liquid, and gas. These are the three states of matter that we are going to talk about today. If you look around yourself, you will find that matter can be found in three different states. Consider this cup of coffee. Now there is this cup and the coffee beans which are in the solid state. There's the coffee which is in the liquid state. And there are these vapors which are in the gaseous state. But how are they different from each other? At the particle level, the difference in all these states is how the particles stay together with each other. In solids, the particles are held together by a strong force of attraction, so they do not move around a lot, but they vibrate in their own space. In liquids, these particles are able to move here and there a little more freely as compared to solid objects. But when it comes to gases, the particles can move around very freely, as you can see here. Now let's try to understand these different states by looking at the objects around you. Now grab some of these objects and see if you can trace their outline. Can you trace the outline of water? Here I am not talking about a glass of water, but water itself. And similarly for a gas. Now you would find that we can easily trace the outline of a solid object, but not a liquid or gas. This means that solids have a definite shape and very distinct boundaries. Since you have all of these objects close to you, try to squeeze or press or stretch them. Maybe take a stone and try to press it. The shape doesn't change. Take a rubber band and stretch it. Take a sponge and squeeze it. Both the rubber band and the sponge come back to their original shape when you release the force. Take a chalk and try to press it hard. Oops! If you apply too much force, you find that the chalk will break. Now all of these objects are solids, and you would find that maybe their shape doesn't change and therefore they can't be compressed, or they regain their shape when the force is removed. And when too much force is applied, they break. Now take a solid object and put it into different containers. You can take a stone or a pencil. Here I have kept some tennis balls in a cylindrical container and some tennis balls in a bowl and one tennis ball next to them. If you look at all of these objects, you see that even though the tennis ball is kept in containers of different shapes, they still retain their spherical shape. That means the tennis ball doesn't change into a cylinder if kept in a cylindrical container, and so on. From this we learn that solids have a fixed shape and volume. That means they occupy a fixed amount of space. But you may say that you have seen salt and sugar stored in jars of different shapes. And you might think that salt and sugar actually take the shape of the container they are kept in. That's not true. The salt and sugar crystals still retain their original shape, whether they are kept in a bowl or a jar or anything else. Also, you would notice that solid particles cannot be compressed into these containers. Like if you can put 1 kilogram of sugar in a jar, you can only put 1 kilogram sugar in that jar and no more. So solids do not take the shape of the container and they cannot be compressed into these containers. Now if you try to put a liquid or a gas into different containers, you will find that now the liquid has taken the shape of these containers. If you look here, the liquid doesn't really have any shape. Similarly, in the case of gases. Gases are usually stored in such containers and they do not have any shape, as you can see here under the arrow. From this we learn that liquids and gases do not have a fixed shape and they take the shape of the container. One more thing. For example, if you take 15 milliliters of milk and put it in different containers, the liquid would only occupy 15 milliliters of the space or volume in these containers. However, if you take 15 milliliters of carbon dioxide or any other gas and put it in a big container or a small container, the gas would occupy the space in the entire container, just like shown in this image. This tells us that liquids have a fixed volume, but gases do not. Now think of this question. Can we mix something into a solid, liquid or a gas? Let's start with a solid. Here I have a corn cob. I have put some salt in it. Is salt, water or any gas able to enter a corn? Maybe not. This is similar for other solids as well. It is not easy for other substances to dissolve or diffuse into a solid. This is because there is little or no space between the particles in a solid. Now, can we mix something into a liquid? Yes, you must have seen your mom mix sugar into milk. You would have also seen that when you drink Coca-Cola or Pepsi, there is carbon dioxide that is dissolved in it, which makes the cold drink fizzy and bubbly. So solids and gases can easily dissolve and diffuse into liquids. Now, also think about plants and animals that are found underwater. How do animals get oxygen for respiration and plants get carbon dioxide for photosynthesis? The oxygen is dissolved in water from the atmosphere and also the plants that produce them. Similarly, plants get carbon dioxide that is dissolved from the atmosphere, which they then use for photosynthesis. Now coming to gases, think about what happens when you open your lunchbox or spray a perfume in your room. All the particles carrying these smells get diffused easily into the air particles in your room because there is so much space between the air particles. Now, this brings us to another fascinating property of gases which we will look at now. A lot of you might have heard about CNG, which is compressed natural gas. Many vehicles across India, such as this auto rickshaw, runs on compressed natural gas or CNG, which is a very important fuel. To store this natural gas, it is subjected to a lot of pressure. This means that gases are highly compressible. In fact, this is how a lot of gases like LPG that is used in kitchens are transported from one place to another by compressing them to pressures and storing them in cylinders. Now, what if a solid, liquid, or a gas is kept in a container and the container is tilted? You would see that the solid object would simply fall out of it, while a liquid and a gas would flow out of these containers. This tells us that liquids and gases can flow and are therefore known as fluids, while solids do not. Now, interestingly, there are materials that are sometimes solid and sometimes liquid. So, in the next experiment, you will look at one such substance which you can easily create at your home.
The everyday materials around us generally fit into one of these three categories, either solid, liquid, or gas. But there are some fluids which behave in a unique or peculiar way. And in this experiment, we will explore the properties of a simple mixture of cornstarch and water. This mixture is also called as oobleck. For this particular experiment, we need very simple materials which are easily available. You need corn flour powder, which is available in any supermarket or nearby general store. You need a large mixing bowl or a pan, a measuring cup, some water and a newspaper because you don't want to create a mess on your table or workspace. First of all, put a newspaper down on your counter or your tabletop. Pour about 2½ cup of corn flour powder or cornstarch into the mixing bowl, and then you dip your hands into it. Can you feel how smooth the powder is? It is made up of super fine particles. So now add water slowly. Mix the cornstarch and water till all the powder is wet. So here the ratio is for 2½ cup of corn flour or cornstarch powder, you have to add 1 cup of water. Mix it thoroughly with your hands. Add water slowly and mix it simultaneously. If you have any food color readily available at your home, you can add it to make it more colorful. But if you don't, then it's fine. The mixture is going to be white in color. So mix it thoroughly and very well till the mixture becomes like a ooze. Now pick up a handful of the mixture and start squeezing it. You will notice that it is hard when you apply force to it, that is when you're continuously squeezing it, and when you stop it, it will drip through your fingers. I have taken a heavy object, that is a metallic pestle from the mortar and pestle at my home. Take any heavy object at your home and rapidly hit it onto the surface of the mixture. So here the behavior of material depends on how quickly you move around it. If you stop applying force, the object will sink inside. So now the question is this mixture a solid or is it a liquid? Think about it for a while. This mixture is unique because it can behave both as a solid and as a liquid. The mixture is made up of tiny solid particles of cornstarch suspended in water, and this type of mixture is called a colloid. As you found out when you experimented with ooze, this kind of colloid behaves strangely. When you bang on it with a heavy object or quickly squeeze a handful of ooze or rapidly drop an object on it, it freezes in place. It acts like a solid. The harder you push, the thicker the mixture becomes. But When you open your hand and you let the ooze flow, it drips like a liquid. Many centuries ago, Sir Isaac Newton proposed that fluids should flow at a predictable constant rate. Many fluids do indeed behave this way and are called Newtonian fluids. Water is a perfect example of a Newtonian fluid. When you are in a swimming pool, water flows around you whether you are moving around quickly or slowly. Unlike water and other Newtonian fluids, there are fluids which respond differently depending on how quickly you try to move around them. They are called as non-Newtonian fluids. Cornstarch water mixture or oobleck belongs to this non-Newtonian fluid category. There are many examples of non-Newtonian fluids. For example, the food industry deals with many non-Newtonian fluids including ketchup, mayonnaise, jelly and cranberry sauce. So understanding how these materials behave help these food scientists to make more interesting and tasty food products. Biologists studying cells inside our body are also interested in non-Newtonian fluids because the fluids inside our cells behave as non-Newtonian fluids and this influences many cellular processes. Engineers are even finding ways of putting non-Newtonian fluids to good use in our everyday lives by using them to fill potholes in the roads. Hence, understanding the behavior of non-Newtonian fluids is important for many areas of scientific research. At the end, I would like to add that cornstarch water mixture is non-toxic, but please be cautious when doing any science activity. Be careful not to get it into your eyes and wash your hands thoroughly after handling the oobleck. And do not add the cornstarch water mixture directly into the drain. So to dispose it, add plenty of water to it in a bucket and then dispose it off into the drain. Take all the precautions and safety measures during the science experiments and have fun. Thank you.
We learnt about different states of matter and interesting materials called as non-Newtonian liquids or non-Newtonian fluids. I once again request Tanveen to turn on her video camera and microphone and please take up a question or two from the audience.
Okay, there is this question on why on heating the intercellular space between water particles increase. This happens because when you provide heat to matter, there is enough energy for the particles to actually move away from each other. And even for example, in a gas or a liquid, they can move around each other in the liquid itself. Sometimes if you provide a lot of energy, they might actually change their state from, say, solid to liquid or liquid to gas also, if that energy is, enough for that, for the particles to stay very apart from each other. And there is this question about how can, is chalk semi-solid or brittle? Chalk is actually just brittle. It is solid. Like you can tell the shape of the chalk. If you put it anywhere, it would always retain that shape. But the thing is, if you apply a lot of pressure on it or, force on it, it breaks. So it's just brittle. And is curd solid or semi-solid or liquid? I think now after seeing the cornstarch experiment, you might have more clue about what curd is like. It can both be but the thing is, think about curd. Does it have its own shape, or like if you keep curd in a glass or in a bowl, does it take the shape of the container, or does it have some shape of itself? So I think that would tell you that curd is actually more like a liquid than a solid.
You can take up one more question, Tanvi.
Okay, there was one question. The question says, how is vibration felt in solids? You can't actually feel the vibrations because these are like very tiny particles which are moving in their own position like this. Okay, they're very tiny, so you can't really feel the vibration. But like, yeah, it's on a very microscopic scale, so you can't really see them vibrating, or you can't feel the vibrations basically, because the scale at you'll need a microscope to actually feel and see that. So yeah.
Thank you, Tanveen. I now request Manasa to turn on your video and microphone and take up a few questions from the audience.
Yes, so these questions are from the Oobleck experiment. So the first question is, what is the main difference between Newtonian and non-Newtonian fluids? So first of all, in Newtonian liquids, the viscosity is nothing but the resistance to the flow. Viscosity of the liquid does not change or does not depend on how fast or how slow you move around the liquid. In other words, the viscosity does not depend on rate of force which you apply. If you take a bowl of water and take a spoon, you move it quickly or you move it slowly. The viscosity or the resistance to the flow does not change, is it? But if you take a bottle of ketchup, all of you will have ketchup at home. So you know that when you actually try to pour ketchup into the bowl, it does not very easily flow. Instead, what you do, you try to hit the bottom of the ketchup bottle very rapidly, and then the ketchup flows off. Another example is toothpaste. So when you have the tube of toothpaste, if you just open the cap and invert it, don't squeeze it, it will not come out. But if you start squeezing it, if you apply pressure or if you apply force, it will come out. So that is the main difference between Newtonian and non-Newtonian fluid. Another question here is, what causes Oobleck to harden? So see, in solids, the atoms are very closely packed or closely arranged. But in case of liquids, it's not so closely packed as in case of solids. So there is some space to move around in case of liquids. But for cornstarch particles, these are superfine particles which are suspended in water. So this is called as colloid, and each cornstarch particle is like 1,000th of millimeter. It is so small. Okay, so when you apply force to it rapidly, the cornstarch particles all start interacting and chaining together, and there isn't much time for water to surround surround the individual particles, and hence it offers more resistance to the force. That is why this Oobleck causes to harden when you rapidly hit on it. Another question that we have here is cement and water Oobleck? Okay, no, it is not the same. It does not have the same characteristics as Oobleck. The thing is, what happens in cement and water paste is it dries up. When you mix cement with water, there are some chemical reactions which take place. They are called as hydration reactions. When you mix those both, they harden up as time progresses. So you have seen that when you apply cement and water, you leave it for a few days, it hardens up. It becomes like a very hard material. This process is called as curing. So it is not the same process as Oobleck. It is a different type of material, the cement and water. And another question that we have here is, which state of matter is jelly? Yes, jelly is also a non-Newtonian liquid. You have noticed it correctly. Jelly is a non-Newtonian liquid.
Thank you, Manasa, for your explanation.
Yeah, thank you.
Thank you so much. We have Ashok now, who will be briefing you about the competition at the end of the day.
Yeah. So guys, I hope you guys are enjoying it, and there is some more to it, all the kids who are watching there. So we have one competition at the end of this event. So we will open the competition at the end of this event. To know more about it, go to our website, Science for Rural India. In their Digital Kids Zone tab, you will see KZ21 Science Competition. So the competition is whatever you guys learn today. We are doing experiments through household stuff. So you guys can also come up with some more experiments of your own. So you try out doing some experiments and explaining some science topic through household stuff, capture it in a video and send it to us. So this thing, our submission, we will be taking from tomorrow, 6th September till 25th September. And we will choose best 10 winners, and they will be given certificate and very exciting prizes from Indian Institute of Science. So please submit your videos. And also for that, you stay tuned to our this YouTube live channel so that you can learn how to make experiments from household stuff. So there is a list of household stuffs given in the website. You have to use few of them to explain one science topic. And one more announcement, in your YouTube channel, in YouTube, wherever you are viewing it, in the description, you can find the schedule of this particular event. So stay tuned, there's some more exciting experiments are coming up. And also we have one guest lecture talk by Professor H.C. Verma coming up. Okay guys, so over to we'll resume our session again.
Thank you, Ashok. You have seen the experiments on matter and different states of matter. Now, let us watch an experiment on the separation of components.
In this module, we will learn about pure substances and mixtures. We will also look at the different kinds of mixtures, separation techniques, and a demonstration of the Tyndall effect. Let's begin. The world around us is made up of matter in its different states. To understand it better, we can classify matter chemically based on its composition, properties, and uses into pure substances and mixtures. Pure substances can be further classified as elements and compounds. Elements have a definite chemical composition which is uniform throughout and fixed physical and chemical properties. Compounds are pure substances that are made by the combination of two or more elements in a definite proportion by mass. Mixtures are obtained by mixing two or more pure substances in any proportion, such that the constituents do not undergo any chemical reaction when combined and retain their individual properties. Mixtures can be classified further into homogeneous and heterogeneous mixtures. Homogeneous mixtures have components that are uniformly distributed throughout the volume and cannot be seen separately. In heterogeneous mixtures, the components are not uniformly distributed and can be seen separately. Let's look at some examples. All the substances shown in this picture are pure substances. The pictures on the left are examples of elements. We see gold, copper, sulfur, carbon, and bromine. Each of these substances are made up of the same kind of atoms. On the right, we see crystals of copper sulfate, images of common salt, sugar, water, and methane. The components of a compound are combined chemically and have definite properties which are homogeneous. These are some pictures of mixtures found around us. At the left, we have plasma separated from blood, a brass vessel, coffee, and seawater. The components of these mixtures are mixed uniformly and cannot be seen distinctly. On the right, we have heterogeneous mixtures. We see pictures of soil and water, smog over a city, bale, and garden soil. Each of these mixtures are made of components that are not uniformly distributed throughout. For example, the number of tomato pieces in the bale is not the same in each bite, and the amount of leaf litter in the garden soil is not the same throughout. In some of these mixtures, the individual components can be seen distinctly. Heterogeneous mixtures can be further divided into colloids and suspensions. Let's look at their properties. A suspension is a heterogeneous mixture in which the solute particles are visible to the naked eye. Suspensions can scatter light, but after the solute particles settle down, scattering is not possible. A colloid is a heterogeneous mixture with solute particle size greater than that of solution but less than that of suspension. Colloids are stable and particles do not settle down, which helps them in scattering light. Let us now look at a demonstration of the Tyndall effect. Tyndall effect in colloid. To make a colloidal mixture, we have taken a glass of water and added 4 to 5 drops of milk to it. In a dark room, use a flashlight or torch to observe the path of beam of light when it passes through the colloid as shown. As you can see, the path of light is visible as a beam of light moving up and down. In this video, we use tap water, which is a solution or homogeneous mixture of salts and water. The particles are too small to scatter light and hence cannot show the path of light. When viewed sideways, we see no beam of light visible, unlike in the previous slide with the colloidal mixture. Separation of mixtures is based on the physical states of the components of the mixture. Different techniques are employed for separating solid and solid as opposed to solid and liquid mixtures. For example, some mixtures can be separated by hand picking if all components are solids and of sufficiently different shapes and sizes. Another example would be separating the components of a mixture using specific properties of the components like the boiling point or magnetic properties, etc. Let us now look at some such experiments. You can also repeat these experiments at home. Physical states of the components of mixtures. Let's begin by looking at solid and solid mixtures. Magnetic separation. In these videos, we have used a mixture of sugar crystals and iron filings. We use the magnetic properties of iron and use a magnet to separate sugar crystals from the iron filings. In the first video, we use a paper over the magnet because it makes collecting the iron filings easier while separating them from the magnet. In this method, we are using winnowing to separate peanut skins from peanuts. Winnowing is used because peanut skins are lighter and separate during the process. Hand picking. This is a method that can be used when the components of the mixture, here the impurities such as pebbles found in brown chana, are visually different in shape and size and big enough to be seen by the naked eye. Next, we have a mixture of camphor mixed in sand. Camphor has the property to sublime while sand does not. We heat the mixture over a flame so that camphor sublimes from solid to vapor state. Please use caution while performing this experiment. We keep a chilled inverted container over the heating mixture. This will cool down the camphor vapors and they will collect on the inner walls of the container in the form of fine solid powder. You can see the solid camphor collected on the inner walls of this glass. Let us now move on to solid and liquid mixtures and look at the technique of evaporation. Seawater is a homogeneous mixture of different salts dissolved in water. It is, however, possible to separate the salt from seawater using the technique of evaporation. This method is also used to extract salt from seawater in salt panes. Evaporation is the process of heating a substance to temperature lower than its boiling point at atmospheric pressure. It can be done by keeping seawater in sunlight or heating it at a temperature of less than 100 degrees Celsius on a burner. The process of sedimentation can be used to separate a heterogeneous mixture such as soil in water. The insoluble solute settles down when left undisturbed because it is heavier. We can also use alum in the mixture to help sediment the soil particles faster. The sediment can be separated from the solvent by transferring the solvent to another container as being shown. This is called decantation. This separation technique, however, does not completely separate the soil from water. Here we see an example of separating tea leaves from tea using sieve, using the process of filtration. For effective separation, sieve size should be smaller than the size of the tea leaves that are being filtered and large enough for tea to pass through. Other common examples of filtrations which you can also repeat at home are using filter paper or layers of sand and pebbles to separate impurities which are insoluble in water from water. Centrifugation. Centrifugation is the process by which components of a mixture having differences in density can be separated. When we separate cream from milk by spinning motion or centrifugation, the cream aggregates and separates from the liquid component of the milk. Then these two can be easily separated. Thus we see that having a prior knowledge of the properties of the components of a mixture help us in employing appropriate techniques for separation. Crystallization. For this experiment, we will use 2 to 3 teaspoons full of sugar and just enough water to soak the sugar, as shown in the picture. We take less quantity of water so that we can make a highly concentrated sugar solution. Please pay attention to the warning mentioned on the slide. To help dissolve the sugar, we heat the sugar solution. After most of the sugar is dissolved, we take the solution off the heat and set it aside for cooling. After the solution cools down, you can see crystals of sugar forming in the solution. Note that these crystals are larger and shaped differently from the sugar crystal started with. Be dried further to remove excess water. Let us now move on to liquid and liquid mixtures. We can again use evaporation as a technique to separate some liquid and liquid mixtures. Here we take an example of ink. Ink is made up of volatile solvent and non-volatile solute components. When we heat the ink mixture, the volatile solvent evaporates and the non-volatile dye mixture is left behind. The dye is in turn also a mixture of different pigments which need other techniques for separation. Here we have taken some fountain pen ink on a spoon and we heat it over a candle flame as shown. After heating it for some time, the volatile component of the ink evaporates. The non-volatile dye is left behind as a coat on the spoon. Let us now look at some more separation techniques. For liquid and liquid mixtures, separating funnel. This technique works when you have a mixture of two immiscible liquids, which means that these two liquids do not dissolve with each other. For example, kerosene oil in water. Fractional distillation. This technique works for a mixture of liquids which are miscible, for example, ethyl alcohol in water. Let's move on to gas and gas mixtures. Solute extraction. This method depends upon the fact that some gases dissolve in water or in some other solvent while other gases do not. Example, a mixture of carbon dioxide and carbon monoxide can be separated by this method as carbon dioxide is highly soluble in water while carbon monoxide is sparingly soluble. Liquefaction. This method is based upon the fact that some gases like ammonia, carbon dioxide, etc. liquefy easily at high pressure and low temperature, while others are not easily liquefied. Example: a mixture of ammonia and nitrogen can be separated by this method, as ammonia is liquefied easily, leaving behind nitrogen gas. Gas in liquid mixtures. This is a common and very easy to observe example. Boiling. Boiling can be used to release dissolved gas, example CO2, from water. These experiments are best performed in the lab as they might need the use of more sophisticated instruments and safety measures. In this session, we learned that matter can be classified into pure substances and mixtures on the basis of its properties. We also looked at different types of mixtures, solution, suspension, and colloid. We saw an experiment demonstrating the interesting phenomena of the Tyndall effect. Mixtures may be separated using chemical or physical means. Understanding their properties help us to employ different techniques to separate the components of the mixture. We encourage all of you to try these experiments at home with due care and precautions. Thank you for watching.
You might have used some of these separation methods in your home, but did you know that there are so many types of methods of separation? Now, I request Vibhuti to take up some questions.
Hi everyone, I'll be answering some questions. So the first question is compound a pure substance? So yes, because all of the molecules of the compounds are made to have the definite chemical composition and they're all the same. What is smog? Smog is a mixture of smoke mixed with fog. So smoke will be carbon particles and the density of carbon particles in the fog will be different everywhere. So it is a heterogeneous mixture. What is Tyndall effect? So Tyndall effect happens when the path of light is scattered by suspended particles in the air or liquid. So for example, even in fog, headlights show the beam of light, which is also an example of the Tyndall effect. Does pure water have blue color? No, pure water is colorless. So the difference between heterogeneous and homogeneous mixtures is that homogeneous mixtures have same number of particles throughout, so that they're uniformly mixed, and in heterogeneous mixtures the particles are not uniformly mixed throughout the medium. So difference between winnowing and handpicking. Winnowing is useful when there is a density in the separation. There is a difference in the density of the components, and for handpicking there should be a difference in the shape and size of the components of the mixture. In sublimation, what happens in sublimation? So what happens is the particles of the solid absorb enough energy to directly convert into the gaseous phase. So they overcome their forces of attraction and directly go from the solid state to the gaseous phase, and that is what happens in sublimation. Alum is a double salt, and it helps in faster sedimentation because it deposits on the particles of the solute and makes them heavy, which helps them in sedimenting faster.
Vibhuti, you can take one last question.
So can we use the process of distillation and obtain the fresh water? Yeah, so even during evaporation, you can get most of the salts away from the water. And then you can also use different separation techniques to remove other impurities from the water, which will give you fresh water. And another very easy source to obtain fresh water is collecting rainwater. So that is also distilled water.
Thank you very much, Vibhuti, for answering some of the questions. Now, let us watch a next video on some properties of metals.
Hi all, the topic for my presentation is malleability and ductility of materials. This presentation is made under Science Rural Outreach Program organized by kidszoneiisc. Let us get started with the word material first. If you look at the image present in this slide, you will see all these daily use items are made up of some or the other material. For example, this is something made of wood. This is cardboard. This is made of cardboard material. This is made of plastic, glass, plastic again, paper. All these things are made up of some or the other material. So if you look at the bookish definition of the word material, it means relating to, derived from, or consisting of matter. Matter is anything that occupies physical space. So anything that occupies physical space is definitely going to be made up of some or the other material, as shown in the picture above. Now, when we talk about any item, it's always possible to make that item using different materials. If I tell you to think about a glass, so the glass can be made up of different materials. For example, this is a glass which is made up of ceramic. This is copper. This is silver. This is paper. This is glass. This is steel, this is paper, this is thermocol, and this is wood. Now, if you see in this image, a single item that is glass is made up of so many different materials. So the choice of the material that you are going to actually use in your application or in your system depends on what kind of application it is. So depending on the nature of your application or your experiment, you will have to choose the material that you will be using. So such is the importance of the term material. Let me give you a task. The task is to think about a ball. Think about it in your mind. Now, when I actually asked you to think about the type of ball in your mind, all of you might have thought about a different kind of ball. The ball could be different on the basis of the physical sizes and all. Apart from that, one of the parameters that will be different about all kind of balls that you have thought about is the kind of material that the ball is made of. So here in the image, you can see there are different balls which are made of different materials. For example, this is made up of rock. This is made up of fabric, metal, thermocol, and cast iron. So these are just a few examples. All of you might have thought of a ball which is made up of different material. So as I mentioned in my previous slide also, depending on what kind of application you have, the same item can be made with different materials. For the sake of organization, the materials are classified into different categories. First is metals and non-metals, and the metals and non-metals are then classified on the basis of their physical and chemical properties. So based on these properties and compatibility of these properties with our application decides what kind of material are we going to use. So in order to decide what kind of material we are actually going to use for our application, we need to know about the physical and chemical properties. For the sake of this presentation, we'll be focusing on physical properties. And two of the physical properties that will be focused in this presentation are malleability and ductility. Few of the physical properties of the metals are as follows. Lustrous. Lustrous is the shining property of the metals. The metals should be good conductors. They are supposed to be ductile. Ductile is the ability of the metals to be drawn into wires. They are usually in their solid state. They are sonorous. Sonorous is the capability of the material to produce a ringing sound on being struck hard. High density. High melting point. Next is malleable. Malleable is the ability of the materials to be drawn into thin sheets. Few of the physical properties of the non-metals are as follows. They are almost complement of those which we just saw in the as a properties of metals. They are dull, and not dull is the opposite of lustrous. They are poor conductors of electricity. They are non-ductile, cannot be drawn into wires. They are brittle, that is when hammered, they break into smaller pieces. They are transparent. They may exist in solid, liquid, or gaseous state. They are non-sonorous. They don't produce a sound when struck hard. One of the physical properties that we are going to look up today is malleability. So malleability by definition means ability of material to be drawn into thin sheets. That means suppose if I'm taking any metal and I'm hammering it, or I'm putting any kind of stress on that metal, and it is and I am able to draw it in the form of a sheet as displayed in this image, then the metal is said to be malleable. As opposite to this property, if I am unable to draw a material in the form of sheets and instead on hammering, the material deforms or fractures itself, or it is not existing in its natural state, then the material is said to be brittle. The example of a malleable material could be an iron sheet. So if you take iron piece in the right combination, then if you will hammer it, it can be drawn into a form of sheet. And many of us has actually seen iron sheets in our daily lives. On the contrary, if you think about the brick that we use in our that we see in our daily lives, if you think about brick, then if the brick is hammered, it breaks into pieces. It is not able to take the stress, it deforms. So brick is a brittle material. On the contrary, iron in right combination is a malleable material. In order to conduct a malleability test, we hammer an object in this manner, and compressive stress is applied, and it turns into something like this. Another related property is called ductility. Ductility is the ability of the material to be drawn into wires. So if I am able to put a tensile stress, which will be demonstrated in the further slide, and able to draw the material in the form of a wire, then the material is said to be ductile. So just to recall, the ability of the material to be drawn into sheets is called malleability, and the ability to be drawn into wires is called ductility. In order to perform a ductility test, on the solid, tensile stress is being applied and it transformed into this shape. Unlike the malleability test where compressive stress is applied, for the ductility test, tensile stress is being applied. Let's do some experimentation. Let us check if the following materials, which I'm going to just show in the next slide, are malleable or not. The items required for our experimentation are as follows. This is an aluminium rod, piece of coal, iron nail, pencil lead. These four are the materials on which we'll be testing whether they are malleable or not. For the safety purpose, we'll need safety glasses, we'll need hand gloves, we'll need a hammer for the purpose of hammering. Let us look at the results now. This is the pencil lead. So what happened, if you see in the video here, what just happened to the pencil lead is, on hammering, the pencil lead is no more in the same shape that it was before. Hence, we can say that the pencil lead was brittle. If you look at the before and after image of the pencil lead, then it was like this before the experiment, and it turned into this. So the material is no more in the same state it was before. So we can categorize pencil lead as a brittle material. Next is iron nail. Here we are hammering the iron nail. Now let's see what is the difference in the shape that has occurred before and after. Before it was this shaped, and now if you see, if I hammer it nicely, I will be able to turn this into a thin sheet. So we can categorize iron nail as a malleable material. Now here is coal. So if you see that, just one hammer and it broke into pieces. It is no more existing in the right structure that it was before. So if you see before and after image for the coal piece, here it was intact, and right after hammering it broke into multiple pieces. So we can categorize coal as a brittle material. Next is the aluminium rod. Since it's the thick aluminium rod, we were able to deform it to a very less extent. But if you will take the pure aluminium in its very pure form, then you will be able to see higher deformation. So let's look at the before and after images. So if we look at this view, then this is what happened to the aluminium rod. It didn't break into pieces. It still had its structure intact. And if you look at another front view of this aluminium rod, this was the before thing, and this, if you see, it has deformed here. It has become flattened over here. So in order to summarize what we learned today, we learned about materials. We classified the materials. We understood the basis of that classification and why is it necessary. We learned about one of the physical properties of metals, that is malleability. We learned how to test malleability of materials. We learned about ductility of metals, that is another physical property of metals, and we learned how to test ductility of metals. and we experimentally performed these tests, I would suggest that you don't actually perform these tests until unless you have a senior which is there to observe with you, because it might not be safe. Thank you all for your patient listening. I'm open to any questions that you have. Thank you.
You watched the video on some properties of metals. Now, Anchal, I request you to take some questions based on the topic.
Hi all. So the first question that the audience has asked is, why didn't the iron nail and the aluminium rod that is used in the experiment change their shape significantly? So if you take iron in its pure form, then it will definitely have a much higher shape deformation. But since the material that I have used, they are not pure form, they are alloys. So alloys, you don't want your iron nail to deform when you are trying to hammer it. So that is why, since they are alloys, they have higher strength and they are made in such a way that they don't deform much. But definitely, if you take iron in its pure form, it will definitely deform its shape. Another question is, why is the classification important? So for different application, the kind of material that you use plays a very important role. So hence there is a separate branch in engineering called materials engineering. So the selection of material actually impacts the cost, performance, efficiency, and reliability of any product that you design. That is why selection of material is very important, and hence we need to classify based on their physical and chemical properties. So next question is, why do materials have luster? Why do metals have luster? Sorry. So in metals, what happens is they have loose electrons on their body. So whenever these electrons are excited or they get some energy, so they take that energy, go to a higher energy level, and when they come back, they release that energy in the form of electromagnetic radiations. So these radiations appear to us in the form of luster. So hence metals have that property of lustrous. Okay, so another question is there any metal in liquid state other than mercury? So first, yeah, mercury is the only metal that exists in liquid state at room temperature, but all other metals that exist can be converted into liquid state when they are taken to a certain temperature. So if you take them to a high temperature, all the metals can be converted into liquids. So at standard temperature and pressure conditions, if you consider, mercury is the only one, but all metals can be brought to a liquid state when you take them to a higher temperature. Thank you.
Thank you, Anchal. Thank you for explaining. Now, let's watch the next video on pH indicators.
Approximately all liquids can be classified broadly into acid, neutral, or base. Acids contain high number of hydrogen ion. They taste sour, just like lemon, orange juice, or curd. Neutral chemicals such as water contain equal number of hydrogen and hydroxide ions. They have no taste. Bases such as baking powder we use to cook cookies and cake contain high number of hydroxide ions and are generally bitter. Other examples are soap and bleach. See the scale? Scientists use this scale called a pH scale to check how acidic or basic a liquid is. A pH value can be anything from 0 to 14. Neutral water has a pH of 7. Values from 0 to 7 are acids, with 0 being the strongest acid. Lemon with pH 2 is very acidic. Whatever comes within 7 to 14 are bases, with 14 being the most powerful base. Soap with pH 10 is basic but not highly basic.
A pH indicator changes color according to pH value when dipped in acid or base. Let's see if we can make our own pH indicator at home. We need paper, hibiscus flower, turmeric, 2 paint brushes, soap, lemon, and water. Squeeze out juice of 1 lemon. Mix 1 spoon soap powder with 1 spoon water.
Rub the hibiscus petals on the paper. This becomes your pH indicator. You can either use earbud or paintbrush to dip it in lemon juice and paint it on the pH indicator. You will observe the paper to turn red in color as lemon juice is acidic. Dip another brush in soap water or floor cleaner liquid and paint it on the pH indicator. You will observe the paper to turn blue or green as floor cleaner is basic. So the hibiscus turns red for acid, purple for neutral, green or blue for base.
Mix 1 spoon of turmeric with 2 spoons of water. Rub this paste on paper. Wait till paper dries. Once it's dry, use soap water brush to paint on paper. Soap, a base, turns turmeric red. Now, use lemon juice brush to paint on paper. Acidic lemon turns the turmeric back to yellow. So, turmeric turns red for base. This red turns back to yellow for an acid. Which pH indicator we saw today do you think is more useful? Hibiscus changes color more readily, while turmeric only changes color for acid once a base has also been applied. In fact, hibiscus indicator can be made to show each of the 14 points in a standard pH indicator.
So now let's start some fun painting with our homemade pH indicator paper.
Wasn't it interesting to see how we can use household materials to identify if substances are acids or bases? And also we can create some art. Now I request Kirti, Aparna and Reshmi to address a few questions from the audience. Please turn on your video and microphone.
Good morning, all. So I'll be taking few questions. So first question, why does hibiscus or turmeric change color due to
Milana,
acid?
could you please turn your video on?
It's on.
Okay, you can continue answering the question.
Okay, so the color change is due to the phytochemicals present in the plants. So in hibiscus, it's anthocyanin, which changes color to acidic or alkaline medium, and in turmeric, it's curcumin. The phytochemical is curcumin, which changes to alkaline medium. And also next question, so what are other household items which can be used to do pH indication? So we can use red rose, cabbage juice, or cherry juice, or red onion juice, apple skin, or radish skin also. The next few questions will be taken by a few of my friends.
Kirti, we are unable to hear you. please unmute yourself? Kirti, are you there? Let us move on to the next section. We'll get back to the questions after this. So our next section is mechanics. So let us see what exactly is force and look at the different laws, Newton's laws of motion.
Today we will learn about force. Do you guys like sports? In football, what do you think? How is the goalkeeper able to stop the ball? In cricket, how is the batsman able to hit the ball for a ball? Answer to. Today we will learn about force. Do you guys like sports? In football, what do you think? How is the goalkeeper able to stop the ball? In cricket, how is the batsman able to hit the ball for a boundary? And how is a player able to catch the ball? Answer to all the questions is force. But what is force? Force is a push or a pull on an object. For example, a golfer hitting the ball is a type of push wherein the force is applied on the ball through the stick, while a tractor operating on a farm applies a pulling force on the trailer. Now let's explore more about forces. A heavy object is pushed from both sides. When equal forces are applied, the block does not move. Now, when unequal forces are applied, the block moves in the direction of the larger force. And when the block is pushed from the same side, it moves in the direction of applied force. What do we observe? Forces applied on an object in the same direction add to one another and the block moves easily. And if the forces are applied in the opposite direction, the net force is the difference of the two forces and the block moves in the direction of larger forces. And if forces are equal, the block won't move. Let's do one more activity. Place a ball on the ground and kick it. Ball starts moving. Now kick a moving ball in the same direction. Its speed increases. Now try to block the moving ball. Its speed decreases. And for the last case, ball is kicked in such a way that it changes its direction. So what do we observe? On the application of force, a body at rest may start to move, or it changes its speed, or it may change the direction of motion. In conclusion, a force may bring a change in the state of motion of an object.
Hello students, my name is Vivek Upadhyay. Now let us look at the concept of Newton's third law of motion. The first two laws of motion tells us how an applied force changes the motion and provide us with a method of determining the force. Newton's third law of motion, that is also known as laws of action or reaction, states that for every action force there is an equal but opposite reaction force which act instantaneously. Forces always occur in pairs, equal but opposite. Let us look at some examples. This means that when you push on a wall, the wall pushes back on you with a force equal in strength to the force you exerted. Either force can be considered the action force or the reaction force. To the right of us, the creator is applying an action force on the wall. The wall is applying a reaction force on the creator. These forces are equal and opposite, but they are not balanced. Action and reaction force pairs don't cancel because they act on different objects. Let us look at some of the examples of Newton's third law of motion that we encounter in our daily life. You constantly use action-reaction force pairs as you move about. When you jump, you push down on the ground. The ground then pushes up on you. It is this upward force that pushes you into the air. To our right, we can see the man is exerting force on the cow, but the cow is exerting an equal force back on the man. One very important fact that we should consider while applying Newton's third law of motion is mass matters. There will be different accelerations for larger masses and for small masses. When you walk forward, you push backward on the ground. Your shoe pushes earth backward and earth pushes your shoe forward. Why do you move forward instead of the earth moving backward? The earth has an enormous mass, hence acceleration produced is minimal according to Newton's second law of motion. Since we have significantly less mass than earth, the same action will produce large enough acceleration to move us forward. Now let us look how rockets work. When the rocket fuel is ignited, a hot gas is produced. As the gas molecules collide with the inside engine walls, the walls exert a force that pushes them out of the bottom of the engine. What are the action and reaction forces in the rocket launch? This downward push is the action force. The reaction force is the upward push on the rocket engine by the gas molecules. This is the thrust that propels the rocket upward. Now let us look at an experimental video where rocket balloon is used by Mr. Irwin to show us the principle of rocket. You might not be able to fly a real rocket, but you can absolutely have a lots of fun with a rocket balloon. The material required for this experiment are long rubber balloon and a stiff straw. Tie one end of the balloon and insert the stiff straw in the other end. Blow air inside this long balloon through a straw and it will look like a rocket. Now hold from the other end, and the moment you leave it, it just goes up in the air like a rocket. It is because the air inside the balloon comes out and it pushes the balloon up in the air. You can do this experiment inside your room also. Or you can do this experiment with your friends and have loads of fun. Now let us look at activity 9.4. Suppose you and your friend are standing on a cartwheel. When the sandbag is thrown by the boy, the action force Fbs will be applied by the boy on the sandbag. The equal and opposite reaction force F-Bs will be applied on the boy. According to Newton's second law of motion, acceleration of the boy will be given as reaction force FVS dash divided by mass of the boy, which suggests that as the mass of the boy increases, the acceleration of the boy will be less and the cart will travel for the less distance. We can repeat this experiment with two persons on the same cartwheel, and we will find that the second cartwheel will have different acceleration than first cartwheel. Thank you.
I hope Newton's laws are more clear to us now. Let us take a few questions from the audience. I request Asif to turn on his video and microphone and take up a few questions.
Am I audible?
Yes.
Yeah, there are few questions. One of the question is, what is the difference between balanced forces and unbalanced forces? So unbalanced forces are like when two forces act on an object but are in unequal size, then it's unbalanced force. While if it is equal, then that would be a balanced force. The next question is something about contact and non-contact forces. So contact forces are like when you apply force on an object and it's in contact, like muscular force or applying a force while you draw water from a well, you apply force on the rope. Now take the case of a magnetic force. When you apply a magnet, what you see that it attracts iron when it is not in contact, even though it applies a full force. That is a kind of example of non-contact force. Now the next question is air resistance a reaction force? Yes, air resistance is a reaction force. Suppose you are running. So while running, you are trying to apply a impact force in the atmosphere. So as a reaction, air applies a resistive force on you. Now the next question is, what is momentum? Momentum is just simply the product of mass and velocity of an object. So if a body with low mass, suppose two bodies are there with equal mass. So the body moving with higher velocity or higher speed would be having a larger momentum as compared to the smaller mass. And one more question is, can we call the change in temperature a force applied because it makes the particle of matter move? Yeah, thermal, this comes into a thermal aspect. Yeah, a temperature, change in temperature causes a agitation, or you say kinematic energy, provides kinematic energy to the molecules. So in turn, that gives a force to its nearby molecules and produces a thermal force. And since there are no more questions.
Yeah, thank you, Asif, for answering the questions. Next, we will look at an interesting concept called as parametric excitation.
In the 1970s, the US banned a children's toy called clackers, saying that it was too dangerous for children to play. What if I tell you that the principle which made the toy so unsafe is also behind how we swing on the swings we find in the playgrounds and parks? Yes, playground swings. Today, I would try to explain to you guys the physics behind that. We are looking at how children are able to swing without anyone pushing them from behind. You can increase your speed and the height up to which you go without that push. This might be hard to explain for a lot of us, and yet we all could do it. This merely shows how well our body understands physics, yet our minds fail to explain how, and this makes the problem interesting. My name is Shrey, and let's get started. You see, while we are swinging, we are mimicking an easy physics setup called simple pendulum. You might have seen one in a clock somewhere. A simple pendulum is a point mass suspended from a rigid support with a long weightless thread. That would be the formal definition for a simple pendulum. And I'm guessing you might have heard of it before. And if you haven't, you're going to. They are quite famous among science. They are quite famous among science students. And the reason behind that is a simple pendulum is an example of simple harmonic oscillator. The idea behind giving a name simple harmonic oscillator to a heavy object swinging by a thread is that the oscillations this pendulum does is special. It takes the exact same time to come back to a certain position no matter how long it has been swinging. That might not seem so special, but it is. You see, pendulums could swing practically for long periods of time without changing the time they take between two oscillations. And for this reason, we could use them for measuring time. Like a stopwatch, they are very accurate and reliable. Let's come back to swings. You see, when we are swinging, we have certain energy within us by virtue of which we are able to swing. This energy is mechanical in nature, which means that this energy has either taken us up or is moving us at a velocity. While we swing, when we reach extreme positions, all this energy has taken the form of potential energy. And when we are at the bottom, all this energy has taken the form of kinetic energy. And that is important because you see, if we had more mechanical energy, we would rise higher or swing faster. And that is precisely how one swings. We are somehow able to increase our energy mid-flight, and that is why we could go higher and higher. You could imagine if I push the pendulum every time it comes down, it would eventually go higher and higher. But we could do it without that push as well. And that is by changing the parameters of the oscillation of this pendulum. It is hard to explain what I mean by parameters of this oscillation, but eventually I'm trying to pinpoint the things that decide the physics of this problem. And we could dig deep into rigorous math to find out these parameters for ourselves. But we actually don't need to do that to keep understanding the concept. It boils down to by changing the length and acceleration due to gravity, we could pump our swings. Let's see a demonstration. Hi, I have with me a nut. It is quite heavy and a thread tied to it. I will be using it to demonstrate how simple pendulum works. Initially it is at rest, all the forces on this nut are balanced, and you just need to give it some push, either give it a push or leave it at some height, some angle. So leave it at some height and it will start oscillating. The first thing I wanted to show you is how changing the length of the thread would pump the pendulum. Now, what pumping would mean, I'll just show you. So let's start the demonstration. I leave the nut at some angle and it will start oscillating. Now observe my hand. I will be pulling my hand, and as a result, the thread will be pulled. Okay. If I do it at correct time intervals, I would be able to pump the pendulum faster. And so see, the nut has already gone out of the frame, and you might have noticed the speed with which it is moving, evidently increasing the energy of the nut. Okay, so that is one way of pumping the pendulum system. One other way is by changing the other parameter of this oscillation, and which is acceleration due to gravity. So acceleration due to gravity could be understood as an intensity of the force with which the earth pulls us. So when I talk about the acceleration due to gravity, I am talking about the intensity of the force in terms of the weight of this, right? And I can change this intensity by pulling it up, right? So I'll show you, if I do it at correct time intervals, this will start to accelerate. Okay. So you might have started noticing it. That seems nice. Right. And this is basically the principle of the clacker's toy we were talking in the starting of the slide, right? Now, one more thing. Why is this happening, right? Why changing the length or changing the acceleration due to gravity is pumping energy into the nut thread system. Well, you see, this is a good example of conservation of energy, right? When I have given this nut some push, I have given it some kinetic energy, right? And which is kinetic energy is an example of mechanical energy, and this energy is getting converted into the two forms, the kinetic and the potential energy, right? Meanwhile, this oscillation keeps happening if I start doing work on the system by either pulling this system, pulling the thread, or let's say pulling the system as a whole and doing some work. And this will pump the oscillation because the work is increasing the energy content of the system. Okay, thank you. So that is how the parametric excitation works. But you see, on swings, we don't have the liberty to pull the chain or the swing itself mid-flight. Then how do we pump in energy? Watch closely how this child leans back when he comes down, bending the chain he holds. Primarily by bending the chain, he shortens the effective length at which he swings. The blue dot represents where this child's weight would have been concentrated if he had not leaned back. But now, when he bends the chain, that point changes and shortens the effective length at which he swings. He bends the chain every time he comes down for one reason. Doing at the correct time intervals or time instants, this pumping will happen faster. The toy clackers worked on changing the acceleration due to gravity principle to pump the toy, and as a result, the two bobs in the toy used to make violent collisions. There were cases when these would shatter and hurt children around, so eventually they were banned. This was the gist of it. I hope you got it. Thank you for participating. I'll be very happy to answer any questions you might have.
Wasn't it interesting to understand how we pump our swings to fly higher and higher? Now let us take a few questions from the audience. I request Ray to turn on your video and microphone and please answer a few questions.
Good afternoon, everyone. Am I visible and audible?
Yes.
So hi everyone. I was going through some of the questions. There is a very interesting question which is that can we convert the kinetic form of energy into chemical? Well, I before the video didn't know as well, and I searched on it, and turns out you cannot, because you see, uh, chemical energy is basically the energy associated with the chemical bonds inside, let's say, our object, and kinetic energy is kind of macroscopic energy as a the system or the object holds as a whole. So, like if you push a system and it is moving at a, let's say, velocity, it has kinetic energy, but for it to be converted into chemical energy, you would have to change the chemical composition of the object, right? So that is one good question. I'm going through some of the questions. Does the length of the string in the pendulum affect the amount of kinetic energy? Well, indirectly good. You see, if you increase the length, and you're not changing other parameters of the, let's say, oscillation, what will eventually happen is that your velocity will decrease. But to be very specific, kinetic energy is only a property of mass of the system and the velocity with which this system, or let's say some nut, or let's say some object, is moving, right? Why do we go high when we pull the chain? Okay, so that is the point, right? How could we pump the pendulum, right? How could we pump our swings? So this is basically conservation of energy. So you can't create or destroy energy, and one way to increase the energy of your system, or let's say of an object, is by pushing some energy into it, by giving it some energy. And you can give some energy to something is like you can do some work on it. So let's say if I start clapping, I'll soon start to feel the heat in my hand, right? If I beat my hand fast, I'll start to feel some energy or some heat into it, right? So one way of doing this thing is by increasing the like by doing some work on the system, and pulling pulling the string is actually doing work on the system. So that is the gist of it. We are increasing the energy of the system by doing some work on it. Okay. So how does yes, Rudy, do I have some like limited time or something?
Yeah, you have 30 more seconds, Shrey.
Fine. So I'll answer one last question. How does the acceleration of gravity affect the pendulum? So eventually, you see, the pendulum is moving because of the force due to gravity. And if your acceleration due to gravity changes, effectively the force on the pendulum would change, and that would change the whole dynamics of it. So it is one of the biggest parameter, and that is how clackers work. We change the acceleration due to gravity. So I think that answers the question. Thank you.
Thank you, Shrey, for nicely explaining the concept. Now let's watch the next video on friction.
Have you ever wondered what is friction and how does it affect our day-to-day life? Today, we will explore the force of friction, how is it caused, and what are the factors on which it depends. You may have noticed the sign on wet floors to be careful while walking. Can you guess why is it difficult to walk on wet floors? To move the bicycle, we apply force on the paddle. How does it move forward? When we rub our hands against each other, it feels warm. Do you know why is it so? Have you noticed striking matchstick against matchbox? It catches fire. Can you guess why does that happen? The answer is friction. The reason why is it difficult to walk on the slippery surface is because of the friction between footwear and the floor. We are able to ride bicycle on road due to friction between the tires and the road. Our hands feel warm because of the force of friction. The matchstick catches fire due to the friction between matchstick and the rough surface of matchbox. So what is this friction that we are talking about? It is quite easy to understand. Friction is the force that opposes the relative motion between two surfaces in contact. Friction between our foot and surface helps us to walk. Due to wet surface, the friction becomes low and it becomes difficult to walk. There are chances we might slip and fall. Force of friction offered by the road on the tire makes it able to move forward. If the friction is zero, the bicycle will not move at all. Friction is responsible for generating warmth in our hands. When hands come in contact and are rubbed against each other, there is some resistance due to the irregularities present on the palm of our hand. When a matchstick is rubbed against a rough surface, some amount of heat is generated, and this heat is sufficient for the reaction that ignites the matchstick. The matchstick usually fails to ignite when we rub it against wet matchbox because water lowers the force of friction. Let us learn more about friction. We will now see what are the factors that affect the force of friction. Let's do an experiment. We will roll an object on two different surfaces. One is smooth with small irregularities and other is rough with large irregularities. We will roll the object from the inclined plane. Can you guess in which case the object will go further? Let us see now. First we roll the object on the rough surface and mark the distance it travels. Now we roll it on a smoother surface and mark the distance that it covers. So what did you notice? The distance traveled by the object on rough surface is less. Can you guess why? It is due to the higher force of friction in case of rough surface. Why is it so? It is because of the large irregularities on the surface. These irregularities on two surfaces lock into one another. Whenever we need to move an object, we need to overcome these irregularities. On rough surface, the irregularities are more, and hence we need more force to overcome them. This causes a higher force of friction on rough surface. So the first factor affecting friction is the nature of surfaces in contact. Can you think of any other factor? Let us consider another experiment. We have two objects of different masses placed on the smooth surface. The surface of both objects is same. We apply same force on both the objects using rubber band. Which mass do you think will go further? First we apply force on a heavier object and observe the distance it travels. Now we apply the same force on the lighter mass. You will notice that the lighter mass travels more distance than the heavier one. So what does this tell us? It tells us that the friction also depends on the force with which the two surfaces are pressed together. If the surfaces are pressed harder, the friction will be more. Why is that? The heavier object presses the surface harder and the interlocking between the surface irregularities is more. Thus more force is required to overcome them. This results in more friction. So what have we learned today? We have learned that the force of friction opposes the relative motion between two surfaces which are in contact. The force of friction depends on two factors. One, the nature of surfaces in contact, and two, the force with which two surfaces are pressed together.
You all have seen the video of how friction works in a very simple and beautiful way. Now let's watch another video on rolling friction.
Now we'll discuss about rolling friction. First of all, let me ask a few interesting questions. Have you ever thought about how we walk? And how does a squirrel climb the tree without falling? And why does a moving object stop after some time? So what is the reason behind all these questions? The answer is friction. So what is friction? Friction is a force that opposes the relative motion. So let us understand about the types of friction. Static friction is a force that tries to keep an object at rest. The sliding friction is a force that opposes the relative motion when a body is moving on another. Whereas the rolling friction is an opposing force when one body rolls over another. So let us understand these types of friction by some exercise. Try to move a sofa by applying some force. What will you observe? There is an opposing force to the applied force. This force resists the movement of sofa, and this is called as static friction. After some time, the sofa starts moving when you apply more force than the static frictional force. once the sofa starts move, you will experience less opposing force, and this force is called as sliding friction. So we'll observe that the sliding friction is less than the static friction. Suppose that sofa has wheels to roll on the surface. Now we can move the sofa very easily because the opposing force is very less. And in this case, the opposing force is the rolling friction. So we can feel that rolling friction is less than the sliding friction. So what do we observe from this exercise? Rolling friction is less than the sliding friction, and which is less than the static friction. Now let us perform an activity to understand about rolling friction and sliding friction. An activity is performed to understand the rolling friction. To perform this activity, we need few pens and a thick book. Now place these pens on the surface at a uniform distance. Place the book on the pens and now push the book gently by applying some force. Observe the distance the book has traveled. Now repeat the same experiment by removing the pens. That is, push the book gently by applying the force in the same manner. And observe the distance it has traveled. In both cases, the book stops after traveling some distance. Why? This is due to a force is opposing the motion of the book. We can see that when pens are kept under the book and the book is moving, then the pens are rolled on the surface. And the force opposing the motion of the book in this case is due to the rolling of the pens and is called rolling friction. Whereas when the book is moving on the surface, the force opposing the motion of the book is due to the surface and is called as sliding friction. From this activity, we can observe that the book has moved a larger distance when pens are kept under it. And this is because the rolling friction is less than the sliding friction. Hence, by placing the pens under the book moved easily. And now think about direct of examples where rolling friction plays a role. The first example is tire, and next one is skating, where we can feel the rolling friction concept. Also, in industries, heavy machinery can be moved with the help of rolling friction concept. By adjusting the wheels under the machinery, it can be moved easily. A small example for rolling friction. So what can you see from this picture? Everyone is sliding in the queue except this guy. This guy made this cube into sphere and moving faster than others. So this is because the rolling friction is less than the sliding friction, and hence this guy is moving faster. Thank you.
We have seen the video on friction and rolling friction. Now let us call upon our volunteers to answer some of the questions. I request Iqbal to switch on your camera and unmute your microphone.
Yeah, hi, thank you, Gautam. I hope I'm audible and you can see my video, right?
Yes, Iqbal.
Yeah, so there are quite interesting questions. So the first one is,
friction, is it essential or evil? So the answer is, in short, it is both. In some cases, it is essential, while in other cases, it is evil. So for example, if the friction is not present, we will not be able to walk on the road. So in that case, friction is necessary that will help us to walk. Similarly, when we ride a bicycle and suddenly something comes in front, we have to apply brakes. So again, friction is important there. But in some cases, it becomes difficult. It acts as an evil. For example, if you continuously walk using a slipper or a shoe, you'll observe that the sole wears out. So in that case, friction acts as an evil. So we don't want the friction to be present there. So sometimes it is a necessary, and whereas in other cases it is an evil. Now moving on to the next question. Next question is, uh, can we make an environment without friction? So it is impossible to avoid friction completely, because as we have seen, friction is because of the irregularities on the surface, and every surface, however smooth though it looks like, there are always irregularities on the surface if you keep on zooming in. At some level, at some stage on the microscopic level, we'll observe that there are irregularities present. So whenever two surfaces come in contact, these irregularities acts as a resistance to motion. So friction will always be present. We cannot completely avoid it. And yeah, so another question is, what makes friction low on wet surface? So to address that, so what we can think of is, when we apply water or soap water on the floor, and we try to walk on it. In that case, the footwear or the slipper that we are wearing, it does not come in contact directly with the floor, and there is always a layer of lubricant, or we can say the water, present in between. That makes the irregular contact between irregularities less. So friction becomes low, and it becomes difficult to walk. And I hope you would have seen signs that we have to be very careful, because we might fall and you might injure yourself.
Yeah, Iqbal, you can take one last question.
Okay. Yeah. So another question is friction and force same? So the answer is yes. Friction is also a type of force, but it always acts as a resistance. It always acts in the opposite direction to the motion, and thus it always opposes the motion of the body. So yes, it is a force, but it always acts in the negative direction. So it opposes the motion. Thank you.
Thank you, Iqbal. Now I request Satvika to take some questions on rolling friction.
Hi, I hope I'm audible.
Yes, Satvika, we can hear you.
Yeah. Few interesting questions is, why is rolling friction less than the sliding friction? So when one body plays over another, there will be some irregularities over the surfaces of the body, which will be interlocked, and this is where the friction comes into role. And what happens is, like one body during sliding friction, one body moves over another body, and here there will be contact, like area of contact is more, and so the interlocking between two bodies is more, and so we require more force, like the sliding friction is more than the rolling friction. For suppose, if you think about a rolling friction, this is just a coin. So if we want to move a coin over the surface, then the point of contact between the coin and the surface is very low, and so less area of contact is taken place, and less interlock forces are there, and so that is why rolling friction is less than the sliding friction. And another question is fluid friction more than the sliding friction and rolling friction? So few ways to reduce the friction are to use a lubricant or to use the grease. So we can understand from that thing, the fluid friction is less than the sliding friction and rolling friction. Yeah.
Satvika, you can take one last question.
Why rolling friction is less than static friction? So the static friction is a force that tries to keep an object at rest.
So what it does is like here also the same concept, like in the static friction is caused when initially there is no movement between two surfaces. So when one body is placed over another for quite some time, there will be interlocking between these two surfaces. Like the interlocking will be very well managed, and so to apply the force to break the interlock, there will be more force requirement. Whereas in rolling friction, the area of contact is less, and hence we can the rolling friction is less, and we can break the interlocking force easily.
Yeah, thank you, Satvika. Thank you for the explanation. You have seen videos on friction and rolling friction. Now you know that what made you fall on a wet floor or when you step on a banana peel. So be careful while walking on a wet floor next time. Now let's watch a video on pressure exerted by liquids and gases.
Hello everyone. In this video, we'll be discussing about the pressure exerted by liquids and gases. We all know that there are many instances in our day-to-day life which involve pressure exerted by liquids and gases. Some of them are like football, a submarine, or simply our gas balloons. In this video, we'll try to understand about the pressure exerted by liquids and gases separately. We'll also see some experiments which will be demonstrating the effect of pressure exerted by both liquids and gases. Okay, coming to pressure exerted by liquids. Here in the first picture, we are seeing that this man is applying force to stop the jet coming through the hole, right? Why do you think he needs to apply force to stop the jet? Now, coming to the second picture. Here you are observing a submarine, right? Why do you think the submarine has to be so robust or strengthy as seen here? These questions can be answered by understanding the concept of pressure exerted by liquids. Pressure is the force that is acting over a unit area of a medium. In case of liquids, the pressure is exerted due to the liquid that is above a particular section. If you consider a tank of unit area as shown here, the section shown in green color experiences the force due to the liquid that is present above it. This force is the pressure exerted by the liquid at that section. Okay, now let us consider some features associated with pressure exerted by liquids. The first feature is that the liquid exerts pressure on the solids that are in contact with it. We all know liquid needs a solid container to hold it. If we consider a tank containing liquid as shown here, now in this tank we already know that all the locations in the tank experience pressure due to the liquid above it. In the same way, the solid base at the bottom also experiences the pressure P due to the liquid above it as shown here. Similarly, the solid walls at any location also experience some pressure P1 as shown here. To understand this, let us do a small experiment. In this experiment, we demonstrate the pressure exerted by liquid on solid walls of a container. The materials required are a normal water bottle with a hole at a location, an outlet pipe, a plastic tag, and a balloon. The outlet pipe is attached to the hole of the bottle and a balloon is attached to this pipe. The final assembly looks like this. Initially, the balloon attached to the bottle outlet will be flat as shown here. Now, let us fill the bottle with water. As we do so, the pressure at the hole location or the balloon location increases. As this pressure increases, the force on the balloon walls also increases. Hence, balloon gradually bulges out as shown here. This simple experiment thus demonstrates the pressure exerted by liquids on the solid walls of a container. The second feature that we will see is that the pressure depends on the height of the liquid column above it. It is obvious from our understanding that the pressure exerted by liquids at a location is due to the liquid above it. So, as the depth of a location increases, the pressure at the location increases simultaneously as shown here. This effect can be understood through an experiment by considering a bottle with holes at different heights. So, the materials required for this experiment are a bottle with holes at two different locations and outlet pipe. The final assembly looks like this. Initially, we fill the bottle till the top by closing the holes. Now, as we open the cap, there will be a water jet passing through both the holes as shown here. As the liquid discharges, it can be seen that the jet through the top hole falls at a location nearer to the bottle compared to the jet from the bottom hole. Once the liquid crosses the top hole, the jet from the bottom hole behaves in the same way. That is, the position where the jet falls on the ground decreases as the height of the liquid above the hole reduces. This happens due to the reduction in pressure. This simple experiment thus illustrates that pressure at a location depends on the height of the column above that location. As we understood that the liquids exerts pressure on the solids and this pressure magnitude increases with height, now we can think of a submarine. We know that submarine travels at very deep locations inside a sea. Hence, from our knowledge on pressure exerted by liquids, it is obvious that submarine must sustain very high pressures exerted on it by the liquid in the sea. This is the reason why a submarine must be so strengthy. Coming to pressure in gases. Let us see some real life examples. What are you observing in this picture? A person is pumping the cycle tire, right? What do you think he is doing to the tire? Similarly, the other person is blowing a bubble gum, right? What do you think he is doing by blowing a bubble gum? Some common examples where we experience glass pressure also include a football and our pressure cooker. Let us understand these examples by exploring the concept of pressure in gases. As mentioned earlier, pressure is the force acting per unit area of a medium. In case of liquids, the pressure is due to the height of the liquid above a section. However, in case of gases, the molecules are freely moving. During this motion, they collide with each other as well as with the walls as shown in the picture. To understand how the pressure in gases will arise, let us consider a gas balloon. If we consider a unit surface area of this balloon as shown here, the force caused on the walls of the surface due to the collisions of gas molecules is the pressure exerted by the gases. So, higher the number of molecules, higher the collisions, and higher the collisions, higher the force. So, this is what happens when we inflate a tire or blow a bubble gum. We are adding more number of molecules to increase the pressure in tires or a bubble gum. Now, the pressure exerted by the atmospheric gases around us is called the atmospheric pressure. Now that we have understood the pressure exerted by liquids and gases, let us see some simple experiments involving the effect of both pressure exerted by liquids and gases. Till now, we have performed some experiments where we have used a water bottle with some holes. Using this, we have demonstrated some features of pressure in liquids. But did you think what is happening at the top of the whole bottle? Can we have a jet through the whole of the bottle independent of whether the bottle is open or closed? Let us understand this by doing a simple experiment. The materials required for this experiment are a water bottle with a hole and an outlet pipe. The final assembly looks like this. Now, initially when the bottle is filled with the water and closed with the cap, there is no flow through the outlet, right? Now, let us see what happens when we open the cap. So now you can observe a jet coming through the outlet, right? Now, if we close the bottle again, let us see what happens. So, when we close the bottle, the flow stops again. So, we observe a flow only when the bottle is open, right? Let us understand the reason behind this happening. Now, consider the open water bottle. The external pressure at the outlet is always the atmospheric pressure, while the internal pressure varies depending on the condition. When the bottle is open, the internal pressure at the outlet is the sum of the atmospheric pressure and the liquid pressure. So clearly the internal pressure is considerably higher than the external pressure. Hence, we see a jet in case of an open water bottle. Now come to the case of closed water bottle. Here also the external pressure at the outlet is atmospheric pressure. But the internal pressure now is reduced as the bottle is closed. It is the sum of the liquid pressure and the gas pressure due to the gas trapped above the liquid. So in this case, the external pressure is higher than the internal pressure. Hence, we will not see any jet. Now, let us see another simple experiment emphasizing the effect of gas pressure. This experiment is known as the water fountain experiment. The materials required for this experiment are a water bottle with holes at a height nearer to the top as shown, and also a cap with a hole, a balloon and few plastic straws. The final assembly looks like this with the straws immersed into the bottle through the holes. Initially, even though the bottle is open, there won't be any flow as the holes are not at a deeper location like earlier cases. Now, we fix an inflated balloon to the bottle by using the cap with a hole as shown here. Let us see what happens. So, we can see that there are jets coming out of all the outlets. Let us try to understand what is happening here. Here, the gas pressure due to the gas in the balloon at the top increases the internal pressure at the outlets and makes it higher than the external atmospheric pressure. Hence, we see the jets coming out of the outlets seeming like a fountain. So, what did we learn? We understood the pressure exerted by liquids and gases and some of their features. We explored some daily life events associated with this topic. We also observed some interesting experiments involving the pressure exerted by liquids and gases. Thank you.
Isn't it interesting that we can understand the concept of pressure exerted by liquids and gases by just using the simple equipments like water bottle, water, and some other equipments like straw, balloon, etc. Now let's watch our next video on surface tension.
Hello everyone, today we are going to talk about surface tension. Now the first question is, what is surface tension? So surface tension is the ability of a liquid to allow objects to float on top of it. So this is just in a crude manner. We'll look at the molecular picture and try to understand what causes surface tension. Consider this pool of liquid. So we have this bulk liquid, a water-air interface and air. Now the surface tension arises due to the cohesive interactions between the molecules in the liquid. At the bulk of the liquid, the molecules have neighboring molecules on each side. So that, like, look at this molecule. It has this and these 6 molecules on it each side. And they all are pulling it towards them with equal force. So that the net force on this particular water droplet or a molecule is 0. So thus this molecule appears as a happy molecule. Now if you consider a water molecule at the surface, that is at the interface of the liquid and air, you'll see that it has less neighboring molecules. It is not having any neighboring molecules at the top. So thus it is experiencing net inward force. So the surface is always pulling inwards. Now this difference in force packs the water molecules at the surface closer together than they are inside the liquid, which causes a net force inward towards the liquid. Now this force resists the breakage of the surface and it is called surface tension. So you can consider that the molecule at the surface is unhappy because it is unequally pulled from all the sides. It is not equally pulled from all the sides, and surface tension tries to make this a happy molecule. So in short, a liquid surface can be thought of as a stretched membrane characterized by a surface tension that opposes its distortion. Now let's see some effects of surface tension in the nature. In rainy season, you would have seen that water droplets which are there on the leaves, they appear as spherical droplets. Also, you would have also played with soap bubbles, or so you have a frame, circular frame or triangular frame which you put it in the solution and you blow off air and spherical bubbles are formed. Also, you would have seen that if you put a capillary in a pool of water, liquid rises in the capillary. And there are some objects which can float on water. There are some insects which can walk on water, like water strider. So all these things are there in the nature due to this surface tension. We'll try to understand it with help of some experiments. So the first experiment we are going to perform is thread loop in a soap film. Now let's see what you all need to conduct this experiment yourself at home. You need a tray or container. You can also take a plate which can hold some water. You would need a soap or detergent, and of course you need water. You'll need some closed frame. It can be rectangular, square or circle, anything. You can also borrow a bangle from your mom if you don't have anything else. So you can have, if you don't have any closed loop, then you can take a rigid metal wire and just fold it in the shape as you like, and you can also use that for this experiment. You'll also need some thread, a pen, pencil or needle, or any object which can be used to prick the soap film. So the very first step is, now you have to make soap solution by dissolving soap in the water. And next, make some closed loops from this thread. Just make a knot over here and a closed loop will be ready. Now let's see this experiment. So first you take the soap solution in a tray and a frame. So over here I am taking this metal ring. Now you just put it in the water, shake it a bit, and soap film is created. Now just put a thread loop on top of it. You will see that it is irregular in shape. See that it's irregular in shape. Now as soon as you break the soap film inside this thread loop, it becomes circular. You can see that pen can move in and out. There's air inside that circular thread loop. You can move it around, it will not break. Let's try to understand what just happened. Before, as soon as I put the thread loop on the soap film, that is before just breaking the soap film inside the thread, then at each point on the thread along the tangent, it was experiencing equal and opposite force. Thus, at each point these forces were balancing and net force was 0. So the loop remains as it is, that is in a random shape. Now when you break the soap film, now over here we have air and here we have the soap film. Now this loop is experiencing only outward force from the soap film and there is no net inward force. Thus the net force is only outwards, and this experiencing outward tension by the thread, this is surface tension. So this thread, why does it acquire only circular shape? Why not triangular, rectangular or any other shape? Because for a given parameter, a circle has the maximum area. So if it forms a circle, the rest of the soap film will acquire minimum surface area. Thus we'll have minimum surface tension. That is why it acquires circular shape. Now we'll see another experiment which is also a very interesting one, which is the floating paper clip. What you all need to have for this is you need a beaker or mug. Any transparent container would work, which can hold some water, some metal paper clips, Q-tips, paper and soap solution. You can also use tissue paper. Now let's see this experiment. So I have this beaker which is filled with water. Now first I will place this paper clip inside it. It sinks. Why it sinks? Because its density is higher than that of water. So due to gravity it just settles down. Now what I am going to do is I'll bring a paper clip which is kept on a tissue paper or any paper. You just let it allow the paper to wick fluid. Now as the paper absorbs fluid, now just slowly with the help of Q-tip, try to separate this paper from the paper clip. You have to carry out this step very slowly such that you don't disturb it very much. If you will use force while removing paper, the paper clip will settle down. So you have to do this step very gently. See, half of the paper is removed. And I am trying to remove the other part as well. Yeah, it is removed. So now we can see that paper clip is floating on the surface of water. Isn't it interesting? Earlier it sank, now it's floating. Well, this could be explained due to surface tension. But we'll just extend this experiment and see what happens if we place some fresh water in this. Will it sink or will it still float? Let's find out. Here I'm adding water. It's still floating. That's good. Now let's try the same thing with a soap solution. What happens if I add soap solution in this liquid? Here I'm adding soap solution and see what happens. Oh, it sinks. Why did this happen? Because detergent lowers the surface tension of water and therefore the paper clip sinks. Now we'll understand this. Why in the first place the paper clip was held by the water surface? Because water has very high surface tension. So as I explained earlier, the cohesive forces between the molecules is what causes surface tension. The stronger the cohesive forces, stronger will be the surface tension. Now where do these cohesive forces come from? As you would know, water means H2O. So it has one oxygen molecule and two hydrogen molecules. So due to the electronegativity of oxygen molecules, it has some negative charge on it. Let's say delta negative. And hydrogen has some positive charge on it, delta positive. So in this way, one water molecule can interact with another water molecule, that is hydrogen of this molecule is interacting with the oxygen of the other water molecule and forming a bond. Such bonding is called hydrogen bonding, which are quite strong bonds. And these lead to the strong cohesive forces between the water molecules. And this results in higher surface tension of the water. Now what you can try is, what would happen if instead of water I use milk and try to float paper clip on that? Will it still float or not? You can also try it with some juice or any other liquid. You can use oil and see what happens. That's for you to do at home. Let's see another experiment, which is using black pepper and soap. So for this, again, you would need a tray or a plate, some water to fill it, black pepper powder, Q-tip and soap solution. We'll see how this experiment works. So I have a tray which is filled with water. You can also take a plate and fill it with water. Now I will sprinkle some black pepper on it. You will see that black pepper floats on the surface of water because it is lighter than the water. See, black pepper is floating on the surface. Now, it's floating. Now take some liquid vim or a soap solution and just add it on the Q-tip. If you don't have a Q-tip, you can use a finger and place some soap solution on your fingertip. Now place this Q-tip with soap in this solution. See? Wow, the black pepper just moves away from the Q-tip. Isn't it magic? We'll find out. Why this happened? Because detergent lowers the surface tension. So a detergent molecule has two ends which enable it to break the surface tension of the water. The end of the detergent molecule, which can attach to oil or fat or grease, and it repels water molecules, is the hydrophobic tail. This is the hydrocarbon chain which is hydrophobic. And the other end is hydrophilic, which loves to stay with water. Now, this hydrophobic end, it attempts to move away from the water molecules and thus it pushes itself up to the surface. Now, this weakens the hydrogen bonds holding the water molecules together at the surface, and this results in the breakage of surface tension of the water. So, you can do a simple experiment at your home. Take a coin, or you can take aluminium foil, or you can take butter paper, anything you can take. Just place liquid water on top of it. You'll see that it bulges around, it forms a droplet. Now add some detergent or bring soap solution to it. It spreads, it flattens out. So when the surface tension is lower due to the addition of detergent, the water tends to spread out. So as the water flattens on the dish in the experiment which we have just seen, the pepper that is floating on top of the water is carried to the outer edge of the tray as if it was magic. It's not magic, it's actually surface tension. I hope you have understood the concept of surface tension with these three simple experiments. And that's all. Thank you so much.
Those were very interesting experiments. I hope all of you tried out at home. I now request Chetan to turn on his video and microphone and take a few questions from the audience.
Hello. Yeah, I think I'm audible and my video is coming. The first question is how the water stops flowing after you close the bottle. So as I explained, when you close the bottle, the pressure at the hole, including which is the sum of air pressure as well as the liquid pressure above it, so that may not be higher enough to go compared to the atmospheric pressure. So in that case, you will not have any flow. Whereas when you open it, the pressure, like atmospheric pressure, includes the adds to the water column above it, and that will become higher than the outside atmospheric pressure, and so you'll have the flow. And how the helium filled balloons fly high. So in case of helium balloons, so that is they fly high because of the buoyancy forces. So inside the balloon, the volume occupied by the balloon is very high, so that causes very high buoyancy forces, which makes them go to reach very high heights. And why is pressure low underwater? Actually, underwater pressure is not low, pressure is very high. As I told, pressure is a function of height. So as we go deeper into deeper, the pressure will become much higher. That is what the submarines has to face. And the other question is, why pressure is more in liquids and gases than solids? Actually, we can't relate liquids in pressure in liquids, gases, and solids, because in gases it depends on, like, gases means they are far apart in gases. Molecules are far apart, so their pressure is dominated by other factors like temperature as also the volume occupied by the gas. Whereas in liquids, it is more of like comes because of the gravity, the height of the liquid above a particular section, and solids, again, the weight of the bodies come into play, which cause the pressure. And the other question is, how much unit average ocean or water body gives pressure? I didn't understand the question clearly, but if you are asking for the general units or order of magnitude, it will be in general like based on height, so it will be in the order of around kilopascals to megapascals also. And
Thank you, Chetan, for answering these questions. I now request Priyanka to answer a few questions from her demonstration. Priyanka, please turn on your camera and microphone. Priyanka, are you there?
Yes, I'm there.
Yes.
Am I visible? Yeah. Okay, so first question which I'll answer is, why soap bubbles are only spherical in shape? This is because a surface tends to attain always a minimum area, and for a given volume, if you do some mathematical calculations, you'll find that sphere forms the minimum surface area for a given volume. The other question is, will the thread turn into the shape of the object or will it be circle itself? So in the soap film experiment, you will always need a closed thread loop. So it always forms a circle, no other shape will be formed, because again for a given perimeter, circle forms the largest area, and the surface tension over there is in the soap film. So if you want the less surface, then you need larger area which is occupying the air. Now the other question is surface tension is applied in cars while driving? No, surface tension is the concept. It comes when you have an interface between two fluids, that is liquid and air. So in cars, I can't really relate. And when we do I have more time?
You can take one more question.
Okay. When we dip soap by Q-tip and put it inside a blown balloon, why didn't it burst? Since the volume inside the volume of liquid inside the balloon will remain same, so it will not burst. There is nothing which.
Okay, thank you, Priyanka, for answering these. We will now move on to our next segment, looking at the experiments on sound.
Hello friends, today I'm going to talk about sound. What comes to your mind when I say sound? Music? Or dog's bark? Or train horn? Let's explore the sound together. Before starting, I would like to ask you a question. Can we visualize sound? What do you think? Let's do some experiments. Here it goes. Experiment number 1. For this experiment, first you need a container. Make sure it's open on the other side. If you don't have a container, you can use a box. It's just that there should be opening. Second, you need salt. And third, you need plastic wrap. If you don't have plastic wrap, you can use normal plastic. Lastly, you need a pipe. Next, what you do is cover the container with plastic wrap tightly. Make sure it is tight. After that, you put little salt on the plastic wrap. Next, put the pipe inside the container through the opening. Now make some sound from your mouth. When you do that, you can see a pattern forming on the top. Make different sounds and observe the pattern. Now we'll do another experiment. For this experiment, we'll use same setup as before. Instead of pipe, we'll use speaker. Put the speaker inside the container. Put a little bit of salt on the plastic sheet. For this experiment, you need to install an app called Frequency Generator. This app is used to create sound of various frequencies. When you change the frequency of the sound, you can see different patterns based on the frequency of sound. This one is just to show you the pattern we got when you play the sound of 260 Hz frequency. It looks scary, right? Just put some music and see how the pattern keeps changing. Okay, let's go to experiment number 3. In this experiment, instead of salt, just pour water on the plastic sheet and put the sound of some frequency. In the water, you can see the pattern like we saw when we used salt.
Volume increase. Start.
Now we'll do another experiment. For this experiment, you need a toy laser and a small piece of mirror. Stick the mirror piece on the plastic sheet. Point the laser on the mirror. Now you can see the reflection of laser on the wall. Using the frequency generator app, play the sound of some frequency. Instead of point, you can see different geometric shape. Now when you change the frequency, the shape also changes.
Start.
can see complicated patterns emerging when you put some music. It was fun doing the experiments. Now let's try to understand the science of sound. You might be wondering how sound is produced. Sound is produced by vibrations. Vibration is a to and fro motion of the object. In this picture, you can see the diaphragm of a speaker moving to and fro. The vibration is causing the particles bouncing off. Now let's understand how sound waves created by these vibrations travel. This setup is same as we did in experiment. We have source of sound, that is speaker, the thin membrane, that is plastic sheet. There are layers of air molecules between the speaker and the membrane. When speaker is not producing sound, there is no effect on the layers. So once the speaker is turned on, the diaphragm starts vibrating and it pushes the first layer of molecules. Similarly, the first layer hits the second layer hits the third, and so on. This disturbance travels throughout the layers and finally it hits the membrane. This causes the membrane to vibrate. That's how we were able to see the patterns on the plastic sheet due to the sound waves hitting on the plastic sheet, which caused it to vibrate. When the diaphragm of speaker moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called a compression. This compression starts to move away from the vibrating object. When the diaphragm moves backwards, it creates a region of low pressure called rarefaction. When the diaphragm moves back and forth rapidly, a sequence of compressions and rarefactions is created in the air. As you can see in the picture, compression is the region where the particles are crowded together, and rarefaction is the region where particles are spread out. So propagation of sound can be visualized as propagation of pressure variations. The sound wave can be shown in a graphic form. The peak or crest represents the region of maximum compressor, or the region where the density and pressure is high, whereas the valley or trough represents the region of rarefaction where the pressure is low. Look carefully, you can see the propagation of sound as the propagation of disturbance, but not the movement of particles forward, just the disturbance that is carried forward. Particles, which are shown by red dot, are just moving to and fro about their mean position, but they are not traveling. You can see compression and rarefaction pattern in Slinky. You can get the Slinky and try it by yourself. In real, the sound wave is propagated in all directions. Just to make you understand, I described it in one direction. This is how sound propagates. This is very interesting. Do you know how do we hear through our ears? It's similar to the experiments we did, and it's based on the principle I described. So inside our ear, we have an eardrum, which is a thin membrane like a plastic sheet we used for our experiments. When sound waves come inside our ears, they hit the eardrum and eardrum starts vibrating. The eardrum vibrations caused by sound waves move the chain of tiny bones, the ossicles in the middle ear, transferring the sound vibrations into the cochlea of the inner ear. This causes fluid in the cochlea to vibrate and it is converted to an electric impulse. That's how our brain perceives sound. Now let's do some thinking exercise. Suppose you are in space. You saw your friend there, and you call your friend by his or her name. Will your friend hear your voice? What do you think? Think and write your answer in the comment below. Stay curious. Thank you.
Those were some fascinating patterns that were obtained just from sound. You all can try it out at home and look at the different patterns that you can come up with. We move on to our next video on sound, about its reflection and echo.
Hello everyone, this video is about sound and its reflexes. Let's begin and use an earphone for best experience. Like every other wave, for example ocean wave and light wave, sound also gets reflected. Let us perform this simple experiment to observe the reflection of sound wave. We took two posters, rolled them and made two pipes. The wooden door works as a reflecting surface. At the source end, we have placed a cell phone and fed the sound into this pipe using an earphone. At the listening end, we have used another cell phone to record the sound. According to the laws of reflection, the angle of incident equals the angle of reflection. For maximum reception at the listening end, we have placed the pipes in a way such that the angle of incident equals the angle of reflection. Now let us hear what we have transmitted from the source end. And this is what we have received at the listening end. Now let us observe reverberation due to repeated reflections from the walls of a big hallway. Even after the sound source stops, the reflections continue and their amplitude gradually reduces to zero. Now listen carefully how the sound persists for several seconds.
Hello? Hello?
Now let us observe a reverberation chamber. This room is designed to produce reverberation. Now listen carefully.
Hello? 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 Hello?
Now let us look into this anechoic chamber. This chamber is specially designed to completely absorb the reflection of sound. Now let us hear something inside this anechoic chamber.
Hello? 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 Hello?
Can you spot the difference now?
Hello?
Hello? Hello?
Hello?
So I think you have got it by now. Let's hear this mysterious sound. See if you can answer this question. Can sound propagate without any medium, say outside Earth? If we transmit a loud sound towards Moon, will it be reflected from Moon's surface? Can you hear that on Earth? Thank you. Have a nice day.
I now request Abhiyan to take up a few questions from the audience. Abhiyan, please turn on your video and microphone.
Am I visible?
Yes.
Okay. So at the end of the video, I had posed a question. The question was like this: suppose you are in space, and your friend is also in space, and then you call your friend by his or her name. So your friend can he or she can able to hear you. So the answer travel. So in space there is no medium, so the sound can't propagate. So another question is one of the students asked, can we avoid the mirror and instead place the laser directly facing the wall? Yeah, you can do that. You don't need mirror. You can do that. So other question is sound energy? Yes, sound is a form of energy which needs medium to travel, propagate. Yeah, it's a form of energy. So another question is, okay, why does the pattern changes in different frequency? So what is frequency? First, we have to understand what the definition of frequency. The frequency is nothing but the number of waves that pass a fixed point in a unit time. So when you change the frequency, the number of waves also changes with that. So the more number of waves in like per unit time, it will hit the plastic sheet, and there will be the deformation in the plastic sheet. Okay, but you can't see that with your naked eye. It will be very complicated deformations. Because of that, you can see different pattern when you change the frequencies. So everything, because of the vibration, there are pattern formed even in water, in salt, is all due to the vibration caused due to the sound wave. Yeah, that's it. Hello.
Thank you, Abhayan. I now request Saurav to answer a few questions from the audience.
Okay.
Hi, Aditi, can you hear me as well as see me?
Yes, yes.
Yeah, okay. So, hi, good afternoon, everyone. There was a question that what is reverberation? So, it is a phenomena where we can hear the sound, actually the reflection of sound, even after the main source stops. So, it is the persistence due to multiple reflection between the walls. So that you can say it is a reverberation. So, and there is another related question. So, is reverberation and echo similar? So, yes, there is a distinct gap between reverberation and echo. When you can distinguish the main sound and the reflection of sound, then it is a echo. Like, for example, say you are standing somewhere and there is a hill nearby, and if you transmit and the reflected wave comes to you, so you can distinguish these two sounds by few seconds or so. So that is an echo. And in case of reverberation, like in our video, so it is not an echo actually, it is reverberation. So you cannot distinguish the sound. It keeps on playing with the main sound. You hear it with a continuous tone. And there is another question, what happens in an anechoic chamber? Okay, so this anechoic chamber is like it stops both echo and reverberation. And because first of all, the material it is made, it is like polystyrene or polyurethane, kind of a foam like material that absorbs the sound. And also this pyramidal shaped wedges, how they are placed in this anechoic chamber, that also matters. They are placed such a way that there is even if there is an reflection from the walls, that will be trapped between two wedges, and eventually that will be absorbed between this foam like materials. And yes, another question, minimum distance required for sound to echo. That actually depends on the speed of sound. Let's take it is 344 meter per second, 344 meter per second here. So that will give us this 34.4 to and fro distance between the observer and the reflector. That comes from this our sensitivity of ear, that is 1/10 of a second, because within this time if there is another sound we cannot distinguish, our brain cannot distinguish. So that's how we get this 34.4 meter distance divided by 2, 17.2 meters. So yeah, that's it. We need 17.2 meter distance between the observer and the reflector. Then we can hear the echo.
Thank you, Saurav, for answering these questions.
Yeah, thank you.
This brings us to the end of the morning session. I hope you all enjoyed it. We'll get back at sharp 2 p.m. with a guest lecture by the well-known physicist, Professor H.C. Verma. Stay tuned.
audible?
physics students from intermediate to graduate levels. He was a professor in the Department of Physics at IIT Kanpur. Prior to this, he served Science College, Patna University as lecturer and reader. Having published over 139 research papers in reputed journals, he has also developed more than 300 physics experiments which can be used by teachers as demos in their classrooms. He has also produced a set of 45 video lectures in Hindi at school level. Professor Verma is Executive Committee member of Indian Association of Physics Teachers, AIPT, which works for physics education in schools and colleges. He has been instrumental in forming a group of IIT Kanpur faculty members and students, together with local youth, to run an NGO called Shiksha Open. His outreach activities are a huge inspiration to our group. It is our immense pleasure to have him with us today to grace this event. I would now request Professor Verma to address the audience.
Thank you very much. And it's a good opportunity because talking to young people is always very inspiring. And I had seen the program and it was very rich. Different people teaching different things to the students. Learning outside the classroom is always more enjoyable. We say that Newton discovered law of gravitation, or at least idea was sparked when he was sitting outside the classroom in the garden, and then that apple fell down, and from there that whole idea crept in. In fact, only outside classroom is much more rich in terms of science, but if I do not connect science to the outside classroom world, I'll be missing a lot of things. Whatever science we have today has been developed basically from the nature, from the experiments, people trying to understand nature, and for that trying to understand different experiments which are done in the laboratories, and from there all varieties of development in science has taken place. You can think of anything you like, anything. People say theoretical scientist and experimental scientist, but any theory, anything you look into, ultimately it has started somewhere from some natural phenomena or some experiment in the lab. So experiments are very, very important for the development of science, and connecting this experiment with the nature and natural events is even better, right? So the starting point is that we see what is around. We normally, what do we study in our science textbooks? In physics chapters, we study motion. There is a lot of motion in the life. A lot of things. We ourselves move, we walk, we run, we stand up, we sit down. A lot of motion is there. And if we connect the laws which we study in our textbooks classroom to these kinds of motions, that will be very nice. For example, when I do this kind of action, right? So one can apply all that knowledge here. Is it rotational motion? Is it translation motion? Where the center of mass is going? If the center of mass is moving with acceleration, from where the forces are coming? If it is a rotational motion, where is the axis of rotation? Whether the entire part of this my hand is having one single axis of rotation, or you have more than one axis of rotation, different parts are going. Anything you take, heat and thermodynamics we study in our textbooks, in our classroom. But then in our kitchen, we always have a lot of activities related to heat and thermodynamics. Right? We use a pressure cooker. So how come pressure cooker helps us in cooking? So all those things, if you try to understand and connect the textbook science with that kitchen science, then you will very well understand all these phenomena, all these rules of thermodynamics. And whenever we fry something, we fry in oil, right? But whenever we boil something, we boil it in water. So where is the difference? Where is the Similarly, when we wash our clothes and put them for drying, then where does the water go? And why does the water go? Water takes so much time. Why the entire water doesn't go in, say, a few seconds? Why it takes hours for our dry clothes to dry the cloths? So all these things, if you connect, whatever you have learned, like let's say evaporation, you have learned in your textbook, and if you can and try to understand this drying of clothes, right, on some string or something in open, you can learn much better of this evaporation and humidity, like that. If in winters many times we use fire to save ourselves from the extreme cold. So radiations, how that radiation is coming from that fire, and how it is reaching our faces or our bodies, and we feel comfortable. Those kind of heat transfer things. We study about light. There's so much of light around us, so we can connect all these things there. The colors are there, the splitting of white light into colors. So many things are there all the time, so that we can connect. Based on this, we conduct an experimental skill test, a national competition of performing experiments, which is open for school students class 9, 10, 11, and 12, and BSc and MSc students, where we use these household materials as our physics equipment. Last year, when we did this experiment, this test, this competition, some 48,000 students enrolled for it, and some 1,400 students were picked up, screened for performing the experiment. And it was lockdown period, 2020, August, September, the same time. And all the experiments were performed by these 1,400 students at their home. We suggested the experiment. We designed the experiments rather. This is another aspect. Designing new things, that is very crucial. If you learn a theory, how Ohm's law works, how a circuit is connected, you can learn all those things. But if you have to design a circuit, not that the components are given to you and then you assemble them in a particular way, and then you take some readings and then verify Ohm's law, V is equal to I into R. That also gives training, that also gives a lot of understanding and training to perform experiments, how tightly I have to connect two wires, or how tightly I have to connect a wire to the battery. Now, connecting the wire to a battery is also not very trivial, unless there is some kind of knob there where you can tie that wire up. So to design, but if you have to design all the things from the home materials, that will give a fantastic experience and a lot of learning experience. So in 2020, August, September, we did that, and the students could perform all those experiments using those kitchen materials, those study room materials, or their own storerooms or gardens. So, and this year also we are performing that activity. It's, in fact, it is still on. Registrations are going on till 17th September. It is open. So that website, nani.hcverma.in, you can go and participate and enjoy. Designing something new is always very powerful tool. When you do that, so much of skill is developed, so that you really become competent, you empower yourself. So the learning, I call it cute learning, C-U-T-E, cute learning. Right? So cramming, first C is for cramming. You have to cram so many equations, formulae, definitions, descriptions, so on. That is also necessary. That is also necessary. One has to cram. In very tiny age, we cram so many things even without understanding. So many things. It's not bad. Multiplication tables, for example. When we learn multiplication tables in our class 3, 4, we don't understand what it is. And it's not needed also. In my childhood, I learned tables up to say 20. So I don't know what is that 17 into 4 is 68. That time even not even 17 is known. 68, what is 68? What is that multiplication? But still we cram all those things. And it is very useful. And it is very useful even today. I remember all those multiplication tables, and therefore my life is very, very comfortable in my science journey. But then cramming together with understanding, that will have a say tenfold impressive results. If I also understand what I am cramming. So this is the second stage. Now the third stage is thinking. And it is this where the experiments, outdoor experiments and self-designed experiments are very important. I can teach you something, and then you can very attentively listen to me, or you can very attentively read your textbook pages, and you can understand what is written there. So that is fine. But there you are not thinking. There something is there someone is telling something, and you only have to understand that. And thinking means you are thinking. You are thinking means you are doing something new. You are trying to get a solution of something new, something you are not able to understand, and then you think. If you understand a particular thing, if I teach so well that you understand very easily what I say, then you don't have to think. Yeah, I have explained it. I have explained it, and you have understood it. You don't have to think. But if you don't understand something, then there is an opportunity for your brain cells responsible for thinking to get activated. If you don't understand something, then you start thinking on it. And then finally, when you understand, then by that time there's so much of exercise of those cells, those brain cells, that your thinking capabilities, it has improved. But if you don't get this opportunity of thinking, and everything is so simple and so nicely and so quickly it is all solved, then you are really missing that opportunity to think. And if you miss that opportunity to think very often, right, very often, so you don't get this opportunity for say 1 year. Only cramming and understanding you are using, and you are getting good grades, good marks, good recognition, and you are happy with that. But then if for 1 full year you do not use your thinking cells, those thinking cells will get weakened. And if they become weak, then it will be very difficult for you to take the journey ahead. The thinking is very necessary. And finally, if you are able to think, then you can design new things. And if you can design new things, then you can explore new ideas. You can venture into new ideas. So that is exploration. So cramming, understanding, thinking, and exploring, that makes really cute learning. So all these experiments that these IISc people are doing, outdoor experiments, I congratulate all the team who have undertaken this, and who are trying to cultivate this culture. Theory is also very important. It's not that only experiment. We perform experiments, and experiments are from nature. See, this is a difference, a major difference between theory and experiment is experiments are not created by us. Experiment go by the rule of nature. We only try to see what is happening. Right? So, and nature is not compartmentalized. Nature is not compartmentalized. Nature is integrated. So it's not that if you perform an experiment, this is exclusively it is involving only the optics. Not necessarily. It may involve many things once it is a natural phenomenon. Your equipment, there may be stress, there may be strain, deformations, blah blah blah. Many things will come into it. Although you are doing an optics experiment, but even then, the particular day, the temperatures are different, the humidity are different, and those can affect your instruments and whatever readings you are taking or whatever data you are collecting, they may get affected by that. So heat and thermodynamics may go there, mechanical stability can go there, alignment. You need perhaps you need a horizontal slab, but then the slab may not be horizontal. If it is not horizontal, then all those normal forces, unequal, this, that, they will come into picture. So an experiment has many phases into it integrated in one experiment. But then to deal with that and to create new equipment, new gadgets which are useful for human society, you need a perfect understanding of all those pieces which are put together to make that experiment. I am designing an experiment, I can think that, okay, I am putting these 3-4 things into my experiment, but then nature can put many more things, and that is why many times people are puzzled that the expected results are not coming. It doesn't mean that the experiment is wrong or the experiment is not performed carefully. That can also be a reason. If you don't perform the experiment carefully, you will get the wrong result. But wrong results are never wrong. Experimental results are never wrong. Experimental results may be not as expected. That is possible. It's not as expected. That is fine. But they're not wrong because they're experiments. They are governed by the laws of nature, which are never wrong. Whatever result you are getting those results because of the laws of nature. So how can an experimental result be wrong? Only thing it can happen is that, all right, it is not as expected. But if it is not as expected, it's once again an opportunity. Okay? If you are performing an experiment and the result is as expected, you perhaps not learned much of new things from this. You must have learned to do the experiment, to perform the experiment. Those experimental skills might have been developed. But then, all right, you knew that it will happen this way, and it did happen that way, and therefore there is no change in. You have not learned a really new thing. But if the experimental result is not as expected, then once again there is an opportunity to learn. Whenever you fail to get the expected result, whether you are solving a numerical problem, whether you are trying to understand the derivation of a particular theorem, right, or you are performing a particular experiment, and then whenever you fail to get the desired result, that is in fact the day of celebration, because it gives you an opportunity to rethink what has happened. And in experiment also, you start thinking that why my result is not as expected, and then you come to know, maybe you discover that, all right, this particular piece was working this way, and we did not know that it works this way. right? So these are the kind of things, and thank you very much for joining me and listening to me. And my message on this Teachers' Day is that uh, inculcate those teaching qualities in you from the very beginning, the very childhood. Once you start thinking and trying to learn, this learning is many-fold multiplied if you try to make your friend understand what you are doing. If you can explain to your friend something, that will uh, make you much more capable in understanding that particular concept. So the teacher in you, the children, teacher in you, you just try to nurture that. Try to nurture that and teach your friends. Right? Make them understand. You explain things. Your teacher has explained something in the classroom, and if you talk to your student, and then you can make your friend understand those concepts in a different way. Present the things in a different way. Right? That will you will feel that yes, now you know it much better than what you thought that I have understood when my teacher told me this, I understood. All right, yes, you did understand. But if you teach your friend, then you will know that, okay, now I understand it even more in a rigorous way, even much better. So that teaching quality in you, you just nurture that, and finally you become a celebrated teacher in your life. And the students of IISc who are in this venture, I will also appeal to them that you are already on that path. You are already on that path. You will do wonderful researches, that is fine, but at the same time, be a wonderful teacher also. Our nation needs really a huge army of teachers who can build confidence in the students, who can build spirit of accepting challenges and finding new solutions in whatever situation they are put. Those kind of teachers are much needed in our country. So all of us should congratulate each other on this Teachers' Day. Thank you very much.
Thank you, Professor Verma, for your encouraging words. Also, thank you for addressing the younger generation and motivating us to understand science around us. We all hope to continue to learn a lot from you. We are grateful to you for making time to join us today. Thank you once again. We now begin our afternoon session of experiments. The first segment is combustion and fire.
This experiment will help in understanding the concept of ignition temperature. The materials required for this experiment are a burning candle, a piece of paper, and some water. Kindly perform this experiment under the supervision of an adult. Firstly, we fold the piece of paper in the form of a funnel, make a paper cup out of it, and place the tip of the cup close to the burning candle. As we can see that the paper immediately catches fire. When the tip of the paper was brought close to the flame, the temperature of the paper began to increase. After reaching a certain temperature, it caught fire. The lowest temperature at which any substance catches fire is called as its ignition temperature. Now we shall observe what happens when some water is poured into the paper cup. We repeat the experiment by bringing the tip of the cup near the flame of the candle. We can observe that this time the paper does not instantly catch fire. Can you think why? The heat that is given to the paper cup is transferred to the water inside. So the ignition temperature of the paper is not reached yet in the presence of water, and hence it does not burn. You can dip your finger carefully into the water and observe the temperature of the water. You can notice that the water becomes hot. In fact, if we continue heating, we can even boil the water in this paper cup without burning the paper. This activity shows that it is essential for a substance to reach ignition temperature to burn. Different substances have different ignition temperature. The substances which have very low ignition temperature can catch fire easily, for example petrol and kerosene. Look around you and think of substances which burn easily, and with that you can classify objects into having high or low ignition temperature.
Now we have another video to understand fire and how it can be extinguished.
In this experiment, we will try to understand how is fire extinguished. The materials required for this are a burning candle, some vinegar and baking soda. Kindly perform this experiment under the supervision of an adult. Firstly, we keep a burning candle prepared. Then we add 2 to 3 spoons of vinegar into a jar. Then we add half spoon of baking soda to it. Now gently stir the jar. You will notice some gas coming out of the jar. Take the brim of this jar close to the flame of the burning candle. The gas from the jar instantly puts out the flame. What was the gas that was released in this reaction which helped in extinguishing the flame? To understand this, we need to look at the chemical reaction between the baking soda and the vinegar. Baking soda has the chemical formula NaHCO3 and vinegar, which is acetic acid, has the formula HC2H3O2. These are the reactants which react to give the products sodium acetate, water and most importantly the gas CO2, which is carbon dioxide. This carbon dioxide is the gas which extinguished the flame in the experiment. You might all have seen this object. This is a fire extinguisher kept in schools, malls and other public places. These extinguishers contain the gas carbon dioxide. When there is fire, the gas from these extinguishers are sprayed over. It cuts off the supply of oxygen and thus douses the fire. Now we all can also perform a simple fire extinguishing experiment with baking soda and vinegar and understand how fire extinguishers work.
I now request Anam and Tavishi to answer a few questions from this segment.
Hi everyone. So the first question that we have is what is ignition temperature? So it is the lowest temperature at which a substance catches fire. So that is the definition of ignition temperature.
Yeah, and the second question we had is why paper cup did not burn. The reason for it being that the heat from the fire candle was being transferred to the liquid and hence the ignition temperature was being raised. So that was the reason why the paper cup with water didn't catch fire.
So there are no more questions from there, but we can just discuss a couple of things. So do all substances catch fire? So that's not the case. Some materials are more flammable than other materials. So the materials which are more flammable, they catch fire more easily, like kerosene and petrol. However, some materials do not catch fire, for example, a stone. So it depends on the ignition temperature of the material, and that translates into the flammability.
Yeah, so another question that we got just now was is only CO2 used to stop fire? No, CO2 is used to stop fire, but it is not the only thing that is used to stop fire. So there are various classes of fire, like it can be divided into 6 or 7 classes. So it is depending on A, B, C, like because of solids, liquids, or gases. And depending on that, we can use a type of fire extinguishers. So we have foam type fire extinguisher, we have powder type fire extinguishers, we have water type, CO2, and all the other things. Like similarly, the other things are there. So not just CO2.
Right. So the basic logic is that to stop the fire, we need to cut off the supply of oxygen. So that is the basic principle on which fire extinguishing works.
I think, yeah, and there is another main confusion. So there is called flammable and inflammable substances. So these are basically synonyms to each other, and it is like a same word used in a different form. Like they are synonyms. Yes, I think.
Do we have any other questions?
Yeah, this is pretty much it. Okay, thank you.
Thank you, Anam and Tavishi, for answering the questions. We next move on to our segment, electricity and magnetism. The first experiment is about static electricity.
Do you think it is possible to move an object? Let me show you a magic trick. Do you think it is possible to move an object without touching it? Then let me show you a magic trick. For this, we need a PVC pipe, some pieces of paper, and a cloth. So here I have a PVC pipe, I have a piece of cloth, as you can see. Now I will rub this PVC pipe with the cloth, and there are some pieces of paper lying over here, as you can see. And when I move this PVC pipe close to the paper, you can see they are getting pulled to that pipe. Isn't this amazing? Now you must be thinking, how does this magic work? But let me tell you something, this is not magic. This is science. To understand the science behind this, let me take you inside a PVC pipe. All the matter is made up of atoms. And if we look inside an atom, we will find 3 types of particles. One, negatively charged electrons. Second is positively charged protons, and neutral neutrons. In an atom, there will be equal number of electrons and protons present. Thus, they balance out each other's charge and makes the object neutral. Let's understand few facts about charges. Like charges repel each other, whereas unlike charges attract each other. Now let's see what happens when we rub 2 neutral objects. Let's say material 1 has loosely bonded electrons than material 2. So by taking energy from rubbing action, some of the electrons from material 1 will come out of the surface and move into material 2. So now material 1 has more number of protons than number of electrons, making it positively charged, whereas material 2 has more number of electrons than protons, making it negatively charged. Now the question is, what will happen when we bring a charged object close to a neutral object? Suppose I bring a negatively charged object near to a neutral object. The electrons on the near side of the neutral object gets repelled by the negatively charged object. Thus a small fraction of electrons get displaced towards the far side. So making the far side slightly more negative and the near side slightly more positively charged. So this process of charge separation in a neutral object is called charge polarization or charge induction. Now the negatively charged object will repel the negative charges on the far side and will attract the positive charges on the near side. But as the distance to the near side is less, the force of attraction is more than the force of repulsion. So if the neutral object is light enough, it will move towards the negatively charged object. So in our experiment, when we rubbed the PVC pipe with the cloth, the PVC pipe got negatively charged and the cloth got positively charged. And when we brought the negatively charged PVC pipe towards the pieces of paper, there must be charge polarization took place in the pieces of paper, and as the paper are very light, so it got attracted towards the PVC pipe. Let's see some more experiments based on the same principle. For this we need PVC pipe, one cloth and a cold drink can. So again we will rub the PVC pipe with the cloth, and when we bring it towards the Coca-Cola can, you will see what will happen. With the same principle, it is getting attracted towards it. Now let's see another experiment. So there is a stream of water coming out of the bottle, and as you show the charged PVC pipe, the stream of water gets deflected. And this is based on the same principle. Now observe the next experiment carefully, and you have to think what's happening now. So we take two balloons. They are touching each other. They are hanging from one common rod. So now we will rub each balloon with a piece of cloth. And we will leave them. So you can see they are running away from each other. Now we will try to push them together, but still you can see they are repelling each other. So can you guess why they are repelling each other? I think most of you guessed it right. So when we rubbed both the balloons with the same cloth, they must have developed similar charges. And as we know that similar charges repel each other, that's why the balloons were repelling. Now we know that an object can be either charged or can be neutral. So the question is there any way of detecting the object is either charged or neutral? Let's build an apparatus to do so. For this, we need a glass, one rubber sheet, a paper clip which we have unfolded as shown in the image, and two small aluminium foils. On one side of the paper clip, hang the two aluminium foils as shown, and the other side is pierced through a rubber sheet and it is placed on the glass as shown in the figure. In order to check whether an object is charged or not, we have to bring that object and touch it on the top end of the paper clip. For example, let's bring the charged PVC pipe we have and touch it there, and let's see what happens. As the PVC pipe is touched, we can see the foils are getting deflected. Let's understand what happened. As the negatively charged PVC pipe touches the top end of the paper clip, all the excess negative charges will flow to the aluminum foil through it. Thus, both the aluminum foil will acquire similar charges. And as we know, similar charges repel, that's why they were deflecting away from each other. Now we can say that if the foils deflect away from each other, that means the object is charged, or else it is neutral. Such an apparatus is called electroscope. This static electricity can lead to some large-scale natural phenomena like lightning. During thunderstorms, in clouds, there will be vigorous movements between the water droplets and air molecules. And this vigorous movements can lead to charge separation. And by some process which is not yet completely understood, the positive charges collect near the upper edge of the cloud and the negative charges accumulate near the lower edges. And there will be some accumulation of positive charges near the ground also. When the magnitude of accumulated charges becomes very large, the air, which is normally a poor conductor of electricity, is no longer able to resist the flow. Hence, the negative and positive charges meet, producing streaks of bright light and sound. We see the streaks as lightning, and this whole process is called electric discharge. In 1752, an American scientist named Benjamin Franklin is the first person who identified that the cause behind lightning is related to static electricity. However, lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. No open place is safe during lightning. So stay inside your home with windows and doors shut. If you are outside, then stay away from all types of trees, poles, or any other metal objects. Squat low on the ground as shown in the image. This position will make you the smallest target to be struck.
Those were some interesting experiments that we could easily replicate at home. I now request Mayank to take up a few questions from the audience.
Yeah, good afternoon, everyone. So the questions came toward the static electricity is like, can we say that the friction result in the exchange of atom resulting in a static electricity? Actually, what happened basically when the frictions come, because of that, the surface of the surface got in excited state. Because of that, electron moves. So obviously, we can say that when there is a friction, actually we are supplying the energy to the upper surface, right? So yeah, that's true. Whenever there is a friction, there is a transfer of electron. Yeah. And there is another question, what charge actually means. So as we know that, like atom consists of equal number of electron and proton, right? So if there is an imbalance between the electron and proton, so we can say the charge does exist. For example, when we are rubbing, so electrons getting transferred from one object to other object. So in one object, what happened? There is a deficiency of electron. That's why we called is a positively charged. In other, we are calling as a negatively charged because there is more number of electrons, right? So yeah, that is the charge actually means. And that is an interesting question, right? Can the electricity in a lightning be harnessed? So yeah, I think that the research is going on that, and that's quite interesting if we are able to do that, because we will be able to save a lot of power and we will be able to generate a lot of power. So yeah, that's sort of interesting question. Other question is like, if only one balloon is charged, then will it still be away from each other? Okay, so what happened, the experiment that I have shown you there, where both of the balloons got rubbed, right? So both balloon got the positive charge, and that's why they got repelled. But in case if you're rubbing only one balloon, that is this particular balloon got the positive charge, but the second balloon is neutral. So what this positively charged balloon will do, it will polarize the charges in the other balloon, and the negative charge will come close to the positive charge of the first balloon, and that's why there will be attraction, and that they will be close to each other. And yeah, other question is on what factor rate of attraction matters. So I think it's a lot of depend on the electronegativity of the materials. Some materials are more electronegative, and other thing is that there, what I feel, there is a mass also. For example, if you're rubbing two material, there is a transfer of electron for sure, but it doesn't mean every charge, every object, every material will get attract or repel to each other, because it does depend on the mass. And there are some other factors also. Maybe I'm not aware with that. Yeah. And the other question is came like they are mentioning when we are rubbing the comb with the hair, that this particular comb we put over the tissue paper or somewhere, that it attracts the tissue paper, right? So they are mentioning if our hairs are wet and we are using the comb and we are combing, then it will attract the tissue paper or some other papers or not. So what happened basically, the interesting thing is that when we are rubbing the comb with the hair, so actually the heat energy is transferring to the hair. From that, electrons getting transferred from the hair to the comb. But what happened in due to the friction, obviously due to the friction. But what happens if your hairs are wet? Then in that case, the friction energy is not sufficient to transfer the electron from one material to other. So in that case, you will not find kind of a attraction between the comb and the tissue paper or paper.
Yeah, thank you, Mayank, for answering these questions.
Thanks, Aditi. Thanks.
Thank you. When it comes to electricity, Ohm's law is one of the most common laws that we hear about. Let us try to understand what this is with our next.
The topic for this presentation is Ohm's law. In this presentation, we'll get to know what is Ohm's law, what are the conditions in which this Ohm's law is valid, from where did it come from, and also how can we verify this Ohm's law without actually doing experiments. Now, let me ask you a question. Why is electrical energy the most popular form of energy? The answer to this question is that it is a controllable and efficient form of energy available out of all the forms of energy that we have. Now we know that electrical energy is the most important form of energy, but how do we actually use this electrical energy? So in order to use this electrical energy, we need a voltage source, a closed circuit, and electric current. Now voltage source can be analyzed as an electrical pressure which helps us to move charge carriers through a conductor, and the rate of flow of these charge carriers in this conductor is called electric current. Let us see few terminologies that will be used ahead. So the first is voltage or potential difference. So potential difference between 2 points in an electric circuit carrying current is defined as the work done to move a unit charge from one point to another. Also, another definition is rate of flow of charges in a conductor which is connected to a source and forms a closed loop is called electric current. Also, another one is a continuous and closed path of an electric current is called an electric circuit. Now, the moment we define the terminologies potential difference and current, a question comes to the mind that is there any relationship between the potential difference and current in an electric circuit? One way to find out is by doing some experiments. But is there any other way to do it? Yes, there is another way to do it. That is simulation. Simulation is an easier alternative to experiments. The ideal definition or the conventional definition of simulation is it is the imitation of the operation of real world process or system over time. So if you can see generally simulation tools are basically of two types. One is the licensed, another one is the open source. Usually the licensed ones are paid versions and open source tools are free of cost. So one of the examples of each of these is for a licensed tool, one of the examples is MATLAB, and for open source, and one of the examples is LT-Spice. In our further presentation, we'll be using this open source LT-Spice in order to replace the experiments with simulations, so that we can do these like virtually experiments even from home. The window that you can see here, this is the window of an LT-Spice tool. This is the window where you can obtain all the waveforms, and this is the window where you actually draw the schematic, and this is the control panel where you find almost all the things that you need to simulate some basic simple circuits. This tool is provided by Analog Devices, and there are many other alternatives to this tool. This is just one example that we are demonstrating in this presentation. This is how the simulation window of the tool LT-Spice open source tool LT-Spice looks like. You can see it here, and this is the panel window. So I'll just go through the few of the quick commands that we need. So suppose we want to make a simple series circuit where there is just one resistor and one voltage source. So this is a pick component button. So let us pick a voltage source first. this is our voltage source that we needed, and here we can readily select the resistor. Now just select the wire, draw it, and I am pressing escape in order to get rid of the wire. The ground, so we have to connect the ground to the circuit, and again escape. Again I will connect the wire to the circuit, and hence our circuit is ready. Now in order to set the values, I'll just do right click on this voltage source and I'll set the value of the DC source as 10 volts for now, and let us select the value of this resistor as 10 ohms. Now if I run this simulation, then the voltage across this point comes out to be 10 volts, which is very true. And let us see the current across this resistor, which comes out to be 1 ampere. Now remember that current for 10 volt voltage source came out to be 1 ampere. Now let me change the value of this voltage to 15 volts. And now run the simulation again, and let's see the current through this resistor. So current now became 1.5 amperes. So for 10 volts it was 1 ampere, for 15 volts is 1.5 amperes. Let us check for one more value. Let us now make it 20 volts. Rerun the simulation and observe the current through resistor R2, and it came out to be 2 amperes. These values, let us record these values in a table and let's see what this means. This is the table in which the data demonstrated in the previous demo is recorded. This is the voltage that was modified, and this is the current through the wire. Now if you find the ratio between of this voltage to current, that is the ratio V by I, we'll observe that it comes out to be a constant value. And even if you form between this voltage and the current, you will obtain a linear relationship. That means voltage is current proportional to current, which implies V by I is equals to a constant. This constant is called as resistance of the conductor. This resistance is constant only when the temperature remains same throughout, and this resistance is proportional to the length of the conductor L and the area of cross section of the conductor A. And this rho is the constant of proportionality used. This rho depends on the properties of the materials used in order to make. Let us simulate the series circuit of these two resistors R1 and R2. R1 is a resistor of value 40 ohms and R2 is a resistor of value 20 ohms, and V1 is a voltage source of 100 volts. Now if you just run the simulation using this icon, this black window will appear, and in order to measure the voltage you can look for this kind of cursor, and in order to find the current the cursor turns into this kind of cursor. So you just have to click on these cursors in order to measure the voltage or the current. So suppose we want to measure the voltage at this node, it comes out to be 100 volt because it's connected through a voltage of 100 volts. Now if we measure the voltage across resistor R1, then it comes out to be, we'll just zoom it in, and it comes out to be 66.7 volts. So the voltage across resistor R2 will comes out to be around 33.3 ohms, which means the voltage across resistor R1 and R2 is equal to the total voltage V1. That means the sum of voltage across these two resistors is equal to the sum of voltage source in a series circuit. Now let us look at the current. So if we look at the current, this cursor, we just click it. This is the IR2, which is represented by the red line, and you can see it's 1.67 amperes approximately. Now let us look at the current through resistor R1. So current through resistor R1 also comes out to be 1.67 amperes. So, and if we measure the current to this voltage source, which is IV1, which is this pink line, it again comes out to be minus 1.667 amperes. That which tells us that the current in this circuit, in the series circuit across all the elements, through all the elements is same. That means 1.6 amperes, and the sign is negative because current is going out of voltage source and into the resistors. So there is only the convention difference. Rest, the current is same in this circuit, and the voltage, total voltage, is equal to the sum of voltage across these resistors individually. In order to summarize what we just saw in the previous demonstration, for series connection of resistors with these specifications, we found that current is same in every part of a series circuit, and the voltage total total potential difference across a combination of resistors in series is equal to the sum of potential difference across the individual resistors. Let us simulate the circuit for parallel connection of two resistors as already drawn here. So here two resistors R1 and R2 are connected in parallel to a voltage source V1. V1 is a voltage source of 100 volts, and resistor R1 is of value 40 ohms, and resistor R2 is of value 20 ohms. Now if we just run the simulation, this window will appear. In order to measure the voltage, this kind of cursor appears, and if you want to measure the current, this kind of cursor to be brought. So if we just measure the voltage at this node, if you can see, all these nodes are just a common node. That means the voltage at all these nodes will be identical. So if you just measure voltage at this node, it comes out to be 100 volts. That means voltage across this voltage source is same as the voltage across this resistor R1 and the voltage across this resistor R2. This is the property of parallel connection, where voltage across both the resistors will be identical and it will be equal to the voltage of the voltage source. Now let us look at the current. If we find out the current through resistor R1, it comes out to be IR1, which is represented in blue color. It comes out to be 2.5 amperes, and current through resistor R2 is represented in red color, which can be zoomed, and it comes out to be 5 amperes. Now let us measure the current through voltage source V1. It comes out to be minus 7.5 amperes. This 7.5 amperes magnitude is the sum of 2.5 ampere current and 5 ampere current through both of these resistors. That means the sum of current which is going from this voltage, the current which is going through this voltage source, is equal to the sum of current which is flowing in this branch and this branch. This is the property of parallel circuits, in which the total current from the voltage source is equal to the sum of current in the two resistors. In order to summarize what we just saw in the demonstration for parallel connection of resistors, and with these specifications, we found that for a parallel circuit, the voltage is same across all parallel connected elements in a parallel circuit. Also, for the current, we found that total current is equal to the sum of separate currents through each branch of the combination. If you have any questions, then please add them in the comments below. Your questions will be answered as soon as possible. Thank you for your patient listening.
That was an interesting way of looking at combination of resistors. Now I request Anchal to take up a few questions from the audience.
Hi all. So the first question that I got from the audience is, what is the difference between charge and current? So current is basically rate of flow of charge through a conductor. So if you imagine a conductor and charge is flowing through that, so the charge flown per unit time is current. They are not the same things. Okay, and another question is, what is 1 unit of charge? So if you know that there is the charge on one electron 6 into 10 to the power minus 19 coulombs, and the unit of charge is coulombs. So if you want to know what is 1 coulomb, then you just divide it 1 by 1.6 into 10 to the power minus 19. That is 6.25 into 10 to the power 25. 10 to the power 18, sorry. So basically 1 coulomb is the charge that 6.25 into 10 to the power 18 electrons carry. So that is how you can mathematically understand a unit of charge. Is electric circuit and electric current similar? Okay, so basically first you form an electric circuit. Electric circuit is basically a closed path that involves a voltage source and some kind of resistance or load. So when you close this circuit and apply a proper potential to this circuit, then current flows. So current is the cause that happens after you create a circuit. And when you apply the potential difference, they are also not the same things. And what is potential difference? So potential difference is basically you can imagine 2 points. Now the amount of energy that I require to carry 1 unit of charge from one point to another can be defined as potential difference across those 2 points. So potential difference always exists between 2 points, or you can measure it absolute, but it has to always be measured with respect to some kind of reference. Okay, what is a good Android app for simulation? So for simulations, I won't recommend you to use any app. So there are multiple softwares which are available. I would recommend you to use open source softwares. As I mentioned in my video, the open source softwares are the ones for which you don't need any license. They are free of cost. So you can just, there are multiple options available. For the experiment, I have used LT Spice. That is a software that is provided by Analog Devices. There are multiple thousands of options available. According to what kind of circuit you want to simulate, you can go with any of the open source softwares. Okay.
Thank you, Anjali. Okay, just take up one more question. Yeah, go ahead.
Yeah, so the last question is, why is voltage proportional to current? So basically, if you see, voltage is the cause and current is the effect of that voltage. So basically, current is proportional to voltage and not voltage, and not the other way around. So that is a very important point that has to be considered while thinking about Ohm's law. And that's it. Thank you so much.
Thank you, Anchal, for answering this. Have you ever wondered if liquids can carry current? Let's look at the next experiment for that.
In this set of experiments, we will check whether various liquids conduct electricity or not. To conduct these experiments, we require very basic equipment. We will require a 9-volt battery, a container to hold the liquid, some wires, and an electrical bulb. All these materials are easily available in nearby electrical or general stores. The schematic to conduct the experiment is as follows. We will take 3 wires, a battery, a bulb, and a container filled with the liquid we want to check. We will take the first wire and connect the negative terminal of the battery directly with the bulb. We will take another wire, connect the positive terminal of the battery, and dip the other end of the wire directly into the liquid. Next, we will take the third wire, connect one end of the wire to the bulb, and directly dip the other end of the wire into the liquid. If the liquid is a good conductor of electricity, the circuit will be closed and electricity will flow from battery into the bulb and the bulb will glow brightly. In case the liquid is a poor conductor of electricity, the circuit will remain open and no electricity or a very small amount of electricity will be conducted through the liquid, and the bulb will either not glow at all or it will glow very dimly. Once we have connected the wires together, we can check whether the apparatus is working or not by connecting the free ends of the positive terminals together. As can be seen, since everything is okay, the bulb glows brightly. We will first test whether tap water is a good conductor of electricity or not. As you can see, as soon as I put the free ends together, the bulb glows brightly. This shows that the tap water is a good conductor of electricity. This is the reason why it is not advised to touch electrical appliances with wet hands, because tap water is a good conductor of electricity. Next, we will check whether distilled water or pure water is a good conductor of electricity or not. As you can see, as I put the free ends of the wire into the container, the bulb glows very dimly, showing that distilled or pure water is a poor conductor of electricity. Next, we will take some milk and pour it into the container. As we have done previously, we will put the free ends of the wire into the milk, and as you can see that the bulb again glows brightly, which means that milk is a good conductor of electricity. Finally, we will take honey and put it into the container. As done previously, we put the free ends of the wire into honey, and this time we can see that the bulb glows quite dimly again, which again shows that honey is a poor conductor of electricity. So to summarize, we can see that the bulb glows very brightly in case of tap water and milk, which are good conductors of electricity, which are shown on the left hand side here, and the bulb glows quite dimly in case of distilled water and honey, which are poor conductors of electricity. So now the question that we need to answer is that why do some liquids conduct electricity, whereas some other liquids are poor conductors of electricity. Liquids which are good conductors of electricity have free charges available in them. These free charges could be ions or electrons. These free charges help the liquid to carry electricity. For example, in tap water, some minerals and salts are always dissolved as impurities which help in conduction of electricity. Similarly, in milk, the lactic acid present helps in conduction of electricity. However, in case of honey and distilled water, such charge carriers are not available, and hence they are poor conductors of electricity. Liquid metals like mercury have free electrons in them, and hence even they can conduct electricity. So here are some more liquids you can try: lemon juice, salt water, vegetable oil, and vinegar. I also do think as why some of them are good conductors of electricity, whereas some are poor conductors of electricity.
You can all try this experiment by using different liquids at home. Now I request Sundar to take a few questions from the audience.
Am I audible to everybody?
Yes.
So some of the questions that have come are, one question that is frequently asked is, do alcohol, lemon juice and vinegar, these liquids conduct electricity or not? Because most of them are acidic liquids and they will have free charges in them and they will conduct electricity. They will be good conductors of electricity. But all of these liquids you can also try out at your home and see whether they conduct electricity or not. Another question that has come is, do bases conduct electricity? Bases also do conduct electricity because they do have OH minus free charges in them. So they are also good conductors of electricity. Another good question that has come is, do other states of matter conduct electricity, like gases, BEC or plasma? As far as conducting electricity is concerned, every state of matter conducts electricity, but some of them are poor and some of them are good conductors of electricity. For example, gases are poor conductors of electricity, but when very high voltages are applied to them, they too do conduct electricity, as you can see in case of thunderstorms. Especially in rainy season, you can see that very frequently. But for that to happen, you need to apply a very large voltages. And finally, one more question that has come is, why is milk a good conductor of electricity? It is because of lactic acid that is present in it. Milk is a good conductor of electricity. I think I have answered most of the questions.
Thank you, Sundar. Thanks a lot for answering the questions. Moving on from electricity, let us look at what magnetism is.
Hello friends, my name is Tushar Gaur, and today in this presentation I am going to discuss with you the magnets and magnetic fields. The contents of this presentation are as follows. First, we will discuss the history of magnets. Then we will understand the difference between electricity and magnetism. Then we will understand what magnets are. Then we will know what magnetic field and magnetic field lines are, types of magnet. Then we will understand magnetic field due to straight current carrying conductor. Then we will discuss about the magnetic field due to current through a circular loop and solenoid. Then we will discuss force on a straight current carrying conductor due to magnetic field. Then we will understand the Faraday's experiment. And last but not the least, we'll know some of the fun facts. History. In 5th century BC, the Greeks already knew that there are some rocks that are track bits of iron, and they are plentiful in the district of Magnesia. And that's where the name magnets and magnetic field came from. These rocks were called magnetites. In 12th century AD, Chinese used these magnetite to form compass needles. In 13th century, people already know that there are specific points on magnetites where the interaction is the maximum. These were named as poles. In 19th century, the Oersted led to the foundation of electromagnetism as he discovered that electric current created the magnetic field. Based on Oersted's discovery, Ampere, Lorentz, and Maxwell carried out their work, and finally Maxwell gave a unified field theory which is at the core of electricity and magnetism. We also know this theory as electromagnetic field theory. Difference between electricity and magnetism. When we talk about static charges, we talk about electric field. When we talk about moving charges, we talk about both electric field as well as magnetic field. Static field is generated when the charges are either in motion or stationary. But magnetic field can be generated only with the help of charges in the motion. With electricity, you have two polarities, positive and negative, and you are free to choose any of them. But with magnetism, it has two poles, which always comes in pair. Isolated magnetic poles are not discovered yet. If someday you find some isolated magnetic poles, you must have done a work which can receive Nobel Prize in that particular year. Now we'll understand what magnets are. Magnets are the material that produces magnetic field, an invisible field, but it is responsible for pulling or attracting the ferromagnetic materials like iron, iron ores, steel, etc. As we know, magnets are always bipolar. Poles occur in pair. Thus, same poles repel each other and dissimilar poles attract each other. As we can see in the figure beside, that when the two different poles, that is north and south, are brought into contact or are brought near to each other, they attract each other. But when the same poles, that is north and north or south and south, are brought closer to each other, they repel each other. Do notice that magnetic poles are different from the geometric poles, which we will understand in the upcoming slides. Magnetic field and magnetic field lines. Magnetic field is an invisible field acting around in the region near the magnet and provides magnets with their magnetic properties. Magnetic field is a vector quantity that has two properties defining it. One is direction, the other one is the magnitude. Direction of a magnetic field at any point can be defined by drawing a tangent at that particular point. This tangent will direct in the direction of the magnetic field. Magnitude at any point can be defined as number of magnetic field lines crossing a unit area. The magnetic field is represented using magnetic field lines which are continuous closed loops running from north pole to the south pole of the magnet. As we move far from the magnet, the strength decreases. This can be also verified or said that as we move away from the magnets, the number of magnetic field lines crossing the unit area reduces, which means the magnitude also reduces. No two magnetic field lines interact or intersect each other. Now we will understand the types of magnets. There are three types of magnets: permanent magnets, temporary magnets, and electromagnets. Permanent magnets do not easily lose their magnetism. These magnets may be naturally occurring, made up of rare earth elements or chemical compounds. Some of the examples of permanent magnets are alnico, an alloy of aluminium, nickel, and cobalt, and ferrites, ceramic-like material made from a mix of iron oxide with nickel, strontium, and cobalt. Temporary magnets. These become magnetized in the presence of magnetic field. They lose their magnetism gradually when the magnetic field is removed. Example, some of the irons and iron ore alloys. Needles and paper clips can also act as the temporary magnets. The third one are the electromagnets, which are created by running an electrical current through a coil with a metal core. The energized coil creates a magnetic field. When the current is shut off, the magnetic field also disappears. As we can see in the figure beside, as we run current through a metallic core, a magnetic field is generated around the coil. Magnetic field due to a straight current carrying conductor. When current passes through a straight conductor, a magnetic field is generated around it. Based on right-hand thumb rule, we can find out the direction of the magnetic field. The right-hand thumb rule states that if you extend the thumb of your right hand in the direction of the current and curl your finger, then the direction in which your finger curls gives you the direction of the magnetic field. This can also be verified using a simple experiment which we will see in the next slide, where we will take a metallic conductor and will sprinkle some iron fillings around it. When we will run current through this metallic conductor, we will see this iron fillings start arranging themselves in the concentric circle, which represents the magnetic field around the current carrying conductor.
We know that a current carrying conductor behaves like a magnet. So, What is the pattern of this magnetic field? Let us do an activity to find out the pattern around it. We have taken a straight, thick copper wire connected to an electric circuit to pass current through it. And iron filings in a sprinkler. Sprinkle iron filings around the conductor. Insert the plug key and observe. We can observe that the iron filings are aligning in a pattern of concentric circles. These represent magnetic field lines. Let's place the compass over these lines. The direction of the north pole of the compass represents the direction of these magnetic field lines. By moving the compass over the lines, we can see the direction at each point. By moving the compass away from the conductor, we can see that the deflection of the needle decreases. It indicates that the magnetic field decreases as the distance from it increases. It can be noticed by the larger circles formed away from the conductor. So, we found that a straight conductor carrying current produces concentric magnetic field lines around it.
Download Spark Learning app.
As we have seen previously, that when current passes through a straight conductor, magnetic field is generated around it. Similar to that, a magnetic field is also generated when a current passes through a circular loop or solenoid made out of conductors. Circular loop. The right-hand thumb rule can easily be extended to a circular loop by taking infinitely small sets of straight conductor around the loop and noting their magnetic field. A solenoid. Solenoid is a coil of many circular windings wrapped in a shape of cylinder. When current is passed through it, it behaves similar to a bar magnet, producing a very similar field pattern as of a bar magnet. To increase the strength, soft iron core is used. The figure on the right hand side shows a solenoid on the top and a current carrying loop, circular loop on the bottom. Force on a straight current carrying conductor due to magnetic field. When a current carrying conductor is placed in a uniform magnetic field acting perpendicular to the direction of current, the conductor experiences a force acting in a direction transverse to both current and the magnetic field direction. The magnetic force depends upon the charge of the particle, the velocity of the particle, and the magnetic field in which it is placed. The direction of the magnetic force is opposite to that of the positive charge and is given by force is equals to Q into V cross B, where Q is the charge on particle, V is the velocity, and B is the magnetic field. The direction of the force can be predicted by using Fleming's left-hand rule. Fleming's left-hand rule states that the direction of the force applied to the current carrying wire is perpendicular to both the direction of the current as well as the magnetic field, and it can be found out by extending your thumb, your index finger and your center finger perpendicular to each other. Now placing your center finger in the direction of the current and your index finger in the direction of the magnetic field, the direction of the thumb gives you the direction of force exerted. For example, in the case shown in this figure, we extend our center finger towards the direction of the current, our index finger towards the direction of the magnetic field, and then our thumb is extended towards the top, which gives you the direction of the force exerted. Now we will understand the Faraday's experiment. Faraday hypothesized that a changing magnetic field is necessary to induce a current in a nearby circuit. To test his hypothesis, he made a coil by wrapping a paper cylinder with wire. He connected the coil to a galvanometer and then moved a magnet back and forth inside the cylinder. When you move the magnet back and forth, you notice that the galvanometer needle moves. We also notice that as soon as we stop moving the magnet, the needle immediately returns to zero, which means a moving magnetic field is required to set up a current in a coil. The same concept is used for electricity generation, where mechanical energy is converted to electrical energy. Now, we'll know some of the fun facts. A freely suspended magnet always rests in the north-south direction because the magnetic south pole of Earth lies in the geographic north direction and magnetic north pole of the Earth lies in the geographical south direction. As unlike poles attract and like poles repel, a magnet aligns itself in north-south direction. The same concept is used for the compass. The most powerful magnet in the universe is actually a star called magneta. These are stars that have died off and had a supernova explosion. The magnetas are what is left over, and they are strong enough to destroy small planets if they get close enough. Luckily, there are only dozens of these according to the scientist, and they are far, far, far away from the Earth. Magnets have been used to study bee communication pattern, migratory cycles, and several other animal behaviors. So friends, this was all for this presentation. Today we understood the magnet, the magnetic field, how the magnetic field is used for generation of electricity. We understood the Faraday's law, we understood the right-hand thumb rule law, and we also came to know some of the fun facts. Thank you for your attention.
I now request Tushar to take a few questions from the audience.
Yeah. Hi everyone. So most of the questions which have been there, I guess I have almost answered all of them within the presentation, but there are a few interesting questions which I would like to take. So one of the question is that why does the same magnetic poles repel? Is it due to the magnetic field lines? Yes, it is due to the magnetic field lines. And when we placed two similar poles together, what happens is that both the poles, the magnetic field lines are opposite to each other, which causes the repelling of the poles, right? Another question was that are Earth and other planets a live magnet? Yes, Earth and other planets, many of them are live planets, and among them, Jupiter wins the race because it has the highest magnetic field around its planet. Related to this, one question is that how does Earth's magnetic fields save us from the harmful rays and solar storms? So basically, solar storms are kind of charged particles. So what happens is when they are reaching towards Earth, the magnetic field of Earth, which emerges from the magnetic north pole of the Earth and comes back to the south, it deflects those charged particles. So yeah, this is how it protects us from them. Yeah.
You can take one more question, Tushar.
Yes. Why magnetic axis of Earth does not coincide perfectly with the geographic axis of the Earth? So basically, see, if when we take a magnet, what happens is its north pole generally points towards the magnetic south pole of the Earth. So that's where the north pole of the geographic north pole of the Earth lies, right? So yeah. Yeah, so I guess I've answered most of the
Yeah,
questions.
thank you, Tushar. Yeah, thank you for answering. Electricity and magnetism are intrinsically related to each other. We saw in the previous video what an electromagnet is. Now let us see how to make one.
Hello everyone. Today I am going to demonstrate you how to make an electromagnet at home. So what magnets are? Magnets are the objects that can attract or repel some materials like iron, nickel, cobalt, or other magnets. Magnet has one north and one south pole. There are two types of magnet, that is permanent magnet and temporary magnet. Permanent magnet are which always have magnetic properties. On the other hand, temporary magnets which can be switched on and off as our requirement. Electromagnetic is also a temporary magnet. What things we are going to require for this demonstration? These are the basic things we are going to require. The first one is the battery holder and electric wires for the connection. Any battery is fine, but we are taking here AA batteries. One long iron nail or any small iron rod, some insulated copper wire, one magnetic compass, some magnetic materials or any iron materials like paper clip or coin is fine. So for making this nail an electromagnet, we need a copper wire. We are going to wrap this copper wire around this nail. You need to be careful, just leave a 5 centimeter of this copper wire at this end, which unwrapped, and then start wrapping this copper wire around this nail. So wrap as tightly as you can and as dense as you can. So as dense as you can wrap it will make the magnetic field better. After wrapping it completely, you leave the other end also 5 centimeter to connect it with battery. So this is how our nail looking after wrapping the coil around. See how dense we wrap this coil. So before connecting it with batteries, we need to remove the insulation from both of the ends. We are going to use this sharp knife for this purpose. So be careful guys while using the sharp knife. Do it under the supervision of any adult. We gently rub the both ends to remove the isolation. This copper wire is insulated, but the insulation coating is so thin, while we were scratching it from knife, we cannot even see the coating coming out. Now we are ready to connect it with battery. So we can connect any of this end with any of the terminal of the battery. So red terminal is the positive terminal and the black terminal is negative terminal. In this circuit, current flows from positive terminal to negative terminal from this coil, and because of this current, magnetic fields generates in this copper wire. Now we are connected our coil with the batteries. So now we are going to check if our coil became an electromagnet or not. So for this purpose, I am going to use this magnetic compass. So we can see the needle of this compass is painted red, and this red point is north and this other point is south. So we bring this compass near this coil, and we can see the needle of this compass is dancing when we are moving around this coil. So it confirms that our coil become the electromagnet now. Now we are going to check which end of this electromagnet is north and which point is south. For this, we are going to check which end of this electromagnet repels the red point. So we take this red point near this end, which is connected with red wire, and as we can see, this red point attracts by this end, and here at this end this red point is repelled by this end, which is connected with the black wire. So we can say this end is north and this end is south. We write down here. And now it's time to have some fun with this electromagnet which we made at home. So we take some paper clips like before, and some oil pins, some coin, and washer. So it is not advised to touch this electromagnet with hand. It may be hot, or it's generally not advised to pick any current carrying coils or wires. So please careful about it. And now we try to lift these things from the ground, and we can see we easily able to see. See how our coin is dancing. You can also make your own electromagnet at home. Please be careful while using all these sharp knives and other things and batteries and coils, and have fun. Enjoy science. Thank you.
I now request Abhishek to take a few questions from the audience.
Hello guys, I hope I am audible and
Yes.
you can see me. So first question I got is what voltage have been used? So you can use a 9-volt battery, but we used a 1.5 volt this cells which are 4, so total 6 volts. So can you give some example of electromagnets in real life? Okay, this is really a good question. You should know where it is used. So these things have a very wide range of applications, from medical to engineering fields. So first, as you all can know, the speakers, the audio devices. So electromagnets are used there. In medical equipments like MRI machines, these electromagnets are used there. Some of the cranes you have seen, in which you're seeing the toes are really heavy weights, so these are also used there. Another, what is the difference between permanent magnet and a temporary magnet? So we call permanent magnets permanent because they have this magnetic property. They always have their magnetic property. They are permanent. But temporary magnets are something that like some iron core, which stays for a long while in magnetic field, can have magnetic properties for some time. This is also a temporary magnet, or like electromagnets, which we can switch on and off using the current. Okay, so that's also a type of temporary magnet in some sense. Another question Can we only turn a needle into electromagnet or any metal? Yes. These cores are used to use this iron core is used to increase the strength of magnetic field. Actual electromagnet is the solenoid, means the turned wire, that is an electromagnet. These cores are used to increase the strength of this coil. Why should we not keep magnets with electronic devices? Okay, so electronic devices carries currents, and as you seen in previous videos, current carrying coils and conductors have their own magnetic fields. So when you keep magnet near them, those devices feel when the current flows inside those devices, they get affected by it. So it is not advised to keep magnets near electronic devices. Plus one more thing, in the old times this magnetic tapes are used for this as memory devices like hard disk or something. So those are made of magnets. So when you put a magnet near them, there means it is there is a chance to lose your data. Okay, so this is not advised to use magnets near electronic devices. Okay, can I increase the number of coils? Oh, definitely. So by increasing number of coils, you can increase the strength. There is actual catch here. So you should not you should not increase the number of coils, but increase the coil density. Coil density is means you can increase coils, but they are very dense. Means per unit length, you need more number of coils to increase the magnetic strength. Okay.
Okay, Abhishek, you can take one last question if you have any questions.
I don't have any questions actually. These are all.
Okay. Okay. Thank you. Thank you very much, Abhishek. Yeah. Now we saw some experiments on electricity and magnetism. The next module is on electrolysis, the chemical effects of electric current. The first video in this module is electrolysis of water. Let's watch the video.
This video is about electrolysis of water. We are going to show you how you can perform electrolysis of water at home with very simple equipments. So let's see. Some of the questions we will try to answer are these. First and foremost, what is electrolysis? Secondly, how to separate water into oxygen and hydrogen. Even if we can separate, can we see oxygen and hydrogen gas? These two questions will be answered while you see the experiment. We will explain the whole process in detail while making the setup. The next question is, can you identify which is oxygen and which one is hydrogen? For that, we will explain you the basic mechanism of electrolysis of water, and then you can surely identify. So electrolysis of water is a method of using electricity to decompose water into hydrogen and oxygen. The overall reaction looks like this. H2O breaks into hydrogen and half O2. But is the process as easy as it is shown in overall reaction? The answer is no. At this time, you should know that there are ionic reactions in water when electricity is passed. Now comes the schematic of the experiment. You can clearly see the diagram. I will introduce all the components one by one. First, two ends of battery, positive and negative. Then, two electrodes, basically a metal to conduct electricity. One connected to negative end called cathode and other connected to positive end called anode. Lastly, the electrolyte. We will use water and some materials added to it. We will discuss about materials next. Hydrogen is produced at cathode and oxygen is produced at anode. Now, the materials we need to use with pure water. Pure water is not a good conductor of electricity. We need to use some other material with water to increase the conductivity of water. Remember, our goal is to produce hydrogen and oxygen. So, what materials we need to use? Can we use normal salt, NaCl? No, we can't. What about sodium hydroxide, NaOH? Yes, we can. What about baking soda, NaHCO3? Yes, we can. Can we use hydrochloric acid, HCl? No, we can't. Because by using NaCl and HCl, we will produce chlorine gas instead of oxygen. And chlorine gas is harmful for health. Now, we will move on to the experiment.
Our experiment is electrolysis of water. Our final aim will be to show you production of hydrogen bubbles and oxygen bubbles separately. So these are all the equipments we will be using for the experiment today. First, this is a container, small container with 2 holes at the bottom. These are pins. You can see the metal tip. These pins are used as a conductors. These are basically electrodes. You can use nails also. For the power source, we will be using 9-volt battery. You can use any other power source, but it should be DC. 2 small test tubes for the visualization of bubbles. Wires to connect the electrodes to the battery. We will be using tap water, and with that we will be using NaOH, that is sodium hydroxide, to increase the conductivity of the water. This will be used to lift the setup from the base.
A quick recap of what all we used: container, metal pins, battery, wire, water plus NaOH, test tubes. That's it. Let's see the setup now.
So now we will use these pins and we will connect the wires to the pins. And we'll push these pins through the hole at the bottom. So it will be looking like this. Now we will be putting this cup on the base. Like this. Now we will put NaOH plates, that is sodium hydroxide, in water and mix it properly. And pour this in the cup. Now we will use this test tubes. This is very important and tricky. So we will fill the test tube with the mixture. Now you should close the end and dip it inside the water and put it just on top of the pin. We'll do same for the next test tube. We'll fill it, close it and dip it inside water and carefully place it on top of the pin. So we'll be using this battery. We'll connect one end of the wire with positive and one end with the negative, and we will see the bubbles coming up through these tubes.
you can see the bubbles are coming up. You can clearly see the amount of bubble is higher at the left test tube and lower at the right one. From the left one, hydrogen bubble is coming, and from the right one, oxygen bubble is coming. Till now, these two questions have been answered. You have seen the process of separating water into oxygen and hydrogen, and you have seen the oxygen and hydrogen gas as bubbles. But can you identify which one is oxygen and which one is hydrogen? I have told that left one is hydrogen gas and right one is oxygen gas. How do I know? Let's see the mechanism, then you will know. Now the mechanism in brief. There will be H plus and OH minus ions in water. H plus, the cations, will be attracted to the negative end of the battery. OH minus, the anions, will be attracted to the positive end of the battery. Look at the reaction. At the positive end, OH minus give up electrons to produce O2. At negative end, H plus ion take up those electrons to produce H2. And we sum up all these reactions to one overall reaction, that is H2O breaks into H2 and O2. Finally, see the coefficient of O2 and H2 in the reaction. The coefficient of hydrogen is twice than the coefficient of oxygen. So in the experiment, we should see more H2 produced than oxygen. Let's see the bubble production again. You can clearly see production of bubble is more in left tube than the right. Also, accumulation of gas at the top of the tube is more for left one than the right one. Now you can guess which one is which. Yes, left one is hydrogen and right one is oxygen. Hope you have got an overall idea of electrolysis of water, why and how hydrogen and oxygen is produced, what equipments and materials you need to use, and how you can visualize the bubbles. Now you can replicate the experiments at home. Thank you.
We all know that water is made up of hydrogen and oxygen, but did you know that it can be easily separated like this at home with simple equipments? Well, now let us go to the next experiment of electroplating.
Hello students. Today we will be discussing about electroplating, which is one of the chemical effects of electric current. The picture that you see here is of bicycle. I'm sure you have seen this shiny appearance on handlebars and other parts in your cycle. The cycle is made of iron, which is not this much shiny. Then how is this shiny appearance achieved? This is achieved by coating chromium metal over the iron, which has shiny appearance. Now you must be thinking how to coat one metal on another. It is done by the process known as electroplating. I will describe this process by a simple experiment. We will take a copper sulfate solution and then we will take two metal rods, one which is to be coated, that is iron rod in our case, and second that has to be coated on the iron rod, which is copper in our case. We will dip these rods in a copper sulfate solution and pass an electric current through it. For this, we need a battery and an electrical connection between the rods. We will connect the metal to be coated, that is the iron rod, to the negative terminal of the battery and connect the metal that has to be coated, that is copper rod, to the positive terminal of the battery. The copper sulfate solution contains copper and sulfate ions. Here copper ions are represented by orange color and sulfate ions are represented by green color. When an electric current is passed through the solution, positively charged copper ion will move towards negatively charged electrode. Then there will be deficiency of copper ions in the solution and therefore the copper rod will dissolve in the solution to counter this deficiency. In this way, we can coat copper on iron rod. Therefore, the process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. The question is, why do we need to coat one metal on another? In this picture that you are seeing here, on the left hand side, there is a rusted part, and on the right hand side, there is a shiny chromium coated part. So when we coat any material with chromium, it imparts shiny appearance to it and also prevents corrosion in it. We cannot make the complete part with chromium as chromium is an expensive metal. So we make the part with a cheap metal and then coat it with chromium to get shiny appearance and corrosion resistance. Another example of coating one metal on another are ornaments. Sometimes we make ornaments of copper, which is a cheaper metal, and then coat it with silver or gold, which are expensive. By doing so, we get the appearance of gold or silver at relatively low cost. We also use tin coating in food containers, which are made of iron that reacts with food and corrodes. Tin is relatively less reactive and hence prevents the corrosion of container and spoiling of food. Now I will demonstrate this electroplating experiment. So the materials required for this experiment is we'll need two electrodes. So one electrode we'll make of this copper rod, and the second electrode we'll make of iron, and this coin will behave as an iron electrode. You can take any coin, 1 rupee or 2 rupee coin. This blue color salt is the copper sulfate salt, which we'll use for making copper sulfate solution, and this is normal water. We will need some wires, and this is 9-volt battery. So first of all, we'll make sure that the copper rod that we have, we'll rub it with sandpaper to make sure that any oxide layer deposited on this copper rod is cleaned off. And then we will connect wires to this copper rod and coin to make them electrode. And then we will dissolve this salt into water and mix it thoroughly so that uniform solution is made. At the end of the experiment, I'll show that a layer of copper is deposited on this coin. So students, this is the copper sulfate solution, which is blue in color. And this is the diagram, the experimental setup that we will be making. It contains a copper rod, which will be connected to the positive side of the battery, and an iron rod, which is coin in our case, and it will be connected to the negative side of the battery. And these both electrode will be dipped in the copper sulfate solution. So this is the copper rod that I have cut, and this is the coin, and this is the arrangement that I made. I will dip this into the solution. As you can see, it is dipped. So I have to connect copper rod to the positive terminal, positive side of the battery. So I will connect it to this positive side, and the wire connected to the iron rod or the coin here in this case, we will connect it to the negative side of the battery. This is the negative side. So the electroplating has begun, and we will have to wait for 15 minutes for this experiment, and then the electroplating will be completed. See, this is the electroplating happening. You can see the black layer on the coin, that is the copper layer which is being deposited. So students, now 15 minutes are completed and I will take out the coin. This is the copper layer, which you can see is of copper color deposited on the coin. Line in the middle of the coin is due to the wire that was wrapped around it, so it is not coated on that line. Otherwise, all of the coin is coated with this copper layer.
You have seen two videos on the chemical effect of electric current. One is electrolysis of water and the second one was electroplating. Now I request Anshul to switch on your camera and unmute your microphone. You can answer the questions related to these two topics.
Hello. Hello everyone. I hope I am visible clearly and clearly audible also. So first question is, why do we use conducting solvent that is water with sodium hydroxide and not pure water? So the thing is, this question is for hydrolysis of water. So the thing is, for hydrolysis of water, we need the ions in the water to transfer from one anode to another anode, right? So we need to create a more conductive medium for which we dissolve the NaOH that creates ions in the water, and hence the ions, positive ions, will be attracted towards the negative cathode. Negative terminal, and negative ions will be attracted towards positive ions. Whereas pure water does not have so many ions, free floating ions. Hence, we need to add sodium hydroxide. Other thing, second question is, why do we use only a DC battery and not AC? Basically, we want to create a particular anode and cathode, particular type of electrode at some point. So if we will connect a AC supply, then these electrode will change periodically. AC is fluctuating, like right? It changes. So positive terminal and negative terminal keeps on changing over the time period. But we want the electrode to be fixed. That's why we will be able to like hydrogen will be attracted towards the cathode, and oxygen will be attracted towards anode. But if cathode and anode are itself changing periodically, then we will not see a clear attraction or clear deposition of hydrogen gas or oxygen gases at the electrodes. Other question is, what happens when we use a battery whose power is more than 9 volts? So we can use a battery more than 9 volts also. So voltage of a battery is like a driving force. So if we will use the more voltage, then this electrolysis, the hydrogen gas and oxygen gas will be evolved more. But we need to make sure that don't go beyond 12 volt battery, as it might be risky to operate. Yeah, so anything between 5 volt and 12 volt will work. Only the amount of oxygen and hydrogen gas will be different. Does this NOH act as a catalyst? No, actually the NOH is not acting as a catalyst. It is just creating the more ion, as I told in the first question, it is creating more ions in the solution, so that the positive ions of hydrogen is attracted towards the negative electrode, and positive ions, negative ions of oxygens are attracted towards the positive electrode. Okay, and the other question is the other questions are for electroplating. Can we electroplate with any other metals that using the same method? Yes, we can electroplate any other metal also, but the only thing different would be in this whole procedure would be the salt that we are selecting. So in this experiment, we have selected copper sulfate because we were working with copper, and we wanted to create a solution in which copper ion is in excess.
So if we are working with any other metals, for example, if we want to coat silver on the iron, then the solution also we will need to take of silver, maybe silver chloride, AgCl. We can take that, and then we can do the same experiment. It will work fine. The other question is, can we take water plus salt for electroplating experiment? No, we can't take. So as I told you that for electroplating experiment, we need to take the salt of the same metal that we want to deposit. So we wanted to deposit copper on iron, so we have taken copper sulfate. Similarly, if you want to deposit silver, we will take silver chloride, but not water plus salt will not work, because there will not be excess of copper or silver in the solution in such a case.
Okay, Anshul, you can take one last question.
Yeah. So last question is, can we clean this deposited copper layer with sandpaper? So yeah, the experiment that I showed you is a very simple experiment, and it can be cleaned easily by rubbing with paper. But in industry, they use some more chemicals to make this layer more stable, and there we can't clean it. So in your cycles, as you see, there is a chromium plated. So you cannot remove your chromium plated with rubbing with sandpaper or something. Yeah. Thank you.
Thank you, Anshul, for clearing many doubts. So you have seen the experiments of the chemical effects of electric current. Hope you too repeat this in your home with basic equipments. Now let us go to the next module of optics, where you can see experiments on reflection and different properties of light.
So this experiment we are doing to demonstrate the laws of reflection. Here we are using a plane mirror. This would be used for the experiment, and the first thing which we are using here is this comb. So on the opposite side we are closing all the sides so that only one slit is open, so that it is able to serve the purpose of a single light ray. For the source of light, we are using this torch. This torch is also, we have covered here, so that when we press it, it gives a single source of light, which can be shown like this. The intensity of the light right now would not be seen clearly because the lights are switched on in the room. Apart from this, here on a paper, we have marked the incident ray which we would follow, and this would be the reflected ray. Now the law of reflection is angle of incidence is equal to angle of reflection. So for this case, angle of incidence is equal to 30 degrees, which is measured from the normal. And here we have already marked angle of reflection is equal to 30 degree. So the light should go from here and reflect through this. Similarly, for the 45 degree angle, light should go on this path and reflect from here towards this way. Now we are going to see two examples of this law. First, the incident light on the mirror is at 45 degrees to the normal, and the reflected ray from the mirror is also at 45 degrees, marked in red. Now we change the angle of incidence to 30 degrees, and we can see that the angle of reflection changes to 30 degrees. In this experiment, we can also see that the incident ray, the reflected ray, and the normal ray, all three lie on the same plane, which here is the sheet of paper which is lying perpendicular to the surface of mirror.
The next video demonstrates multiple reflections.
Hello guys, you might have wondered how you are able to see the backside of your head when you go for a haircut in a barber shop. If you have noticed, the barber uses another mirror behind your head facing the front mirror, and on the front mirror you see the backside of your head. This is basically called multiple reflection. Today we will demonstrate multiple reflection. For this we have used two plane mirrors that are inclined at particular angle and an object for reflection that is a paper load. As you can see, it is placed in between the mirrors. Also to your left you can see three lines, two in red and one in black. The first red, on which the left mirror is kept, is drawn at 60 degree with respect to the right mirror. The black is at 90 degree and the last outer red line is at 120 degree with respect to the first mirror or the right mirror. Now what we do is we will vary the angle between these mirrors and see what happens to the number of images of the paper load that is formed by the mirrors. For the first case, we have placed mirror at 60 degree and we can see 5 images formed, 2 on each mirror and 1 in between. Now we will increase the angle between the mirrors to 90 degree and as you can see 3 images are formed. Similarly, as we increase the angle to 120 degree, that is indicated by the outer red line, we can see only 2 images that is found between the mirrors. Now we might relate this demonstration to that observed in the barber shop. Though you will study in detail the formation of multiple images in +2, for now what you can remember is that an image of a mirror behaves like an object for another mirror, and this process continues unless the images formed by each mirror start superimposing upon each other. By this what I mean to say is images by each mirror coincides and are seen as a single image after the formation of a certain number of images. Now the question arises, how many such images are formed? So for this you will be taught in detail about these all phenomenon and the number of images formed between two plane mirrors at any particular angle in +2.
Playing with light and mirrors is always fun and interesting to watch. Now let's watch one more video about diffuse reflection. We will demonstrate the difference between regular and irregular reflection or diffuse reflection, which is a property of the reflecting surface. To demonstrate it, we will use the same apparatus as that used to demonstrate the law of reflection, except that we have covered about 40% of the mirror with crumbled aluminum foil and left remaining 60% uncovered. The portion covered in foil creates a rough surface as the foil is crumbled, and the remaining uncovered part is smooth. The difference in texture of the surface will help us create different types of reflection. The rough surface creates diffused reflection, while the smooth one creates regular reflection. To demonstrate it, let us use law of reflection, that is angle of incidence is equal to angle of reflection. First, we will see regular reflection. For this, we make the light ray incident on the plane mirror. We can observe that the light ray gets reflected by the mirror as a single concentrated ray and follows the law of reflection. Now we will slowly move the mirror towards left such that the incident light hits the mirror covered in foil paper. We can observe that the reflected light is very faint and it doesn't follow a single light path. That is, the reflected light ray is diffused now. This is due to the rough surface that is created on the plane mirror. till now, you have watched videos on the laws of reflection. Now let us watch a video on the refraction.
Hi friends, now we will see refraction of light. Refraction of light is the bending of light as it passes from one medium to another. Let's see the equipments now. For these experiments, we are using a glass slab, a point source laser, and some thumbnails. We will be using a white paper to draw different direction of different light rays. And first, now we will trace the boundaries of the slab on the paper, and then we will move forward. Now we will draw the direction of the incident ray, which will pass through the glass slab. Let's take the light source. As we know, if there is no obstacle, the light will pass in a straight line. This is known as rectilinear propagation of light. Now I will place a transparent material like glass slab in the path of the light ray. We could see the light is bending as it passes through the glass slab, and when it comes out, it also bends again. Now I will be using thumbnails to trace the direction of the refracted ray. We could see the incident ray is not collinear with the refracted ray. This is due to the bending of the light. Also, some part of the light is reflected by the surface, and we will trace that also using the thumbnails. We have both the refracted ray and the reflected ray. Now we will remove the glass slab and the thumbnails, and then we will trace the points to make the rays. Now this is the refracted ray coming out of the slab, and this is the reflected ray which is being reflected by the surface of the glass slab. Now I will trace the path of the light ray inside the glass slab by joining these 2 points. Also, I will add the direction using the arrows. Now I'll bring the glass slab again and use the light source to have the same incidence light. And we could see the path is same as that we have traced using the pen. And we could see the light traveling through the slab and the refracted ray. And this is the refraction of light. Thank you.
We have seen a series of experiments related to light, which were very simple and yet interesting. Now I request Adip to switch on your microphone and video camera and take up the questions related to optics.
Hi, so I hope I'm audible.
Yes, Adip, you are audible.
Okay, so the first question is, what is light? So light or visible light is a form of energy that can be detected by the human eye. Okay, so it is made up of electromagnetic radiation and it travels in a straight path. So that can be a definition for light. So the next question now is, what are the laws of reflection? So we have 2 laws of reflection. One is that the angle of incidence and angle of reflection both are equal. Okay, so these angle of incidence and angle of reflection are measured between the incident light and the normal to the mirror, and the reflected angle is also measured between the reflected light and the normal to the mirror. Okay, so this is the first law, and the second law is that the incident light, the normal and the reflected light, all these 3 lie on the same plane. So these 2 are the laws for the reflection. So next question is, what is multiple reflections? So when we use more than one mirror, so the reflected light from one mirror is serving as an incident ray for the other mirror. So because of that, as more than one incident light we have, so we have more than one image formation also. So generally we have a rule that we have a formula that for number of images we have, if the angle between two mirrors is theta, so the number of images formed would be 360 degrees divided by theta minus 1. So that is multiple reflection. But in the case of parallel mirrors, what will happen is that if the mirrors are facing each other, then we'll form only two images, one on each mirror. And if the faces are not facing each other, if the mirrors are not facing each other, then we'll get only one image. Okay, so the next question is, what is the difference between reflection and refraction? So reflection basically refers to when the light is bouncing back from a surface and it's changing its path. Okay, but that is related to a reflectivity of a material. But when we talk about refraction, so refraction is generally exhibited by materials which are optically, like light can travel through them. So those materials are generally exhibiting refraction. So glass is one such material. Other materials can be, for example, water. So what is another example of refraction? So another question is, what is the laws of refraction? So for the law of refraction, we have Snell's law of refraction, which states that the ratio of angle of incidence by the angle of reflection for any color of light for any pair of two materials. Like when we talk about refraction, light is passing from one material to another material. So for any such pair of materials, the ratio of sign of incidence divided by the sign of refraction stays constant. Okay, so yeah, so these are the questions.
Thank you, Adib, for answering all the questions in detail.
Okay, thank you.
Yeah, thank you. You all must have seen a rainbow on a rainy day. The display of 7 colors is always mesmerizing to our eyes. Today, let us understand how the rainbow is formed and how can we make one within our homes.
Hello, dear friends. Namaskara. I hope that you all are well and fine. Today, we will talk about one of the beautiful natural phenomena called a rainbow. And we will try to figure out if the sunlight, which looks bright white, is actually white or colored. And yes, that's the topic of our discussion today. Rainbow formation. Is sunlight white or colorful? So friends, in rainy season, sometimes we see the bands of beautiful colors in the sky, and that's a rainbow. So in scientific language, a rainbow is a natural phenomena in which the bands of several colors, namely 7, are seen in the sky due to splitting of sunlight, which is also called dispersion of white light. This happens by rain or other water droplets of the atmosphere. You see there's a sun shining and there's some water droplets in the atmosphere and a bunch of kids standing in between. They see a rainbow. Similar situations happen when we observe a rainbow in the sky. So when and where do we see rainbows? Let's dig into our memories and try to find out as to when and where all we have seen such bands of colors. First, as we described, we saw rainbow in sky during rainy season. But friends, can we see a rainbow forming in bright sunny day too? The answer is yes. So if you go to some parks or location like this, where you find such a fountain, you may see a rainbow. Also, if you go on a trip to some waterfall with a family or school group like this, you have a chance of seeing a rainbow there too. Moreover, we also observe the mixture of colors appearing on soap bubbles and series placed in lights. So how does the rainbow form? Sunlight is a white light. It's a mixture of 7 colors. We name it as Vibgyor. Rainbow is formed due to dispersion of sunlight into 7 constituent colors. You must have learned in your 7th standard that there is an object known as prism, and this prism makes us see different colors of sunlight. In nature, raindrops or any other water formed in the atmosphere act as prisms, and that is why we see rainbow in the sky. Now let's see more science to it. 2 fundamental optical phenomena are responsible for the formation of rainbow. First one is the reflection. When a light ray falls on a mirror surface, it reflects back from the surface. So you see this is an image taken from your 8th standard science book. So the black lines are the incident rays and the blue are the reflected rays, and this is a plane mirror. And we see a real life example. One bird is just flew off this water surface and the photographer captures the actual bird and its image in the sky. And the other phenomena responsible for the formation of rainbow is refraction. It's a bending of light rays on passing through one medium to another of different density. So you see, friends, this is a light ray. It's in the medium of air. Now it enters the second medium, which is water. Both are having different density. And when it enters into the medium of higher density, it bends towards the normal. So the practical life example, take a glass full of water, a transparent glass, and you dip a pencil. So the part of pencil that is submerged in the water looks shifted from what we see in the air, and this is due to refraction. We now understand the very physics of the rainbow formation. So this is the sun. Let's take one light ray from the sun, AB, and at B, the light ray enters this circular rain droplet, and the refraction happens as B. Why? Because the light is entering from air to the water, because it's a raindrop, and then dispersion of light happens. This is due to difference in the wavelengths you will study in the higher standards. And after this refraction happens at the back surface of the raindrop, there's a reflection happening. And then at point D, now this whole bunch of colors will move from water droplets to air. So again, there's refraction. And here we are standing with our eyes and we see this beautiful band of colors. So now let's form a rainbow. So what are the things we require? First, strong sunlight, that is a bright sunny day. A small plane mirror. You can have any plane mirror in your home, small mirror. Clear water. Bowl or pan. In Hindi we call it katori. White sheet of a paper. This is just to clearly see the rainbow. And adult supervision. So remember kids, though it is very simple experiment, it is still requires someone elder than you to guide, because you must not look directly either to the bright sun or its reflection in the mirror. Doing so may harm your eyes. So be a little bit cautious. So how to do it? We'll take one medium-sized bowl or pan and we'll fill it with water. Now put a small mirror in the water inside the bowl, like this. Now you may need to position the mirror such that sunlight falls on it. So I have kept this setup in the bright sunlight. Look in the direction of reflected sunlight from the mirror and adjust the angle of the mirror until you see a rainbow. So this is how you're gonna see the rainbow. See friends, as you saw in the image, this image, I have used a scissor to get the required angle of the mirror. You can use anything just to get the proper angle of the mirror to have a reflected light rays from this portion of a mirror which is submerged in the water. And hence, when you place a sheet, you will find a rainbow. So now let's see a demonstration video, friends. Hello kids. Today we are going to do an experiment for rainbow formation. We require simple few materials. So this is one pan. You can also take one big bowl, also one mirror, and white sheet of paper, and of course water. So let's see how the rainbow forms. So you can see a formation of rainbow over here. We see a spectrum of color known as Vibgyor. Now kids, please tell me what are the colors you see in the rainbow. We'll go back to our slide, and yeah, in this image, let's take some seconds and you try to figure out what all colors you can identify. I guess maybe 3, 4, or maximum 5. Maybe like red, yellow, or blue, or purple you can see. But friends, what is happening? You have a red at this end and yellow. And when the red merges with the yellow, there's a formation of orange, an extra color. And similarly, when the yellow merges with the blue, it forms a fringe of a green color. You can see slide here. And similarly with the violet and blue, there is a formation of indigo. So that is why we see additional colors. So what did we learn from the demo experiment we did today? Sunlight is a mixture of all the 7 colors in the rainbow, and these different colors mix together and form a white light. Second thing, the water and the mirror together act as a prism, which breaks up the sunlight into different colors. So I would like to end my presentation on one note. We can do science with whatever we have. We just need to be curious. Thank you, friends.
This was a simple yet exciting experiment to make a rainbow of our own. Now, I would like to request Sudhanshu to take up a few questions from the audience.
Hi friends, I'll take a few questions on rainbow formation. So first question is why rainbow is having 7 colors only? So actually, as we learned that light is a form of energy, and it is of electromagnetic wave, and human eyes can perceive only some small part of that wavelength. And our human eyes have also 3 kinds of photoreceptors which can detect 7 zones of wavelength. So that is why 7 distinct colors we can see. And other is next question is why does the rainbow appear like an arc? So this is obviously due to the spherical shape of the raindrops, because raindrops are acting as prisms as we explained. And yeah, it is. Can there be 2 rainbows at the same time? Yeah, there can be 2 rainbows at the same time, because when the light from the sun rays are falling on the raindrops in the atmosphere at 2 different locations, then you can have multiple rainbows also. And next query is, it is said that rainbow is formed on the opposite side of the sun, but as per the explanation given, it can be said that it is formed at the same side. No, actually, the basic idea behind saying that you should be between the sun and the water droplet is your eyes should be able to perceive the refracted and reflected light rays from the drops. So for that you need sun to be at some angle from you. So it may not be exactly opposite, but at some inclination from your side. So how does a mirror help in formation of rainbows? Okay, so in nature we have raindrop, which is so raindrop is water and air. So air and water have different density. So at the surface of raindrop, there is a reflection happening, and then at the back surface of the raindrop, there is a reflection happening. And that is why when the light enters into the raindrop, it disperses into 7 colors, and then all those 7 colors reflected back from the back of the raindrop. So to create that reflecting back, I have used the mirror, and that reflection from that raindrop is called total internal reflection. So total internal reflection is a refraction only, but when your refraction angle is 90 degree. So ultimately you are having a reflected ray instead of refracted, because your incidence angle is such that your refracted ray are not crossing but coming to in the same medium. Can rainbow be formed in the presence of water in the atmosphere? Yes, rainbow can be formed in the presence of water in the atmosphere. I have explained many examples. Also, I'll say one more interesting fact, that we can see 7 colors in the rainbow, but if we see from if we somehow ask the birds, so then they can they will not say 7 colors, they will say 9 colors, because they have an extra photoreceptor in their retina, the 4th type of receptor, which is in the ultraviolet regions of electromagnetic wave spectrum. So that is why they can see 9 colors and we can see 7 colors. What is water and sky? White water and sky blue in color. So I'm okay. That's it from my side. Thank you.
Thank you, Sudhanshu, for answering all the questions. We next move on to the next segment, which is biology. Have you all observed that all of us resemble our parents in some way? We have some features that are inherited from them, but we don't exactly look like them. Why is that so? We shall look at this explanation in the next video and understand what exactly is heredity.
Have you ever heard people say that you look like your mom or dad or even your grandparents? Have you noticed that some of your features resemble your mother and some resemble your father? Have you noticed that you and your siblings have similar features yet look different from each other? If you look at the world around you, from microbes to plants to animals, all of them have adapted to a particular reproductive strategy to produce organisms that look like them. They also have features that are different in certain aspects. Microorganisms such as viruses and bacteria that reproduce asexually exhibit very little overall variation. Similarly, often trees and crops also look similar in appearance despite reproducing sexually. While closely related humans look similar, they exhibit subtle differentiating characteristics. Human populations exhibit variation in skin, eye, and hair color, physical and body stature, so on and so forth. However, if you look at dogs, we can observe that there is tremendous diversity among various breeds. The genetic variation in dogs is 5 times that of humans. What causes this variation? Sexually reproducing organisms inherit traits from their parents as well as accumulate minor variations and eventually become different from their ancestors. Some of these variations might provide certain advantages and help in survival. Graham John Mendel wanted to understand if there are any rules that define inheritance. Despite coming from a poor family, he used the pea plants grown in his garden to come up with the laws of inheritance. Pea plants are an excellent model system as they exhibit wide range of variation in observable physical traits such as seed coat, flower color, plant height, etc. Mendel demonstrated the heredity in plants by crossing a small and a tall pea plant and observing the next generation. The first F1 generation produced all tall plants. When 2 tall plants from the F1 generation were crossed, the F2 generation produced 3 tall plants and 1 small plant. What is happening here? When the germ cells from the parent organisms combine, half of the genetic information from each of the parent is transmitted to the offspring. Here, the genes that carry this information become the units of heredity. Each of these genes or a group of genes dictate a physical trait or a character. The offspring gets one variant of each gene randomly from each parent and they combine to form the genotype. If the same variant is inherited, then the organism is homozygous for that particular trait. Otherwise, the organism becomes heterozygous. In F1 generation, all the pea plants were tall and heterozygous. The variant for tallness is dominant over shortness and hence tall phenotype is observed in all the plants of the F1 generation. However, when the genes independently segregate in F2 generation, the tall and the short plants are produced in the ratio 3:1. Among the tall plants, both homozygous and heterozygous genotypes were also observed. This shows that both tallness and shortness were inherited in the F1 generation and were passed on to the F2 generation. Similarly, the inheritance of several traits in animals could be demonstrated. This chart shows how the coat color in cat parents is inherited in their offsprings. The eye color as well as the blood type in humans are also transmitted in a very similar manner.
Our next demonstration is on evolution. What is evolution? You must have often heard that humans evolved from monkeys, but is that really true? Because we still see monkeys around. Why do certain species have certain characteristic traits? For example, why do giraffes have long necks? Why are some insects of some particular color? Let us understand this with our next video.
I'm sure you all would have heard people say that humans came from monkeys. But if it were true that all monkeys turned into humans, will we stop seeing monkeys around us one day? Why do monkeys and other apes still exist if they evolved into humans? We will learn the answers to these questions in this presentation today. This quote by evolutionary biologist Theodosius Dobzhansky emphasizes the importance of understanding evolutionary principles while studying living organisms. Evolution is an inheritable change in the genetic makeup of a population of an organism over time. Often colloquially, humans are referred to have evolved from apes. However, we know that evolution is not directional. Humans and chimps inherited the genes of an ape-like common ancestor and then diversified over time to become different species. When can we consider two species as different? According to the biological species concept, two different individuals that can no longer mate and produce viable offspring are classified as distinct species. The process by which these two individuals diversify from each other is known as speciation. But why does speciation occur? Let us take the case of these two insect populations that are distributed across the river. If these two insects do not disperse through long distances and the river forms a geographic barrier that prevents the insects from mating, both these populations might eventually become two different species. Likewise, several factors can prevent two species from interbreeding to produce offspring. For example, lions and tigers can potentially interbreed, but we do not see any ligers in the wild because lion and tiger populations are geographically isolated. These are two different species now. But what facilitates speciation? In the previous video, we studied that random changes in the genetic material of an organism during sexual reproduction causes variation. These variations could be inherited and transmitted to the entire population. What are the mechanisms through which populations evolve? Two popular theories were put forth by Lamarck and Darwin explaining the mechanism of evolution. Lamarck believed that giraffes have evolved long necks after generations of effort to reach for leaves on tall trees. He theorized that the evolution of a character in a species happens through a gradual transformation process. However, Darwin believed that the appearance of long neck in giraffes occurred by accident and the individuals with the long neck variation survived long enough to produce many babies due to their ability to reach tall trees. They become stronger because of their ability to reach tall trees. Eventually, long-necked giraffes increased in number while the short-necked ones were weak and died and became extinct. This is also quoted as the survival of the fittest. Let us look at this example to understand Darwin's theory. We have this red-colored insect population. They get predated by these little blue birds which can accurately distinguish these red insects in the green grass. Later, a spontaneous green variation arises in the insect population. Now, the insects that carry this variation are not predated by birds as the birds cannot distinguish them from the green grass background. The number of insects with this green variation increases and get transmitted throughout the population. The green variation here is selected due to the advantage, and this process is called natural selection. Here, the green variation is equivalent to the long neck in giraffes. However, let us imagine that an elephant runs over the green insects and kills all of them. Only the red insects remain. The elephant did not intentionally kill the green insects. It was an accident. It was spontaneous and random. There is no selective advantage because of this event. This phenomenon is known as genetic drift. The elephant could not have wiped out the green variant completely if the population size was larger. The effect of drift is therefore more pronounced in small populations. Thus, genetic drift and natural selection are the two most important mechanisms through which populations evolve. And now we know that this is how humans and chimps evolved into completely two different species.
I hope now we know a little better about heredity and evolution. I would now request Senji to answer a few questions from the audience.
Hi everyone. So yeah, I'm going to be explaining about. Can you explain something about twins? Human twins are closely related siblings, but they look very identical to one another because in any other siblings, the zygotes develop separately. That is, the two zygotes are different and the embryo is different. But in case of twins, after the development occurs, they split into two. The egg splits into two, and the organisms develop individually. This is different from the egg developing into two different individuals from scratch. So whatever changes that occur between the siblings during the development stage, that is during the recombination phase in the cell cycle, all of this happens for twins together, and the split happens after that. That is why most of the variation that occurs for siblings during the recombination phase is eliminated for twins. That is why the human twins look very similar to one another. This is also the reason why many plants or bacteria or other organisms that have sexual reproduction but do not look very different also looks with very similar features. That's because there is not much recombination happening that separates the two individuals from one another. The next question is, why can't we breed one animal race with another animal race? So we saw an explanation for this in the evolution video, where there is a reproductive barrier between the two races. It could be because of several factors. They could be either present in completely two different geographical regions, so the two animal races never come together, or it could be because they do not have compatible sexual cells, like the eggs and the sperm could be completely different from one another, and hence even if we try to breed them, the young one will not develop, or even if it develops, it will die immediately. That is also one of the reasons why the ligers which are found in the zoos are not found in the natural environment. Can you tell something about the well-known question if N came first or the egg came first? So according to evolution, many species and many organisms have developed from eggs. Even before hens came in the evolutionary pathway, there were many other organisms, including insects and other arthropods and other reptiles. Many of them were egg-laying animals, and the young ones developed from the egg. So egg existed in the evolutionary tree much before hens developed in the evolutionary pathway. So from an evolutionary biologist point of view, the egg came first. What were the first species on Earth? This is still debated whether it is a microorganism like bacteria or it is an virus, something which is not a living organism outside a bacteria or any other entity. So it could have either been archaeobacteria, like old bacterial species, or it could be a chemical entity like virus, which came first. Can a different organism, say like dog, evolve to humans or similar to us? So in terms of evolution, as in if we are looking at this from a perspective of how we think that monkeys evolved into humans, which is not exactly true, which is what we looked at in the video. Monkeys and humans had a common ancestor, but dogs and humans are not that closely related. So we can't have a form which looks like human come from a common ancestor of dog. But we all know that dogs, or what we see currently as dogs, is a species which came from wolves. The wolves that we see in the forest and the dogs are closely related. And these modern day dogs actually came from wolves. Yeah, so that's about it for today. Thank you so much.
Thank you so much, Senji, for clearing all the doubts. Moving on to our next video. We know that human body is a very complex system. Many organs together enable us to perform various activities throughout the day. Let us now learn about the different organs using an anatomy model.
Hey kids, I'm Prince.
I'm Shruti, and our friend Supreet will be joining us too.
I hope you're all doing well. And today we're here to take you on an extremely exciting journey to the most fascinating human body. Before we begin, do you see a motor car on the screen? Shruti, can you help us describe the motor car?
Sure. So the car has a metal framework, tires, and engines to drive the car. So before going back to the human body, we'll take a look at this small clip.
That was a very interesting video. Don't you think that human body and the motor car are similar in some sense?
Oh, that's so true, Prince.
Similarly, doctors and scientists have always wondered what the human body consists of. Today we're going to show you how intricately our human body is designed and how does it functions. Shruti, can you begin it with explaining the head?
Yeah, sure. So the head houses the control center of the body, which we call the brain. Here is the cross section of the brain. So brain helps in controlling and coordinating all the body movements. And the head also has sensory organs like the ears for hearing, eyes to see, nose to smell, and tongue to taste.
So going below the head, we reach a broad region called the thorax or the chest. Thorax is a cage-like structure which houses many of the important organs of the body. These organs include the lungs, the heart, and some parts of the liver. Thorax contents of the organs are separated from the abdominal organs by a muscular structure which lies here, around here, which is not in the model and is known as diaphragm. All these organs are very well protected inside the bony rib cage and the chest musculature from any injuries or harm.
Oh, Prince, you left one organ that's protected by the rib cage and not a part of thorax.
Which organ is it? Is it stomach?
No.
Is it the kidneys?
That's right.
But I can't see the kidneys here.
Oh, kidneys are present at the back, near the abdomen.
Oh, you mean at the retroperitoneal position behind the fluid ribs?
That's true.
Is that the position of the kidneys?
Oh, kids, that is the position of the kidneys.
So now we will examine the contents of the thorax. This is the heart, which is the small fist-like organ responsible for circulation of blood in the body. It is present in the middle of the thorax, but slightly tilted towards the left.
Oh, is that why the left lung is smaller than the right one?
Right. Also observe that the right lung is slightly upward in position than the left lung. This is because it has to make space for the pig liver.
That's right.
So kids, here's my friend Supreet, who is going to summarize the analogy between the car and the human body. Supreet.
Kids, understand that like the metal framework of the car, the skeletal system protects different organs of the body and defines the shape. The rib cage protects the vital organs, whereas the skull protects the brain.
After the thorax comes the abdomen. It houses most of the soft tissue organs of our body. It has the stomach, pancreas, liver, kidneys, and intestines. We will look into the detailed mechanism of these organs as we move to the next part of our lecture.
So I hope till now you guys have understood the working of the human machine as we called it in the beginning. Why then shooting if humans are machines, what is our fuel?
Oh, that's simple. The food we eat is the fuel. And kids, the food has different nutrients like the carbohydrates,
which are the energy giving food,
fats,
the energy giving as well as storing nutrients,
proteins,
the bodybuilding food,
right, vitamins,
and it helps in immunity and our development.
And lastly, the fiber or of age,
which is very important in the diet because it helps in proper digestion.
That's right.
So remember kids, that eating a balanced diet will help you with proper maintenance of human health and functioning.
So going back to a comparison in the mechanical aspect of the car where fuel is combusted to produce energy, a similar process occurs in the human body to produce energy via digestion. This process is divided into namely 5 simple steps, which are ingestion, digestion, absorption, assimilation, and egestion. We'll look into each of these processes briefly.
Yeah, so ingestion refers to taking in of the food. So the food enters the mouth or the buccal cavity, and the buccal cavity has teeth, tongue, and the salivary glands. Teeth help in breaking down the food into smaller particles. Tongue has 2 main roles. Number 1, in sensing of the taste of the food via taste buds present on the surface of the tongue. And number 2, in the mastication of the food and swallowing it.
Mastication is the mixing of food with the saliva in the mouth. Saliva is a very important component in the buccal cavity where the first step of digestion takes place. Digestion is simply the breakdown of complex food substances into simple absorbable forms. Saliva helps in lubrication of food as well as it breaks down complex polysaccharide or a carbohydrate, that is starch, into simple sugars. So Pete, can you tell us what the fun fact about the starch and sugar?
Yes, so you can take a piece of bread and chew it 32 to 36 times. You will find that the bread has become sweet. This is because the carbohydrates in the bread has been turned down into simple sugars. So you must take your time and chew your food as the first process of digestion happens in the mouth.
Following this, the food is swallowed with the help of tongue and it reaches pharynx, which is located over here. And pharynx is a common passage for both air from the nasal cavity and food from the buccal cavity. A cartilaginous flap called epiglottis covers the opening of larynx and it prevents the entry of food into the windpipe. So epiglottis covers the opening of larynx as and when we swallow the food. Now our friend Supreet will give an important message.
Since the flap is common to both the larynx and esophagus, you should not talk while eating, else the food may enter the windpipe and choking could be fatal. Kids, have you experienced water coming out of your nose when someone makes you laugh while drinking? This is the reason why.
Then the food enters the esophagus, which is the food pipe. Esophagus is a muscular tube that begins in the throat and ends at the opening of stomach. The food is pushed down through the esophagus by its muscles rhythmic contractions known as peristalsis. The opening of stomach is guarded by muscular door that prevents the backflow of food into the esophagus from the stomach. To explain peristalsis, let's look at this anime video clip.
The tissue layers that form the walls of the tube include 2 layers of smooth muscle. The contraction and relaxation of these muscles is called peristalsis. One peristaltic wave can be enough to move a bolus down the esophagus and into the stomach. In the intestines, the waves are smaller and more regular. As one section of the intestine contracts, the section in front relaxes. This occurs in the rhythmic, wave-like patterns that create the peristalsis that propels substances forward.
So, in the times of nausea and vomiting, the peristaltic motion of the muscles of the gut helps to remove the contents in the stomach.
The food now enters the next part of the gut called the stomach. Stomach is a bag-like muscular organ where the food resides for nearly 3 to 4 hours and is slowly digested by the gastric secretions. The most prominent gastric secretion is the highly acidic hydrochloric acid, whose pH ranges between 2 to 5, and enzymes like pepsinogen and mucus. The low pH of hydrochloric acid helps in breaking down the complex food substances and also helps in killing the microorganisms that are ingested along with the food. It also activates pepsinogen into its active form called pepsin, which then aids in the breakdown of proteins.
Now, you can ask why the stomach is not affected by the action of pepsin and excoriated by the action of HCl. This is due to the mucous lining of the stomach that protects it.
This acidic broken down food is now called chyme, which is pushed via peristalsis into the first part of small intestine called duodenum. Duodenum is the shortest portion of small intestine, which is C-shaped, which lies near the liver and pancreas. The maximum amount of digestion occurs in this region of the gut.
That's right. Yeah. Like many of us, stomach also has strength that helps in digestion, like the pancreas, the liver, and the gallbladder.
Rightly said, secretions from the liver, which is and from the pancreas, pancreatic juice enters the duodenum as soon as the acidic chyme enters. Bile juice helps in emulsification of fat globules and also facilitates the action of intestinal and pancreatic enzymes for the digestion into fatty acids. Finally, the intestinal juice and pancreatic juice helps in completely breakdown of food components into the simplest absorbable forms, which are carbohydrates into simple sugars like glucose, proteins into amino acids, and fats into fatty acids and glycerol.
Right. Now the simple forms can be absorbed by the intestine. The intestine is folded into finger-like projections called villi, which further has microvilli on their surface. This increases the absorption of the broken down food by many times. You can see the picture of the villi on the screen now. The villi is supplied with a rich network of blood capillaries that help in carrying away the absorbed nutrients.
So guys, do you know that the length of the small intestine varies from 6 to 7 meters? And it can range from 11 to 12 meters across organisms. It depends on the food habit of the organism. Herbivores, which depend on plant and plant byproducts, have intestinal length from 11 to 12 meters, whereas carnivores, like tiger, have intestinal length from 1 to 2 meters. This is because herbaceous food contains cellulose, a plant complex carbohydrate, which is difficult to be digested. It takes an exceptionally long time to be digested with the help of gut microbes, and hence the length of the small intestine is longer in herbivores than carnivores, which depend on meat, which is a rich source of protein.
Now the digested food nutrients are absorbed by the jejunum and ileum region of the small intestine, and the undigested, unabsorbed food is pushed into the large intestine. The large intestine is large in the sense of its diameter. If this is the small intestinal diameter, then this would be the large intestinal diameter. It is basically responsible for the absorption of water and nutrients from the undigested food. Large intestine is divided into 4 different parts, namely the ascending colon, the transverse colon, and descending colon. This colon now opens into a broad region called the rectum, where feces are stored. Also, the large intestine houses many healthy microorganisms which constitute the gut microbiome. Can you tell us about the gut microbiome?
Sure. The gut microbiome is basically an ecosystem that is made up of different types of bacteria that interacts with each other and also with our gut. These bacteria are not harmful as they provide us with nutrients like the vitamins, and they also take up some of the digestive food for their own metabolism. Our gut and the gut microbiome show a type of mutualistic symbiotic relationship where both of them benefit from each other.
Therefore, we are suggested not to take antibiotics for a longer period of time without the prescription of a doctor, because antibiotics have deleterious effect not only on the bad microbes but also on the healthy microbes that are beneficial to us. Therefore, try to avoid self-medication and seek proper medical advice.
Now, the undigested food that reaches the rectum is called feces and is stored until there is an ejection reflex from the brain. As soon as the ejection reflex comes, the feces are excreted out of the body via the rectal canal through the anal opening.
That's right. So kids, we have looked into the 5 coordinated processes, which starts with ingestion, followed by digestion, absorption, assimilation, and finally egestion of the undigested food.
So you've completely understood the digestive processes and its mechanisms.
This is the normal functioning of the body. But at times, have you felt discomfort like pain in the abdomen, constipation, loose and frequent bowels? So let us discuss few of the common ailments of our digestive system to maintain better health and take precautions against these. After all, prevention is better than cure. Do you guys eat spicy and oily food like noodles, chili paneer, momos, kachori and many more? I bet they taste good, but they are an adverse effect on our digestive processes. Spicy and oily food decreases the motility of our stomach and increases the retention time. This causes a feeling of fullness and full stomach called indigestion. This may lead to constipation and diarrhea. So avoid frequent consumption of such food.
At times when we eat spicy food or imperfectly cooked food or some spoiled food, it causes hypersecretion of acid in our stomach, causing acidity. Acidity can easily be understood by abdominal pain in the upper part of the abdomen along with tightness. The simplest way to treat acidity is by neutralizing it by taking some mild-based antacids like Daiichi. There are many other medicines available which are fast-acting like pantoprazole, which are commonly available in the market and used for treating acidity.
The other most common ailment is diarrhea, whose symptom is frequent loose bowel movement. This is indigestion followed by excessive loss of water that leads to dehydration and general weakness in the body. Some of the common factors that leads to diarrhea are bacterial, protozoal or viral infection, indigestion, improperly cooked food or spoiled food. Since they lose a lot of water due to dehydration, we should replenish it by taking in ORS or the oral rehydration solution.
Another most common ailment is typhoid. Typhoid is a bacterial infection caused by the contamination of food. Some of the common symptoms of typhoid are mild fever, loss of appetite, weakness, constipation and diarrhea at severe cases. To prevent typhoid, kids, you must be vaccinated, which is available at your nearest hospitals.
So kids, we hope you enjoyed learning about the human digestive system. We'll meet you soon with another video explaining a different organ system of the human body. Till then,
take care.
Stay safe. Bye. That was a wonderful explanation about human digestive system. I now request Prince to take up a few questions from the audience.
So I can see there are very good questions available. So first of all, the first question is, can we live without stomach? Because I have read a fact about we can live without stomach. Is it right? So yeah, we can live without stomach because stomach has majorly roles in digestion of beginning of the digestion of proteins, while the maximum digestion happens in the small intestine. So if there is no stomach, the small intestine can help take up the function of the stomach. Of course, there will be delay in the digestive processes, but yeah, we can live without stomach. Another question which is there, is thorax bone shaped like ribcage? If yes, can you please tell the difference? Well, thorax is not just the bony ribcage. Thorax or the chest region, it has various muscles and all, and it is present in the chest region. Thorax, the structure of thorax is built via the ribcage. It is a skeletal structure which gives support to the thorax and the internal organs.
Another question is that what kind of muscles are present in the esophagus? Esophagus, just like the alimentary canal, it has the 4 layers of the 4 layers. On the innermost is mucosa. Before that, submucosa. In to that, there are muscles which are usually smooth muscles because they are involuntary muscles and help in the pushing down food via peristalsis. There is another question, why heart is not on the right side? Well, the human body is so intricately designed that because heart is in the left side, therefore the lungs are also present there, which are designed according to that. If the heart is present on the right side, then it can affect the right lung functioning as well. And of course, there will be other defects, conditions which will affect the functioning of the normal physiology of the body. There is another question. What are the names of the 3 segments? So I shall try again.
Yeah. Turn it on again.
Okay. Is it working? Okay, there is another fact-based question. What are the names of the different segments of intestine, like duodenum? So intestine is divided into 3 parts, beginning in duodenum, followed by jejunum, and the last part, which is ileum, which opens into the large intestine. Our next question is, why can't we feel the movement of food in our stomach? Well, stomach is basically a very bag-like structure, and the movement of food towards the duodenum happens very slowly and in very small amounts via the sphincter which is present between the stomach and the small intestine. That is why we do not feel the movement of food from the stomach into the intestine. Question, which is a very good question, is what is the work of kidney? How it gets damaged by alcohol or cigarettes? Kidneys are basically the filters of the body, where it removes the toxic waste that is present in the blood out of the body via urination. Well, alcohol, since alcohol gets metabolized in the liver, it produces certain metabolites which are harmful towards the body. Those metabolites can lower the pH of the blood and thereby affect the functioning of the major organs, which includes liver, kidneys, brain, heart, etc. And similarly, cigarette because it will choke your lungs, will decrease the oxygen absorption in the body, increase the carbon dioxide uptake, and it will decrease the pH and other metabolites in the blood, and will definitely affect the end organ, that is these important kidneys, liver. And
yeah, thank you, Prince, for answering all the questions. We now move on to the last video of our session, which is about environment. With the ongoing climate change, it's very crucial that we understand the environment around us.
Hi friends, Namaskaram. I am Sudhanshu, and today I'll take you through a small but important journey of environmental awareness. We will see and understand how nature is the basis of our existence and why being aware to this fact is the need of hour. Let's begin with few terminologies. The life on Earth happens only because of ecosystems and food chain, a geographical area where all organisms such as plants, animals, human beings and microorganisms, as well as physical surroundings such as weather and landscape, interact with each other and maintain a balance in nature to form a bubble of life. There are 2 types of ecosystem, natural and man-made. Forests and lakes are natural ecosystem, while crop fields and garden are man-made ecosystems. There are 2 components of ecosystem. First is biotic, which consists of living organisms. Second is abiotic, which consists of physical factors. Now, environment is everything that surrounds us. It includes all physical, chemical, and natural forces that act upon an organism and ultimately determine its survival and form. So there are 2 types of environment. First is natural and second is human-made. Natural has biotic and abiotic components or types, and human environment types are social, economical, cultural, and political. Abiotic natural environment consists of non-living entities like water, air, soil, sunlight, etc. And biotic is termed for living entities like humans, animals, birds, microorganisms such as viruses and bacteria. Environmental awareness is understanding or being conscious of the unavoidable fragility of the environment and the importance of its protection. We should have a sense of responsibility towards our environment in order to give the respect and hence the protection and the preservation nature needs. Because we are the inseparable part of our environment and our life existence is totally on it. As we get food from soil, air to breathe, and water to drink, we must understand impact of our behavior to the environment and how a staunch adherence to the eco-friendly activities are helpful in the protection of our planet. The simple and straight answer as to why environmental awareness is needed is it is necessary to stop the harm which human does to nature. Also, sustainable development and encouragement of protection of environmental degradation are only possible through environmental awareness because no awareness means no action. We take actions when we are aware and sensitive enough, which is through the concern and love of the mother nature, and we are willing to contribute. So based on that, there are few objectives of environmental awareness. First, to make one conscious and careful about the environment. Second, to make people understand their role in the environment. And third, to encourage minimal use of natural resources to avoid future disasters. A healthy environment is must for good health and sustenance of life on Earth. So we need to stop harming and start protecting. Our world's resources are under huge pressure, and environmental pollution is the major factor causing it. Environmental pollution causes destruction or disturbance of habitats of plants or wildlife. First is air pollution. Anything in excess in the air that is harmful to our health and to our environment is the reason for air pollution. For example, contamination of air through smoke and dust. From this pie chart, we see that industries, waste burning, and transportation are three major sources of air pollution. Numerous diseases are caused by air pollution, and the top two are lung and heart diseases. Also, as per the statistics, air pollution is the fifth highest cause of death globally, and in India, 2 people die every minute. Water pollution scenarios are too not good in India and in world. Water is polluted when pollutants are thrown into it without removal or adequate treatment of harmful compounds. This happens by discharging industrial waste, oil spills, dumping garbage or raw sewage in rivers, and seepage from the landfills. Variety of diseases are caused by drinking polluted water, like cholera, typhoid, diarrhea, etc. As a matter of fact, more number of people die from polluted water than any natural disaster or conflicts. As you can see in this graph, the unsafe water, the reason for death is so high as compared to the conflicts and natural disaster. Another form of pollution is soil or land pollution, which is caused by presence of human-made chemicals, deforestation, and solid waste disposal on land. Other sources of soil and land pollution are poor agricultural practice like pesticides burning the remains after harvest. So toxic substances like pesticides, waste or etc. they soak in ground and cause soil pollution. Or when it enters in water, it causes water pollution. And when they are burned, they cause air pollution. So this pollution affects human lives in many ways. First, it leads to underground water pollution, which is our source of drinking water. And the pesticide residue are potentially toxic and may cause cancer and adverse effects on our immune and reproductive system. Adding to the list of the types of pollution, the noise pollution are also harmful to human health. The unwanted or undesirable sound to listener is noise. We all must have had the experience of headache and uneasiness due to excessive noise from road traffic, near railway or airport residents, industrial works like drilling, or even noisy concerts. The continuous exposure of noise pollution disrupts our sleep. patterns and hinders child development and can also lead to several psychological issues. Ozone layer is like Earth's natural sunscreen. It protects us from harmful ultraviolet rays. So ozone layer depletion is the gradual thinning of Earth's ozone layer present in the upper atmosphere. This image from NASA shows the ozone layer depletion. It is of concern for sure. Though ozone is poisonous, it is there at higher level of atmosphere and protects us from harmful UV rays, which can cause various diseases to human beings. The main cause of ozone depletion and ozone hole are manufactured chemicals, especially chlorofluorocarbons, which comes out of our refrigerators and air conditioner, and also aerosol sprays. Along with the human health, it can also negatively impact crop growth and phytoplankton growth, can also lead to increased diseases. Earth's natural greenhouse effect is required. This is required to maintain Earth's average temperature for life. This is done by trapping heat by gases like carbon dioxide, methane, nitrous oxide, water vapors in the atmosphere. But intensified greenhouse effect cause global warming. Global temperature rise and hence melting of a glacier take place. This lead to serious threat to biodiversity. So global warming is an increase in Earth's average temperature due to increase of greenhouse gases in the atmosphere. As you can see, comparing to the decade of 1980 to 1990, in the past 30 years, the average temperature has risen by around more than 2 degrees Celsius. So our planet is kind of burning. Globally, 1 in every 9 don't have access to potable water to drink. 80% of illness is due to unsafe water, and 50% of developing nations like Brazil, Bangladesh, India, Nepal, Pakistan, Philippines, etc. The primary schools do not have access to water and sanitization facilities. In 2018, pollution alone killed 83 lakh people globally, and India and China are top 2. So do you know that Delhi and Mumbai are among the top 10 noisiest cities of the world? The consequence of environmental degradation is climate change. Climate means long-term pattern of weather in an area, around 30 years average pattern. Climate change is long-term change in Earth's climate or of a region on Earth. As a result of all this pollution, the consequence is climate change. And the effects are rising temperature, rising sea level, unpredictable weather patterns, increase in extreme weathers like we have in summer, too hot summer, and in winter, too cold winter, and land degradation and loss of wildlife and biodiversity. EPI is Environmental Performance Index. It is a quantitative comparison and analysis of 180 countries for their environmental performance. And India, out of 180, ranks 168. And also India is worst in health and air quality. As you can see, the ranking is 172 and 179. Plastic pollution is even worse. It is killing around 10 lakh, 1 million lives every year, marine lives every year. Less than 9% of the plastic actually got recycled. So this is the result we are having. We heard and saw how dangerous our activities are for our own existence, and let's know some solution rather than answer. First thing is we need to reestablish our connection to the nature that has been lost due to heavy industrialization and technological boom. Our mobile phones, laptops are our all-time environment. We become more sensitive to a notification than any nature's part like animals, birds, plants, etc. Let's reignite the compassion within us for every part and parcel of the mother nature. We should learn from notable movements in history like Chipko movement, where people have staked their life to save trees. we should consciously work on our need or resources and minimize to basic level. Let's work on the 3 R's, that is reduce, reuse and recycle. At our level, we can think of steps and ideas to orient our life more towards eco-friendly direction. Let's look at some of it. First is let's avoid burning garbage. It's a bad idea, of course. Next, be wise while you throw your garbage. You should know which type of dustbins are used for which type of waste. This is segregation of waste. Plant saplings and take care of them till they become trees. More of public transport. And if you're having or thinking to have a private transport, buy electric vehicles and promote electric vehicles. Save water by any way possible. Here are some. Choose a closed taps while brushing and soaping hands. Also, minimize the use of plastic and plastic waste. Use cloth bags for shopping and avoid single-use plastic items like water bottles, tea cups or juice glasses, etc. There are dedicated days for environment, water, etc. These comes to make us conscious of our living ways and realize if we are doing enough at our level for the environment. Let's make a green mask for our planet Earth. Just like plantation drives by school are fun, one can involve in many other nature connecting activities like forest exploration. Of course, this should be under professional guidance. Trips to relaxing and rejuvenating waterfalls. Karnataka has some amazing waterfalls like Shivasamudram. Trekking is another great experience. The landscape beauty of mountains, rivers just gives a sense of peace and serenity. Of course, the excitement of seeing the world from the top of a hill is always a great feeling. In India, we can find places where under guidance, you can go a little deep in the sea or ocean and observe a totally different world of existence. Please do it when you get a chance. So that's all I had for you. Thank you, my little brothers and sisters, for your time and attention. I hope I was helpful.
I now request Sudhanshu to take a question of you.
Hi everyone, I'll take a few questions. So first question is, why is plastic use harmful for our environment? So the simple answer is plastic never goes away. It takes thousands of years for the plastic especially to break down into something degradable. And the chemicals are very toxin and are toxic, and they affect our groundwater, affect our food chain, and etc. So the chemicals are very toxic in the sense. And second question is, what is greenhouse effect? So Earth's natural greenhouse effect is very much required for our life sustenance, because greenhouse effect is basically is warming of our Earth's atmosphere, where it maintains a certain temperature for the existence of life. This is done by the gases present in the atmosphere, which traps the heat, like CO2, water droplets, and methane, etc. And define bioaccumulation and biomagnification. Okay, so biomagnification is the increase in concentration of toxic or pollutants when they are transferring from one level of food chain to another level of food chain. And bioaccumulation, on the other hand, is in a single organism's body when the pollutants level is increasing. That is called bioaccumulation. Is ozone layer compulsory need for us? What happens when ozone layer is depleted? Okay, so ozone layer, it absorbs harmful ultraviolet rays type V, ultraviolet rays type V. There are also ultraviolet rays which are reaching to Earth like A and C. So this is required because if it is not there, it can cause skin diseases and other issues.
You can take up one more question if it's there.
So why is the ozone layer present at stratosphere and why not in the troposphere? Okay, so I mean, I have a simple answer. This is how it is. The nature is. I mean, yeah, it is present there because it may be stable there for its existence. That's the answer I can think of. Yeah. Thank you.
Thank you, Siddharth. This brings us to the end of this delightful set of sessions on science around us. I hope videos have motivated you to try on some hands-on science experiments sitting at home. We would love it if you could share with us the different experiments that you try at home. In this regard, we have designed a competition for you all as mentioned in the morning session. Ashok here now will again explain to you the instructions related to the competition.
Yeah, guys, the competition has been organized where you can use the household stuff which is mentioned in this list which is on the screen right now. Are you able to see this table where you can see the household stuff? Household stuff that you can use to build some simple experiments. And using these things here as there are the guidelines presented which I have been selected. The first thing that you need to select the component from the list. If some of the components are missing, you can think but try to use from the list itself. For mobile recording would be sufficient. Try to record video less than 3 minutes, and you need to explain the concepts. I mean, whatever you understood, just try to avoid take help from any available internet media or YouTube. And then you need to the event, this video submission link will be activated from the 6th to till 25th, and we have some exciting prizes that worth of trying. So yeah, that's all. Then you please try to submit a video as early as possible.
Okay, guys, so now we have reached to the end segment of this event. So I would like to mention that this is the first time we have tried something digital, this outreach, and it's at a national level. So our main objective was to convince you that you guys can learn science using household stuff. So we have designed this competition in that regard. So please go through that competition guidelines and submit your videos. The best videos will be rewarded. And finally, I would like to thank our organizing team, all the demonstrators, and the whole team of Science for Rural India, who have put months of effort to make this event possible. And also, I would like to thank Indian Institute of Science for supporting us organizing this event, and also KSCST for helping us in many fronts, and Office of Communication, IASC. So also, finally, I would like to thank you guys for patient listening. I hope some of you got motivated and you'll try some of this scientific stuff at home. And also, we would like to hear your comments and feedback. So please drop a mail at kidszoneiisc@gmail.com, or you can visit our website and drop your feedback there. There's an option. So that's all with this. So keep learning and happy Teachers Day. And now we will play our end credits that will show how many people have put all the effort to make this event possible. Thank you very much.